Welcome to my complete guide on Angular. So great to have you on board. In this course, you're going to learn what Angular is and how you can use it to build awesome front-end web applications with it. Very reactive web applications with great user experiences. For that, throughout this course, you're going to learn all the individual building blocks which make up Angular, before we then also dive into the more advanced features. And we're going to build a project throughout the course, putting all these things you'll learn in theory kind of, and which you practice throughout the course, into the perspective of a real project so that you can see how you would apply them there and that you can see how you build up a real web applications with the things you learn here. So with that, I'd say let's dive into it, and let's dive into the most important question first. What is Angular? Angular is a framework which allows you to create reactive single-page applications. A nice sentence, but what exactly does it mean? A single-page application is an application like this, the project we're going to build throughout the course. You can navigate around there, and in the URL you can see that we seem to visit different pages, but in the end, our page never changes. It's only one HTML file and a bunch of JavaScript code we got from the server, and everything which you see here, every change, is rendered in the browser. Now, why is that awesome? Because it gives the user a very reactive user experience. JavaScript is much faster than having to reach out to a server for every page change and for every new piece of data you want to display. And therefore, this approach allows you to create web applications which look and feel almost like mobile applications. Very fast, everything happens instantly, and if you do need some data from a server, you simply load it in the background so that the user never leaves this experience of having a reactive web application to use. So every click I do here simply changes this one single page we're using, this one HTML page. And how is that done? Well, JavaScript changes the DOM, changes whatever is displayed here, changes the HTML code during runtime, so to say. That is why you never see that refresh icon on the top left spin, because we're only changing the currently loaded page. And you can even see that if you inspect the source code of a page like this. That is the HTML file, and as you can see, it doesn't seem to contain the content you are seeing on this page. We only have one single HTML element, which doesn't seem to be a built-in one, a native one. But that's Angular doing its job, and throughout the course, you're going to learn what exactly happens here and how Angular does this job. Now, one thing that can be confusing when you're getting started with Angular is the amount of Angular versions you find out there. Now, in this lecture, we'll have a look at the different versions, how they are connected, and if that means that Angular changes all the time. Spoiler, it does not. So we had Angular 1. It was released a couple of years ago, and Angular 1 was a big new thing back then. Now, this course is not about Angular 1 though, because whilst it was the big new thing, it also had some issues that could lead to worse performance and bigger applications and so on. This version of Angular, Angular 1, is nowadays referred to as AngularJS, written like this. So if you see people write AngularJS in some internet forum, on Reddit, or anything like that, they are most likely referring to Angular 1, which is totally different to the Angular version you're learning about in this course, because there was a complete rewrite of the Angular framework between Angular 1 and Angular 2. Angular 2 was released in 2016, and it was rewritten from the ground up. It works totally different than Angular 1 to fix all the issues Angular 1 had. Now, since then, since that initial release of Angular 2, we had a couple of other versions of Angular. We had Angular 4, Angular 3 was skipped for internal reasons, so that version number was skipped. We had Angular 5, 6, 7, and now we have Angular 9. Why do we have all these Angular version numbers? Does it mean that Angular was reinvented 8 times since Angular 1? No. This is not the case. Instead, since the release of Angular 2, the Angular team simply adheres to a versioning scheme where a new version of Angular is released every 6 months. Now that new version, however, is not a complete rewrite. It does not change everything. Indeed, most updates change almost nothing, only some behind the scenes stuff, or add some new features without breaking existing features. Indeed, Angular 9 is pretty much the same as Angular 2. I initially created this course for Angular 2 and I updated it multiple times, and it is totally up to date therefore. But when we have a look at the core syntax, at the philosophy and so on, nothing changed since Angular 2. Indeed, if you learned Angular 2 in 2016 and you then slept for 3 years, you can still use the exact same syntax. Some minor things changed, and I updated the course over the time to reflect that, but overall it's the same framework. We have small, incremental, backwards compatible changes between these versions. It's simply just a commitment which the Angular team made to release such a major new version every 6 months. It does not break or change everything every time it's released. And therefore we have AngularJS, this version 1 thing, which is totally different. And then what we just refer to as just Angular. Angular 2, 4, 5, 6, and so on. This is all just Angular. You shouldn't really use the version because in 6 months it will be outdated anyways. Instead, it's just Angular. And this course is just about Angular because, as I said, Angular 9 is basically the same as Angular 2. And Angular 10 will be the same as well. We just will see small improvements over time. That's the idea behind these versions. So now with the definition of Angular and the different versions out of the way, let's simply dive into it and let's build our first Angular app. For that, we'll use the official Angular command line interface, CLI. And that is the recommended and best way of creating Angular projects because Angular projects are actually a bit more elaborate regarding their build workflow. There are a couple of files that need to be converted before they can run in the browser. And this CLI does all of that, and it also heavily optimizes our code so that we ship a highly optimized code version to the browser once we finally deploy our app, which we'll also do in this course in the end, of course. So, the Angular CLI, and you can see all the steps you need to run on the left here. And these steps are the same for Windows and Mac. Now, for them to work, you need one additional tool, and that's Node.js. Node.js is a server-side language, and you might be wondering, what are we doing with it in this course? It's an Angular course, not a Node course. And you'd be right, we won't write any Node.js code here, but Node.js will be used behind the scenes by the CLI to bundle and optimize our project, and we'll use NPM, the Node Package Manager, to manage the different dependencies an Angular project has. Dependencies are things like the Angular framework itself, but also some other libraries that framework uses. So you can simply download the latest version here by clicking on that button. In my case, it's 10.0, but that might differ for you. And you will get an installer for which you can walk, which will conveniently install Node.js and this NPM tool on your machine. Once you finish the installation, we can run these commands, and we run them in our terminal or command prompt. Now here I'm on a Mac, therefore I use the normal terminal. If you were on Windows, you would open the normal command prompt. Possibly open that as an administrator by right-clicking on the executable and clicking Run as Administrator to rule out some potential issues. But in the end, you should be able to simply run npm using that Node Package Manager, install -g to install it globally on your machine, at Angular/CLI at latest. At latest is optional, at Angular/CLI is not. So you absolutely need to run this. Now on Windows, this should just work. On Mac or Linux, you probably need to add a sudo in front of this to give yourself the right permissions. Hit enter, and now I'm prompted to enter my password. You may or may not be. And once you confirmed everything, this should now download the Angular CLI from this Node Package Manager repository and install it on your machine. Now, as you can see, you might get some errors in between, like I'm getting here. You may ignore them as long as it successfully installed the CLI, as you can tell by the output here at the bottom. So it updated 2 packages, or added them if you installed it the first time, and you see the CLI and the version installed. Now, the version can differ depending on the time when you installed this, by the way. The general functionality will not differ. So this did work. Now with that, we can create our first Angular project. And for that, in the terminal, in the command prompt, first of all, navigate into the folder on your system, on your computer, where you want to create that project. You can go there with the cd command. This is a command which is available on macOS and Windows. And with that command, you can navigate into any folder which already exists though. So it must be a folder which you already created. In my case, I'm going into the development teaching Udemy folder. But again, that is a path which I created ahead of time. Simply go into any folder where you have read and write access to. And once you're there, once you're in that place where you want to create your Angular project, you can create it with this ng-new command, which you also find on the official web page. So here in that folder where I want to create this project, I will now run ng-new, and then any project name of your choice, a new folder of that name will then be created in that folder where you're running this command. And I'll just pick my-first-app here as a name. You can pick any name, but it shouldn't contain any white space, and it shouldn't contain the word test. But other than that, you're free to use whichever name you want. And then also important, add --no-strict here. A strict mode is a special mode in which we can create our projects, and we'll look at strict mode or at optimizing our projects later in the course. But to get started and make it a bit easier for us, we'll start in non-strict mode here. And then you can hit enter, and this will create a new Angular project for you. Now you're then asked a couple of questions, whether you want to add Angular routing, and here you should choose N for no, we don't want to add it yet. We'll dive into it later in this course. And which style sheet format you'd like to use for writing your styling code. And here I'll use standard CSS, so I will confirm this default selection here for me, CSS. And now this goes ahead and creates a new Angular project. And as I said, we need this more complex setup because, for example, Angular uses TypeScript, a superset of JavaScript. So basically a language that looks a bit like JavaScript and is compiled down to JavaScript in the end by that workflow, but which also offers some extra features. And to do that compilation, as well as a couple of other optimization steps, we need this more complex setup with all these dependencies. Now, once this finished successfully, and if it didn't, check out the lecture prior to this video here. I do share some common gotchas and fixes there. So once this finished successfully, we can navigate into that with the cd command and then the name of the project. In my case, it's my-first-app. And once you're in there, you can run ng-serve to basically bring up a development server that will run your built and for development optimized app so that you can see it in the browser. The server runs on localhost 4200 by default. You see the output here. So you can simply go to the browser, enter localhost 4200, and you should see something like this. This is just a simple starting screen provided by the CLI project. Welcome to app, and then some useful links to the official docs and so on. Awesome. Now, the screen you're seeing actually also might look something like this. The starting screen simply was updated with newer versions of the CLI. This does not impact what you learn or the version of Angular you're using. Everything you'll learn in this course is fully up to date with the latest version of Angular. I kept this course up to date in the past. I will do so in the future. It's only that starting screen that changed. Now, in order to follow along smoothly, attached you actually find the app component HTML file. And you can simply go into your Angular project that was created on your hard drive with the ng-new command, and there into the source folder, the src folder, into the app folder, and then simply drag the attached app component HTML file in there and replace the existing app component HTML file you find in there with it. And with that, if you reload localhost 4200, you don't even need to restart the server. You find the same looking starting screen I have here. Again, that's just for you to follow along smoothly. We'll work on these files in the next lecture. So we'll dive into what you got there in this folder and what this app component HTML file actually does. This is just so that you can follow along without problems. Angular itself has not changed. It's just this starting screen. Now this is our first application. Now we set this up. Of course, not too much is happening here. So let's edit this first step and do something more fancy with it, and also understand what exactly the CLI created in the next lecture. In the last lecture, we created our first Angular app, but we haven't changed anything there. So time to do that. And for that, you need an IDE or editor where you can write and edit your code. Now I'm using WebStorm here. WebStorm is a great IDE, great for Angular development, but it's not free. A great free alternative would be Visual Studio Code, which you can find on code.visualstudio.com. This is a great IDE and it is free. You can simply download and install it both for Mac and Windows. And then you can start developing Angular with that. Whichever IDE or editor you install, you'll always have to open a new folder. In WebStorm case, it's just called open. And then simply navigate to the folder you created. So in my case here, it's my first app. Select that folder and open it. And now it will load that folder and all the files into the IDE on your system. So in my case, it now looks like that. Now this is the project loaded into the IDE. Now it's still indexing it here, but it'll be done in a second. And these are all the folders and files the Angular CLI created for you. This is your entire Angular project. Now, as I said, this might look intimidating because you got so many files in there. Most of these files are just doing some configuration work and you don't really need to touch them. One interesting file is the package.json file. Here you can see all the dependencies of your project, like Angular 6. And these are these third-party packages your project needs to run correctly. All dev dependencies are only required for development for this build workflow I was talking about. But we're here to edit our code, right? So let's jump into the source folder because that is where our code is. E2E is for end-to-end testing. We'll ignore this. And node modules is where all these dependencies you see in the package.json file actually were installed. But we're interested in the source code, so let's go to source. Then we got a bunch of other configuration files. And then here, we got this app folder. And in this app folder, we see some other files. Of course, I'll dive into what they all do in detail in this course. And for now, let's open the app component HTML file. And here we indeed see something which looks deceivingly like what we saw in the browser. Do you remember? It's welcome to app and so on. We see that here too. By the way, make sure you keep that localhost 4002 process running. So that ng-serve process you started here in the terminal. Make sure to keep that running. If you're done with development for the day, you can quit it with Ctrl-C and you'll get out of there. But as long as you are developing, you should keep it running because it will automatically watch your files and rebuild your project whenever you change and save something. Now, since I quit it, I'll need to restart it. And I will actually restart it here in my IDE. There's a built-in terminal, but it's the normal system terminal. So here I can also run ng-serve to bring that back up. But back to the app component HTML file. We're outputting something here. And if we change anything here like, hi, this is instead of welcome to, and we save that with ng-serve running, if you go back, you see it automatically updated, hi, this app. Now, one strange thing we see is that this app here, well, we actually only see these curly braces and title in the app component HTML file. And therefore, we can already see some of the work Angular does here. Angular is, of course, not a tool to allow us to write static HTML files. We would need no framework for that. It allows us to mix static HTML code and dynamic things we want to output in that code. And actually, what we have here is one of these components Angular works with, the app component. A component always has a template, the HTML code, possibly has some stylings in the CSS file, though it's empty here, as you can see. And importantly, it has a TypeScript file. If we enter this is TypeScript.
And this is now the definition of the component. This is what will be converted to normal JavaScript by the build workflow. And in this file, we see a couple of interesting things like add component. I'll come back to that and what in detail is happening here in the next module. We also see title equals app. Now, what's that? If we go back to the app component HTML file, we also saw title here, right? Between the curly braces. So an assumption would be that the title in the TypeScript file is related to that. So let's maybe change this to my app. And now if we save this, it recompiles, and if we go back, we see, hi, this is my app. Now, this might not be perfect English, but we can definitely see that something changed. And this is so-called data binding in action. Of course, also a concept we'll dive in deeply in this course. And this is how we can output dynamic content, and this could, of course, be content that is calculated dynamically or retrieved from a server in our HTML code. Now, interesting, if we right-click on the loaded page and inspect the page source, we don't actually see that code there. We just see a bunch of script imports at the bottom. That is our build code and the Angular framework code. The head tag here, and then this strange app root part. Now, app root is also something we see in the app component TypeScript file. Here, the selector. So it looks like this is basically like our own HTML tag we're creating. And that's indeed what's happening here. The page we're viewing here, to which this source belongs, actually is this index.html file in the source folder. Here we also see app root. The script imports are missing because they are injected dynamically. Now what Angular does in the end is we always load this page, then we have these dynamically injected script imports, and these script imports will dynamically replace app root with our own component. And of course, we can have more than one component in Angular apps. Again, these are all things we'll dive into in this course. Now that's all nice. Let's do something more fancy. Let's change title dynamically. So back in the app component, I'll actually get rid of the entire code in here, and I'll add an input instead, a normal HTML input, type text. Below that, I'll add a paragraph where I want to output, let's say, a name. Now, name is not something we defined yet. We'll do so in a second. Let's go to app component, and let's change title to name. And I'll say Max here because that is my name. And if I save that, I go back, we see the input and we see the name. Now I want to be able to enter something in the input and automatically change the name. And we can do this with a tool provided by Angular, a so-called directive, which is called ngModel. Now you'll learn the exact syntax throughout the course. For now, let's simply add square brackets, parentheses, ngModel, written like that. Make sure to get the casing correct. There is no dash in between or anything like that. So ngModel in square brackets and parentheses on the input, and set it equal to name. So to the same name you're outputting here. Now this is a so-called directive, and what it does is it basically tells Angular to listen to anything you enter here and store it in this name property, in this name model, but also on the other hand, output the value of the name model in this input. This is what we're doing here. Now, if we save this, we don't see anything on the page, and if we open the developer tools, which you can simply do from the menu or with the shortcut, you reach it under View, Developer Tools in Chrome, and I strongly recommend using Chrome for this course since it has the best developer tools. So then we see here in the console part, there's an error. Can't bind to ngModel since it isn't a known property of input. So somehow Angular doesn't understand ngModel. Now that's strange because I said it's built in, right? Angular is actually split up into multiple modules, sub-packages you could say. And we need to add them if you want to use a certain feature from them. And in this course, you will learn about the different packages and which features they contain. To add such a feature, we go to that other file we haven't had a look at yet, the app module. This is basically where we tell Angular which pieces belong to our app. And there we have to add something to imports, to import another package from Angular. So we need to import it at the top of the file first, because TypeScript always needs to know where things are. So we import something from, and then it's at Angular/forms. This is one other package from the Angular framework. And from that package, we can import the forms module, written like this. So make sure to add this import. This is not an Angular feature, but a TypeScript feature. As I said, TypeScript needs to know where the things are. But now with that imported, we can add it to this imports array down here, which is not related to the imports up there. This is simply a feature understood by Angular, since it's part of an Angular module. And now it tells Angular that we want to import some forms features. And this directive we're using is such a form feature. So now if we save that, our app will rebuild. And once it is done, we can go back. And now we see our input, and there's Max inside of it. And if I start typing there, you see that the text below it automatically also updates. This is some magic done by ngModel. We'll dive much deeper into everything we learned here. But this is now our first app with some changes. What does this course offer you? We're just getting started and we just built and edited our first Angular application. But of course we didn't fully understand what we did there. So that's why in the next lecture we're going to dive into the basics of Angular. What are components? What did we do there with this two-way data binding and how does that all work? This section will answer it and we'll take a very detailed look at it, and we'll also explain how all these files you saw in your project are connected to each other. Well, then we're going to have a look at components and data binding, two important key features, and we actually saw both already in our first application. Angular apps are built up from components, and data binding is simply how you output data in your DOM in the end, or, as we will also learn, react to user events. Angular has another key feature, directives. ngModel, which we used with two-way data binding, actually is such a directive. And you will learn more about the built-in directives in this section, and also, very important, build your own directives. Nice little helpers, instructions you can place in your templates, in your HTML code, which will then do something at runtime depending on the commands you wrote in there. Well, and after having a look at this, we're going to learn more about services and dependency injection, a core feature of Angular, which makes it really easy for you to have your different pieces in your app communicate with each other, to centralize code, and really to manage the state of your application. Once we're finished with that, it's time to have a look at routing, because thus far we will only have been on one page. Well, we're always on one page since it's a single page application, but to the user it really looked like one page. With routing, we introduced the management of different URLs so that to the user it looks like we're switching pages, even though technically we will still remain on that single page. Sounds great? It is, and routing shows you how it works. Then it's time to have a look at observables, something which will make more sense once you've been to the routing section. It is a concept allowing you to work with asynchronous code. Angular embraces it. It's really powerful, and this section explains how it works. Then we'll have a look at forms, because handling forms, handling user input is a key task of almost any application, and this section takes a very close look at it. After we're done with forms, we're going to have a look at pipes, another nice feature which makes it easy for you to transform the output, so what you display on the template at runtime. Well, we're nearing the end, but not before having a look at HTTP. What if you need to reach out to a web server? What if you need to store some data in a database? Angular can't connect to a database directly, but it can connect to a server which is able to, and the HTTP section shows just that. Thereafter, we'll have a look at authentication. What does authentication mean in an Angular application? How does it work? And once we're at it, let's simply implement it in an application. Then we're going to have a look at some optimizations we can put into place and how we can manage different modules in our application, something you will really understand once we are at this point. And then we're going to deploy an application and learn how we can get our Angular application from our local machine to a place in the internet where we can view it. And if that's not enough for you, we're also going to have a look at animations and testing Angular applications. And besides that, throughout the whole course, we're going to build a real project, putting all these things you'll learn in the individual sections into practice, and therefore seeing how they are used in a real project. So with that, I feel very confident you're going to be an Angular master after finishing this course, and I can't wait to start this journey together with you. Now that we had a look at what this course offers, let me explain to you how you get the most out of it. Of course, you should watch the videos, go through the lectures, and I do my best there to explain how Angular works, why it works like this, and how you use the different features together. But besides the lectures, I got a couple of assignments in this course, practices, exercises, and I urge you to do these exercises. I designed them to be challenging but doable, and these assignments allow you to check if you understood a certain concept and to really practice it and get more comfortable using it. Well, besides the assignments, we're going to build a whole course project, and I can only invite you to build this project with me and also sometimes pause the video and build a feature we're about to implement together on your own first. This really is a great exercise too, and it might also be very interesting for you to expand this course project beyond the things we built here to add new features to it. Well, and if you're stuck somewhere or if something is unclear, there is the Q&A section, and I'm very happy to help you there and answer any questions you might have related to this course. However, you will learn even more if you not only ask, but only if you answer. Dig through the Q&A section and try to help other students too. Why? Because by answering, you are really challenged to think about a problem and to come up with a solution. And it doesn't really matter if that is then the best possible solution. If there is a better one, someone else is going to correct you, and then you learn again. But by thinking about it in the first place, you really go through the concepts you learned and you apply them to a real problem. So that is how you will learn the most. And besides that, how strange it might sound, the official documentation and Google is your friend, especially if you get some strange error messages. Simply Google for it, and not because I'm too lazy to help you, I will help you, but because it's so much faster than waiting for my reply or for the reply of someone else. Most of the error messages were encountered by other people before too, so chances are great that you get an answer by simply searching for them. And by following these advices, you should learn a lot about Angular in this course. No worries, we're about to get started soon, but I did mention that we're going to use TypeScript in this course. We already did use it when we changed the first app. What is TypeScript? TypeScript really is just a superset to JavaScript. It offers more features than vanilla JavaScript, like classes, interfaces, and very important, which gives it the name, types, strong typing. So you define in TypeScript if a certain variable is a number, a string, or something else. You don't do this in vanilla JavaScript. There you have dynamic typing. You can have a string variable, and then you assign a number, and that's totally fine. That won't work in TypeScript, it will give you an error, and therefore it allows you to write much more robust code, which gets checked at the time you write it, and not just at the time you run it. A great enhancement. However, TypeScript doesn't run in the browser, so it is compiled to JavaScript in the end. And this compilation is handled by the CLI, one of the reasons why we need the CLI, why we need a project management tool like the CLI. Now, this compilation is really fast, and therefore in the end in the browser, JavaScript is going to run. We're not writing the Angular app in JavaScript though, because whilst technically possible, that won't be much fun. A lot of the features really only exist in TypeScript, and Angular is meant to be used together with TypeScript. That being said, you don't have to learn TypeScript for this course. You should be able to pick it up along the way, and I do have a whole section giving you a brief introduction into TypeScript at the end of this course, so feel free to jump ahead there, go through that section right now if you feel like you need that, or throughout the course if you feel like you need some deeper dive into some of the features you see there. And you should be fine, you should be able to follow along just fine. Of course, if you feel like it, feel free to pick up another course or tutorial focused on TypeScript so that you have something to look at if something is unclear in this course. Generally though, TypeScript is an addition to JavaScript, not a complete replacement, so a lot of the commands will look really familiar. Throughout this course, I'll often start with an empty project for a given section, so that we can focus on the topic at hand in this section. So therefore, you can simply create a new project with ng-new, as we did it a couple of lectures ago. And I'll typically start with an empty app component HTML file. If I have a different starting setup, you'll find it attached to the lecture, so I'll always ensure that this is the case. But here, I'll now simply have this empty setup. We can now remove forms module from app module here, in case you added it, so that we really have a clean starting project. And now there's one important thing. In this course, I'll use the Bootstrap CSS framework to have some nice CSS styles out of the box without us having to write all these CSS styles. Now to add this, we need to install it, we need to download it. We can do this by quitting this development server with Ctrl+C and then installing it with this npm tool, this node package manager, by running npm install --save bootstrap, and now that's important, add free to install version free, which is the version I use in this course. Now this will install it locally in this project, not globally, locally. Simply hit enter and it will download Bootstrap and store it in that node modules folder. Now that's one first step, but to be able to use it, we also need to make Angular aware of this styling package we want to use. And we do that in one of the config files, the most important one actually, the angular.json file. This configures the CLI project. We will not work in this project file throughout the course because the default setup is perfect and we don't need to change anything there. But one thing we do need to change right now is the styles we want to use by default. Here you got this styles array in this architect build node. Now it already has one entry, source styles CSS. This is a file you can use to define some global styles you want to use application-wide. So you can enter any CSS code here, and it will be used in every Angular component. But in my case, I will add another import prior to that source styles CSS import, so that we could overwrite it within this file. And now here we need to point to node modules, so to this node modules folder we got there. And there, if you scroll down a bit, there are many dependencies because you also have dependencies of dependencies here. If you scroll down a bit, you'll see Bootstrap. And in there, you find a dist folder, a CSS folder, and there the Bootstrap CSS file, or to be precise, there also is a bootstrap.min.css file, just hidden a bit by my IDE. So we can enter node modules /bootstrap /dist /css /bootstrap.min.css and make sure that you got no typo in here. It's easy to miss the T or something like that. So make sure that you have a path like this. Once you added this path here, save your package.json file and rerun ngserve to load this new configuration. As I said, you don't really need to change anything else here. The default configuration should work perfectly. So once you're done, you can visit localhost 4200 and you won't see anything because I deleted all the content in the template.
But if you open the developer tools and you go to the Elements tab there, here in the head section, you will see that the styles CSS file is being imported. And if you go to sources, you should find that styles CSS file here. And in there, you will see that it's mentioning Bootstrap, which basically means that everything worked and Bootstrap is included here. And with that, you know that everything we do in the course will work and will have the correct styles. Now one last change, in the app component, I'll also get rid of whichever property we have here. With that, the starting project is prepared. You can always use that at the beginning of a new module, and important, you also saw how you can add your own styles. So now that we got started with this course and with Angular and our project we're going to use in this course, it's time to dive deeper into Angular to understand what it really does, what happens behind the scenes, how an Angular app gets started in the first place, and which base building blocks it offers us, how we can build Angular apps, and which features we may use for this. By the end of this section, you will understand how you can build your basic Angular application, what it then does, and what you need to change to reach a different result. So with this, let's dive into it and let's start by having a look what actually happens when we visit this page in the browser, when we reload this page. How does Angular get started? What do we actually see here besides nothing? Because there is more to this page than it might look like.
So this is the page as we see it right now in the project we created at the end of the last section. An empty page here, Angular the Complete Guide, we reach it at localhost 4200. This is where our development server hosted by the CLI or spun up by the CLI will host our Angular application. Now, the content we see here can be changed by going to the app component HTML file in our app folder. And in here, we can output some text. Let's say in the app component here in a h3 tag, a normal HTML tag, therefore. If we save this, we will see it here. And it automatically has the bootstrap text style and so on because we added bootstrap at the end of the last section too. But whilst it might seem kind of obvious that we see it here, it is also kind of strange. How does our browser or how does the server hosting our app know that it should render the content of app component HTML here? You could argue it's the only component we have right now, and we will take a closer look at components soon. But that is not the reason. And actually, this is not the file served by the server. Instead, the index.html file here is served by the server. And remember that I told you that Angular is a framework which allows you to create single-page application? This is the single page which is served, the index.html file. Now, if we have a look at this file, we see this is a normal HTML file. We define the title we could see on the tab in the browser here. And the body of this file is very interesting. Here, we get this app root thing with loading ... in between. Now clearly we don't see loading ... here. So somehow this index.html file seems to have changed. And it did. App root here of course is not a default HTML element, instead it is one of our own components. We will soon dive into how we create our own components, but the CLI created one for us, the root component of our application, the component which will tie together our whole application in the end. And all the files in the app folder here, which have component in their name, so these files are related to this component. I will go into more detail about these files in one of the next lectures. For now, let's take a closer look at the app component.ts file, the TypeScript file here. Here you can see that we have this add component decorator. This seems to be important, but more importantly right now you see that there we have this selector property which assigns a string as a value, and this string holds app root. Now this clearly is the same text as in our index.html file, and this actually is the information Angular needed to be able to replace this part here in this index.html file with the template of this component, the component having this selector, and the template of this component simply is the content here in this app component HTML file. Now, whilst I will dive deeper into how to create components and how to configure them, this is what basically happens at the startup. Though the missing information is, how is Angular triggered? How is it kicked off to actually run over our body here of this index.html file? And the answer is in the final index.html file getting served in the browser, and we can verify this by inspecting the source code here. We get a couple of script imports at the end. These are injected by the CLI automatically, so that is why we don't see it here in the raw index.html file. Here we don't have any script imports, but whenever this ng-serve process rebuilds our project, it will create bundles, JavaScript script bundles, and automatically add the right imports in the index.html file. A little convenience functionality for us. So in the final file, these script imports here are present, and these script imports will contain our own code too. So these script files are therefore executed, and they are actually the first code to be executed, and that is just something you have to keep in mind, is the code we write in our main.ts file. That is why it's called main. This is the first code which gets executed. Let's have a closer look at it then. Here you see that we get a couple of imports, then we check if we are in production mode or not to basically turn off some warning messages, I can tell you that. But most importantly here, this line. This now bootstraps starts our Angular application by passing an app module to this method. And app module refers to this file here. Now, if we have a look at this file, here we actually see that somehow we kind of like with the component have this strange add thing here. I will dive into this in a couple of lectures too. But most importantly for now, here we got this bootstrap array, which basically lists all the components which should be known to Angular at the point of time it analyzes our index.html file. And here the circle closes because here we reference our app component. So Angular gets started, this main.ts file gets started. There we bootstrap an Angular application and we pass this module as an argument. In this module, we tell Angular, hey, there is this app component which you should know when you try to start yourself. And Angular now analyzes the app component, reads the setup we pass here, and therefore knows this selector, app root. And now Angular is able to handle app root in the index.html file, and it knows, all right, this is the selector I know. You told me that I should know it because it was listed in this bootstrap array in the app module, this component. So now I know that here I should insert the app component, and the app component happens to have some HTML code, a template attached to it, which is this h3 tag. And this is how the Angular application starts here. This is why we see what we see. Now, there was a load of information regarding the app startup, but it's key to understand how this starts. With this information, we can now proceed and dive deeper into how components actually work, what they are, how we can create our own ones, and what this app module here does in detail. So let's move on. In the last lecture, we had a closer look at what happens at the point of time we visit localhost 4200 here in the browser. We understood that the index.html file is served, that it will contain a bunch of scripts here which get executed, which then basically start the Angular app. The Angular app gets the important information that it should know the app component, that it should analyze it. With that information, the Angular code is able to parse this here, this app root component here, understand it, and insert our Angular application at this point. And that is why we don't see loading ... which would still be in the source code of this page, as you can see, but instead why we see this, because Angular overrides this at runtime, because that is, well, what it does, what its job is. So now that we had a closer look at this startup process, let's have a closer look at this component or add components in general. Components are a key feature in Angular. You build your whole application by composing it from a couple of components, which you create on your own. Now we do start with this app component, the root component you should say, which holds our entire application basically in the end. So this root component, this app component, will be the component where we later nest or add our other components to. So to this template, this HTML file of the app component, this is where we will later add our other components. Typically we might have a web page like this, with a header, with home and users, then a main area and a sidebar maybe. Now, if we have a look, this would be a fitting component, the header. And maybe also the items on the header could be their own component. Could be. You don't have to. You will learn throughout the course how I approach the splitting up of an application into separate components. We also have, of course, our main area and the sidebar here as components. And that is the core idea behind Angular. Build components. Each component has its own template, its own HTML code, maybe its own styling, and more importantly also its own business logic. And this is the great benefit. It allows you to split up your complex application, your complex web page, into reusable parts. You may use a component more than once. And that allows you to easily replicate that business logic, replicate that styling, or in general, make a finely controlled piece in your application without having to crunch everything into one single script file, one single HTML file. Instead, it's very easy to update, very easy to exchange, and again, reusable. So let's have a closer look at how we actually create a component and what this add component thing does in the next lecture. Components are important, right? That is why we start with one, with the app component. It, on the one hand, is a normal Angular component, but on the other hand, it's also kind of special because it serves as our root component. It's in the end listed here in the app module in this bootstrap array, which tells Angular, hey, this is a special component. You should bootstrap the whole application with that component being the root component. So all other components we create will not be added to the index.html file. Their selectors will not be added here. Their selectors will be added to the app component HTML file because this is now the, root component of our app where we add the other parts. Enough talking about adding components. Let's add one. Let's say we want to output some information about a server. We're building a backend for our server management application and we want to output some server information. So I will store this in a new folder, which is a subfolder of the app folder, because generally in an Angular CLI project, all your app-related content will go into this app folder. I will name it server because it will hold my server component. And this is a good practice, having the folder name equal your component name. And each component typically should have its own folder, though it's not a hard rule, but generally it makes sense. So here in the server folder, I will add my server component. Now, a good naming convention is to have server, so the name of your component first, then a dot, and then component. We will later learn that there are other building blocks in an Angular application too. So by using file names like this, it's very easy to see what's inside the file. And very important, don't forget to add .ts, so for TypeScript, because this is what we will write this component in. So now we got an empty file for our new component. How do we create a component now? First of all, a component simply is just a class, a TypeScript class, so that Angular is able to instantiate it, to create objects based on the blueprint we set up here, you could say. So let's export this class so that we can use it outside of this file too, because as I mentioned before, we're going to use our component in the app component, for example, to add it there. So we will add a class here, and this class should now be named server component. Again, the naming convention here, have the name of the component first, server, and then also the description, component, because later we will also learn about other parts which might then be named differently in the Angular app. This is our class, and right now it's a normal TypeScript class, nothing special about it. We can't use it like this. Angular doesn't have all the information it requires. So we should add something to it which tells Angular that this is not only a normal TypeScript class, but instead something special, a component. We do this by adding a special decorator. Decorators are a TypeScript feature which allow you to enhance your classes, for example, enhance elements you use in your code. It's not restricted to classes, but here we will use a class decorator. It's the component decorator, and decorators are always attached by adding an @ sign in front of them. Now, this component decorator is not something TypeScript knows from the start, so we have to import it. We have to add an import, and this import now needs to give us access to components. So we need to import component between curly braces, because from the file where we're going to import this, we could import other parts too. So we have to specifically pick the component by using this syntax. And then it's from, and now the package where we import component from is @Angular core. Now Angular ships with a couple of packages where it basically groups its functionalities. And the core package, as the name implies, gives us access to some of the core functionalities of Angular. So with that, we import that component. Now this add component decorator is known to TypeScript, so when it parses this file and compiles it to JavaScript, it is able to understand it. Now we need to pass a JavaScript object to this component decorator to configure it, because without any configuration, it's still not that valuable to Angular. But here we can set up some important information which will be stored as metadata for this class in the background then, which will tell Angular what to do with this class. And one important information piece is the selector. So basically the HTML tag by which you're able to use this component later in your other components templates. We will see this in action soon. The selector should be a string, and here you may set up any name you want, but you should make sure that it is a unique selector, that you don't accidentally override a default HTML element or something like this. So typically you prefix it with app dash and then a fitting name, like server, because it's a server component. This is my own selector by which I can now later use this component in my other components HTML files. So with that set up, the other important piece we need to have is the template. And here, let's reference another external file. I'll come back to another alternative to this soon. And this external file, of course, needs to be created. So in the same folder, I will create a server.component and now .html file. This will hold the template, the HTML code of my component here. So here, I can now basically add any content I want, like for example, the server component to start simple. And back to the TypeScript file, I can now point to this HTML file. We need a relative path for this. In the end, this will all get bundled by Webpack, so we need to tell it where to find the HTML file. Well, and relative to the TypeScript file, the path simply is /server.component.html, like this. This is pointing to this file. With this, we created our first component. Now to use it, we need to dive into app module and understand what this does, because we need to change something here to use our own component. Let's do this in the next lecture. In the last lecture, we created our own component, the server component here. It's almost ready to be used, but to use it, we need to change something about our app module. What is an app module? Angular uses components to build web pages and uses modules to basically bundle different pieces, for example, components of your app, into packages. Now, this is kind of an advanced feature, but later in the course, I will have a whole section about modules. For the majority of this course, we will only use the app module, which is absolutely fine for a lot of projects. Only in bigger projects you might think about splitting up your app into multiple modules. But what does this app module do? What is a module then? Well, it's a, as I said, bundle of functionalities of our app, and it basically gives Angular the information which features does my app have and use. As you can see, it also is just an empty TypeScript class, like our component. And as the component, we transform it into something else by adding a decorator. Here, it's the ngModule decorator, which is also imported from @Angular core. Now in there, we see 4 properties we set up on the object we pass to ngModule: declarations, imports, providers, and bootstrap. We had a look at bootstrap. This was responsible for telling Angular, hey, which component should you be aware of at the point of time the whole application starts? So which component should you basically recognize in the index.html file? And that was the app component. Now, I already mentioned that we won't add any more component selectors to the index.html file. That's just not how it works. Therefore, we won't touch the bootstrap array. Still, we added a new component to Angular. And this new component now has to be registered here in the module, so that Angular knows that this component exists because, and this is important, by default, Angular will not scan all your files here. So if you don't tell it that the server component exists, it doesn't know it. Just creating the file is not enough. That is why we have to register it here in the ngModule to tell Angular, hey, part of this module, and therefore right here of our whole app, since we only have this module, is the server component. We do register new components in this declarations array. We already registered the app component here, because even though it's also used in Bootstrap, it also is a part of our app. Now we also need to add the server component here. Adding it like this is not enough though, because now Angular would kind of know that this is part of the app, but TypeScript wouldn't know where to find this type, where to find the server component. So when we try to bundle our code, we would get an error, which you can actually see if you save this, triggering the recompilation. You see that we get an error in the terminal down there that it can't find server component because, and this is not Angular, this is TypeScript, it doesn't know where this file is, where to find this class. So we need to add an import at the top manually pointing to this. So we add server component here as an import from /server and then here in the server component, and you omit the .ts. You don't add .ts to your import, it's just server.component, so the file name without the extension. The extension is added by Webpack, which bundles our project automatically. So with this, and it's just so important, this is not Angular, this is a TypeScript feature. Now TypeScript knows where to find this, therefore everything can be bundled, so therefore now Angular, when it runs, knows that we have a server component and that it is part of our app. And with this, we can now finally use our component. We will do this in the next lecture, but maybe you're also wondering what imports and providers does here in the app module. I'll come back to providers later in the services section. Imports simply allows us to add some other modules to this module. Because I told you, you can split up your app into multiple modules and then you can import these modules to basically make this module a bit leaner and outsource some stuff into another module. Now I told you that we are only going to use one module, so what are we importing here? Some modules built into Angular, because Angular itself is split up into modules. So the browser module, for example, gives us all the base functionality we need to start our app. And forms and HTTP module, that is something I'll come back to in the forms or HTTP section of the course. So with this, the basics about this module should be clear. Again, we'll dive deeper into this later in the course. We also registered our own component. Let's now use it in the next lecture. With our component registered, let's use it. So we have our selector here, app server. Now I told you we are not going to add it to the index.html file, there it wouldn't work. Instead, let's go to the app component HTML file, the only other HTML file we have right now where we could add it. And here I'll add a horizontal line, and below this I'll add my app server element here. And the shortcut I used here is just a little plugin called emmet, available for many IDEs and editors, which gives you a quicker way of writing HTML. So here, app server is our own selector, our own element kind of we created. If we now save this, it should successfully recompile, and if we have a look at our running application, you see the server component here, our own component being added here. So that is how you can use your components then with their selector after adding them to app module and then, well, displaying them on the page. In the last lectures, we learned a lot, including the creation of a new component by hand. Now, there also is an alternative to creating it manually. When using the CLI, you can open a new terminal window or command line, leave the ngserve window running, that's important, don't close it. And in this new window, we can use some CLI command to also create a new component. Let's say we want to have our single server component here in another component, so nested into another component, a servers, multiple servers component. We can create this manually by adding a servers folder with our component, or we use the CLI with ng, and there we have a generate command, which allows us to generate some elements supported by Angular. One such element is a component. So we can create a new component with ng generate component and then passing the name servers like this. You can also use a shortcut, and instead of ng generate component, you could say ng gc, which does the same. So if you hit enter, what this will do is it will give you a new folder in your app folder with the name of your component, servers, and in there you basically find the same files as you had for the app component. HTML, CSS, TS, and this spec file, which basically is used for testing. Now I will remove this. We'll later have a section about testing. And we'll have a look at the styling later too. For now, let's say it is in this servers component that we want to output our single server. Well, we already have this decorator, this selector, app server. So in this template of the servers component, we can override the default text with app server. And maybe simply replicate this so that we have two components, because remember, components are reusable. We can use the same component as often as we want by simply using its selector as often as we want. So now we have two servers here, and with this in our servers component, you need to make sure that you also update the app module. Now the CLI should do this automatically, which is why you already find the import and the declaration in this file. But make sure you really do have it here. With this, we can go to our servers component TypeScript file to check the selector, which is app-servers. And then we can go to our app HTML or app component HTML file and update the selector to use this new component instead of the old one. With this, if we now save this and go back to our application, it looks almost the same as before. We see our single server component twice. But if we inspect the code here in the developer tools of Chrome, for example, you see that we have this outer app servers component, this newly created component, and in between we have two single app server components. So with that, we learned a couple of important things about how to create components manually or with the CLI, how we can nest them into each other, that we can use component selectors in any other template of any other component, and how we can replicate components by simply using them, well, multiple times, using their selectors multiple times. Let's dive into how we can actually style them, what we can do regarding the style and the template of components. Thus far, we always used an external template file, and we haven't done anything regarding the styling of components. Time to change both. Now, instead of using an external template file, you can also use an inline template, which means you define the HTML code in the TypeScript code. Sounds strange? Well, it's possible. We can do this by simply going to our servers component here, for example, and right now we point to this HTML file here. Now we can change template URL to template. One of the two has to be present, either a link to an external template or just template to define it in this file, but each component needs to have a template. This is the one property you have to have at all times. So with that, now I changed it to template. Now we can write our template code here. So here we could now replicate app server like this, maybe twice. We have to make sure that we don't wrap this line because this is not supported in a default TypeScript string. And if I now save this, we see the same result as before. So it looks like nothing changed, and that is good in this case because we tried to make it look like this. But actually, we did change the way we set up our template here. Now we're defining the HTML code in this same file. And actually, if you want to write multi-line strings here, which you probably want if you add more HTML code to it, you can switch from a normal string with single quotation marks to using backticks to use JavaScript template expressions to be able to write multi-line strings in between there now. So now between the opening and closing backtick, you may actually wrap the line and now write your HTML code like this. What should you use? Should you use this approach here of using template or an external file? It depends. If you have not that much code, not that much HTML code, using an inline template like this might be fine. Then you have all the logic in the TypeScript code And that is absolutely okay. But as soon as you have, let's say, more than 3 lines of code in the HTML part here in the template, using an external file is a good idea to make it easier to follow and easier to understand. It is important though to keep in mind that you can use this approach, that you can inline your templates, and very important that you need to have at least a template in a component. You can omit the selector. You will later in the routing section learn a different way of loading components without using their selector. And you don't have to add styles, but templates have to be present. So that were templates. Now let's have a look at these styles in the next lecture. We understood that templates are important and that we can either use them inline here or point to an external file. What about styles? We also have this style URLs property here, and we have these CSS files. What can we do with those? Let's go back to our app component for this. Here we got a h3 tag and a horizontal line. And if we have a look at our application, it's not that pretty, right? The I'm in the app component text here, or all the text actually, is sitting right on the edge here. Not super pretty. Now, since we use Bootstrap, of course, we can use some Bootstrap classes to enhance this. So we could add a div with a container class around it, then add a row, and this is just using the CSS framework, Bootstrap. So these are some CSS classes provided by this framework, nothing Angular specific. And then we could add a column here, XS12, to have one column on all device widths. Now, if we add this, we added some styling, some normal CSS styling, nothing Angular specific, and our app looks a little bit nicer now. This is great, but we can also use some tools given to us by Angular. Let's say this I'm in the app component heading here. We want to change its style. Maybe we want to give this some blue color. We can do this by going to the app component CSS file, which defines the styling for this component. And now we can use or write normal CSS code, so override the style of the h3 tag and set its color to some blue. So maybe to this dark blue here. If we now save this and we have a look at our application, you see it's dark blue now. This is how you can use this style file, this CSS file referenced in the app component here, to define the styles for a component. Now, just like we were able to choose between external file and inline code for the template, we can do the same for the styling. You notice that style URLs is an array here, whereas template URL wasn't. It is this because we could reference multiple external style sheets here. So you could add pointers to other style sheets. But besides that, I'm going to comment this out, you can also set up another property which is just styles. This also takes an array, but now it takes an array of strings where you define the style in this string, so now in this file. Here I'm going to use backticks again to be able to write a multi-line expression here. And then we could set up h3 here. And to really show you that this is different, I will set the color to, now let's not say dark blue, but to Dodger blue. And if I now save this and we go back to the application, you see the blue updated because now the inline style is taking over. I commented out the other one. Just like with the template, you have to decide which one to use. You can't combine style URLs and styles. But both important here has to be an array. That's the difference to template. You must only have one template. You may have multiple style files or style definitions. And you can choose between inline and external file. The rules are basically the same as for the template. If you have more code in there, using an external file is a good idea. If it's a short style definition like this, why don't you just put it into the TypeScript file? This is how you can work with templates and styles. Now, are you already a component ninja? We learned a lot about components, about the templates, options we have there, and about the styles. I want to focus on the last property we see in this component decorator for now, the selector. I already mentioned that this has to be a unique selector so that you don't override accidentally an already existing element or maybe a component made available by another third-party package you use in your project. There's one other piece of information about the selector though. You don't have to use this type of selector. Right now our selector is the same selector as we use it in CSS for selecting an element. So we have app servers here as an element, and this is recognized by Angular because the selector we chose is app servers. And this basically just looks how you select elements in CSS, right? We select the H3 element by just typing H3 here. We select the app servers element by just typing app servers here. So that actually works like a CSS selector, and therefore you are not limited to selecting by element. You could put this into squared brackets to use the attribute selector. So in CSS you can select elements by attribute by enclosing that attribute in squared brackets. And now if you save this, you would see that our app actually is broken, because if we have a look at the error message, app servers is an unknown element, because now our code, Angular, doesn't recognize app servers anymore, because we changed the selector to be an attribute. So to make this work again, we would have to comment this out or remove it, and maybe add a div or any other element, a normal HTML element, which has an app servers attribute now. Now with this custom attribute added now the app works again, because now Angular selects the element by attribute and not by the element itself, because we changed this selector. Another alternative is to select by, and I'm just going to comment this out so that the code is still there for reference, to select by class. So with a dot at the beginning, app servers. Again, just like in CSS. So here we can now select by class. So let's add a new div here, which has a CSS class of app servers, which we of course could now also style. But besides that, it's also recognized by Angular as a selector, which is why we still see the app. Now, these are all options you have. As a side note, selecting by ID won't work. That's not supported by Angular. And all those pseudo selectors like hover and so on also don't work. And you typically use the element style here, app servers, for components. We will soon learn about directives, another feature where this is different. But for components, you typically create your own elements. And therefore, you don't use that style and you don't use the attribute style. Instead, you use app servers like an element, but it is important to understand that you are not limited to this, and there might be use cases where you want to use a different selector. Time to practice some of the things you learned thus far, creating components, styling them, and so on. Here is your first assignment. I got 4 tasks for you. I want you to create 2 new components, a warning alert and a success alert component. Now you may create them manually or with CLI. I recommend creating at least one of the 2 manually to really get a feeling for how you set it up and what you need to import. Thereafter, after you created them, I want you to output them beneath each other, and you should also add something to their templates, a fitting warning message for either the warning alert or a success message for the success alert component, so that you can actually see something after you output them beneath each other in the app component. Feel free to also nest them into each other, even if it might not make super much sense, but to practice around with that. Then I also want you to style these components. Maybe make the warning text red or give it a red background. Feel free to be creative here. And also feel free to use external or internal templates or styles, maybe kind of deciding on what's right about how much content you have in there. Finally, feel free to play around with it. choose different selectors, or something like this. In the solution video, you will find my approach. Attached to this video here, you find the starting code for this project. Have fun with the assignment. So, were you successful? Let's have a look at my solution together. The first task was to create 2 new components. One manually and with the CLI maybe. So I will start with the first one, which I'll create manually. I will create a new folder and I will name it warning alert. And in there I will create a new file, which I'll name warningalert.component.ts, following this naming convention I explained. Now in this TypeScript file, I will export a class, which I'll also name warning alert component, again following this convention of being descriptive about what's in it. Here I will add the component decorator, and as you learned, the component decorator needs to be imported, so we should import component from @Angular core like this. With that import added, we need to configure the component so that Angular is able to do something with it. We absolutely need to add a template, and we should also add a selector here so that we are able to use it. Now the selector could simply be app warning alert, again to have a unique selector. And the template, you could point to an external file or use an inline template. For this component, I will use an inline template, though of course you are free to choose an external file. And I will simply, between backticks here, create a multi-line string where I have a paragraph in which I say, this is a warning, you are in danger, whatever text you like. This is my first component for now. Now I will create the second component with the CLI. So in the terminal, I can create a new one by writing ng generate component, or as I told you, the shortcut gc. And now this will be the success alert. So success alert will be the name. This will give me a success alert folder with all these files. I don't need the spec file, the testing file here. So we'll remove it. And now in this folder here, we got a out of the box working TypeScript file. We got a HTML file. As a side note, you can't ignore this constructor and ng on init thing. I will come back to this later. And here I want to output another message where I say, you are so successful maybe. This is my success message. So with that, both components are created. I also already added their templates, the content of the templates. Now we should output them beneath each other here in the app component. So I'll do this right below this paragraph, maybe add a horizontal line to separate them. And then I'll add the app warning alert component and the app success alert component. And now if we save this, we will get an error. So now is your chance to anticipate this error and fix it, but I will show you which error it is in a second. So I'll save this, and let's now go to our presumably working application where we, oh guess what, find an error. So what's wrong? Let's have a look at the error message. Most error messages are kind of useful in Angular, that's a good thing. And here it says that app warning alert is not a known element. Isn't that strange? Because warning alert, this selector here, I can copy it so that I don't have a typo. If I now paste this in there, doesn't look like I had one, so it should be known. Nope, we forgot one important thing. App module, we have to add it there. The success alert component was added automatically since we used the CLI, but our warning alert component, well, we have to add it on our own. So we should add warning alert component here, and I could use my IDE to auto import it, but for this time I will type the import manually. So warning alert component should be imported from, and now we should point to our warning alert folder and there to the warning alert .component file without .ts at the end. Now with this in place, now if you go back to the application, now we see this is a warning, you are in danger or you are so successful. So now we can see both components. So we finished these tasks here. Now let's style them appropriately. So maybe a little box with a red background for the warning and with green for the success case. So for the warning alert, I'm again going to use inline styles to have everything inlined here to show how this works. So I'll add my styles array. And in there, I'll add backticks to be able to write a multi-line style. And I basically want to style my paragraph, which is the only element I have in here. So this paragraph now should receive some padding, maybe 20 pixels, and a background color of, let's search for red or maybe some misty rose, something like that. It's a light red touch, choose any color you want. And maybe also let's give it a border of 1 pixel solid and a solid red color. If I save this, we should now see, looks like a warning alert box, looks fine to me. Now let's copy this for our success box. But here I'm going to use the external file, which is already referenced in the TypeScript file here. So let's add it here. Let's turn this to some light green, maybe green yellow, or do we have something pale green maybe? And then use a clear green here for the border. And now we should see 2 boxes below each other, 1 green, 1 red, depending on the component, with our own style added. So with that, all tasks are completed. This was the first little assignment to play around with components and get into how to create them, how to style them, how to work with them. Let's dive deeper into the basics of Angular in the next lectures. So, were you successful? Let's have a look at my solution together. The first task was to create 2 new components. One manually and with the CLI maybe. So I will start with the first one, which I'll create manually. I will create a new folder and I will name it warning alert. And in there I will create a new file, which I'll name warningalert.component.ts, following this naming convention I explained. Now in this TypeScript file, I will export a class, which I'll also name warning alert component, again following this convention of being descriptive about what's in it. Here I will add the component decorator, and as you learned, the component decorator needs to be imported, so we should import component from @Angular core like this. With that import added, we need to configure the component so that Angular is able to do something with it. We absolutely need to add a template, and we should also add a selector here so that we are able to use it. Now the selector could simply be app warning alert, again to have a unique selector. And the template, you could point to an external file or use an inline template. For this component, I will use an inline template, though of course you are free to choose an external file. And I will simply, between backticks here, create a multi-line string where I have a paragraph in which I say, this is a warning, you are in danger, whatever text you like. This is my first component for now. Now I will create the second component with the CLI. So in the terminal, I can create a new one by writing ng generate component, or as I told you, the shortcut gc. And now this will be the success alert. So success alert will be the name. This will give me a success alert folder with all these files. I don't need the spec file, the testing file here. So we'll remove it. And now in this folder here, we got a out of the box working TypeScript file. We got a HTML file. As a side note, you can't ignore this constructor and ng on init thing. I will come back to this later. And here I want to output another message where I say, you are so successful maybe. This is my success message. So with that, both components are created. I also already added their templates, the content of the templates. Now we should output them beneath each other here in the app component. So I'll do this right below this paragraph, maybe add a horizontal line to separate them. And then I'll add the app warning alert component and the app success alert component. And now if we save this, we will get an error. So now is your chance to anticipate this error and fix it, but I will show you which error it is in a second. So I'll save this, and let's now go to our presumably working application where we, oh guess what, find an error. So what's wrong? Let's have a look at the error message. Most error messages are kind of useful in Angular, that's a good thing. And here it says that app warning alert is not a known element. Isn't that strange? Because warning alert, this selector here, I can copy it so that I don't have a typo. If I now paste this in there, doesn't look like I had one, so it should be known. Nope, we forgot one important thing. App module, we have to add it there. The success alert component was added automatically since we used the CLI, but our warning alert component, well, we have to add it on our own. So we should add warning alert component here, and I could use my IDE to auto import it, but for this time I will type the import manually. So warning alert component should be imported from, and now we should point to our warning alert folder and there to the warning alert.component file without .ts at the end. Now with this in place, now if you go back to the application, now we see this is a warning, you are in danger or you are so successful. So now we can see both components. So we finished these tasks here. Now let's style them appropriately. So maybe a little box with a red background for the warning and with green for the success case. So for the warning alert, I'm again going to use inline styles to have everything inlined here to show how this works. So I'll add my styles array, and in there I'll add backticks to be able to write a multi-line style. And I basically want to style my paragraph, which is the only element I have in here. So this paragraph now should receive some padding, maybe 20 pixels, and a background color of, let's search for red, or maybe some misty rose, something like that. It's a light red touch, choose any color you want. And maybe also let's give it a border of 1 pixel solid and a solid red color. If I save this, we should now see, looks like a warning alert box, looks fine to me. Now let's copy this for our success box, but here I'm going to use the external file, which is already referenced in the TypeScript file here. So let's add it here. Let's turn this to some light green, maybe green yellow, or do we have something pale green maybe? And then use a clear green here for the border. And now we should see 2 boxes below each other, 1 green, 1 red, depending on the component, with our own style added. So with that, all tasks are completed. This was the first little assignment to play around with components and get into how to create them, how to style them, how to work with them. Let's dive deeper into the basics of Angular in the next lectures. In our little basic first application we're working on, where we added a couple of components, we covered a lot of key aspects of a basic Angular app, how it starts and how to use components, the base building block of any Angular app. But thus far, we only output static content, the server component here. That's not super interesting. We did even more than that in the first section of this course. So let's change this to output some data which is kind of dynamic at least, which is not hard-coded into the template. Time for some data binding. What is data binding? You could basically translate data binding with communication. Communication between your TypeScript code of your component, your business logic, and the template, so what the user sees. Because you might have some result in your TypeScript code because you fetched something from a server or finished some calculation, which you want to display to the user. And the only thing the user sees is the template. So we need some kind of communication between both pieces to be able to really well, do something in our app. That is where data binding comes into play because it is responsible for this communication. We get different ways of communication now. For example, we want to output data from our TypeScript code in the HTML code, in the template. We can use string interpolation for this. You saw this in the first section of the course. It's the syntax with the double curly braces and then some property name or some expression in between. Or property binding. We will have a closer look at all these forms, of course, in the next lectures. So we will learn what this then is and how it works. The syntax basically uses these strange squared brackets around HTML attributes. But again, I will come back to this. Sometimes, though, the other direction is interesting too. If the user clicks a button, you can kind of think of the user clicking this button on the template because, again, the template is the thing with which the user interacts, which he sees and where he's also able to click buttons. So if we click a button, we maybe want to trigger something in our TypeScript code. So now we need the other direction. And we can get this other direction. We can react to user events with event binding. So we can bind to, for example, a click event to execute some code whenever it occurs. And we also have one additional form of data binding where we combine both directions. Two-way data binding, where we are able to react events and output something at the same time. Might not be super clear how this works, but that is why we will now have a detailed look at all four forms in the next lectures. Let's start by having a closer look at string interpolation. Here in the server component, I don't want to output this here in the HTML code like this. I don't want to hard code the output here. It would be realistic that our server component contains information about a specific server. So maybe here in the template file, we want to output server with ID and then some dynamic ID here is, and then the status like offline. So we have two dynamic fields here. Now, it would make sense to kind of derive them in TypeScript code. In a real app that might be derived from HTTP request you make to some backend or some calculation. For now, I will hard code it in here. So we might have a server ID and I will assign a value of, let's say, 10, so a number. And I might also have a server status, which is a string offline. So two different types, a string and a number. And though not necessary, you could also be very explicit by assigning the type with TypeScript's feature here of adding a colon after the property name and then the type. It will infer it automatically though, so this is not required. I'm just doing this here for demo purposes. So now I want to output these two properties in my template. And to get this connection, we need data binding because you learned it's all about the communication between your TypeScript code and the template. So string interpolation is a typical use case here or a typical solution for this task here. Instead of the placeholder, I use my double curly braces opening and closing. This is the string interpolation syntax. And in between these double curly braces, you can now write a TypeScript expression. So the easiest expression is to simply reference a property, like the server ID. And this is a common use case that you only output a property here or the value of the property. However, it's not the only use case. You could also, for example, here for server, simply hardcode a string in there. Any expression which can be resolved to a string in the end. That's the only condition for a string interpolation syntax here. So whatever you have between the curly braces, in the end it somehow has to return a string. So you could also call a method here which returns a string in the end. The only other restriction is you can't write multi-line expressions here. You can't write block expressions in here. So you can't add a if or a for control structure in here. You could use a ternary expression though. So this is what you can do. Now let's also replace the last placeholder. And here I will again just reference a property, the server status. Now this is string interpolation in usage. And you see that we have an expression which is a string itself, and then two other expressions which simply point to properties. And again, you could also call a method here which returns a string. Now interesting, the server ID is not a string but a number. And I just said that string interpolation has to resolve to a string in the end, has to get a string in the end. So let's see if this works. If we save this with ngserve still running, let's also change app server back to app servers to make this work again. We see server with ID 10 is offline. We see it twice because we repeat this component, and each component of course has the same content, but we see that string interpolation is working and that it especially is also working here for our number. So ID 10, that is not an issue, that is working fine because a number can be easily converted into a string. So yes, you have to get a string in the end or something which can be converted to a string to really be correct here. This is how you can use string interpolation. And now to really complete the example, let's say the server status here is somehow returned in a method. Get server status could be the method name. This is how you define a method in TypeScript. So you might know this kind of method definition from other languages. And here we simply return this server status. So we return the property here. We could of course have accessed as it directly as we already did, but just to demonstrate that you can call a method, here I am calling a method. Get server status of course leads to the same output because again, all this method does is it returns us a string in the end or something which can be converted to a string. That is string interpolation in action. In the last lecture, we had a look at string interpolation, which is a great tool for outputting data in a template. Now I want to have a look at property binding. Now, one important information right away, there are a lot of times where you can either use property binding or string interpolation. And I will show what I mean in a second. Let's go to our servers component where we manage all the servers. And I want to allow the user to add new servers. At least soon I want to allow that. So we will need a button where I say add server on it, and I will just add some CSS classes button and button primary to make this button look nice. This is all using normal Bootstrap CSS classes though, nothing to do with Angular. And to reflect this change in my servers component here, I also want to comment out the inline template and point to the external template again. So template URL should point to my servers component .html file like this. So now with this, if I save this, we see that button here. Right now, it doesn't make any sense that I'm able to click this button because it doesn't do anything. We haven't learned to react to a button click yet. So I will add a new property in my TypeScript code here, which I'll name allow new server and set it to false. So now this is also another property holding a Boolean value. So true or false, in this case false, because I don't want to allow the user to create a new server. And you could again imagine that this is somehow derived dynamically. We will soon work with some dynamic data. So in the HTML file here, I now want to disable the button. And as you probably know, there is a disabled attribute you can add, like this. If we now save this, the button is disabled, I can't click it. That's nice, but that's hard-coded into HTML. Now maybe this allow new server code here changes, however. Maybe it's not set to this all the time. So then we wouldn't be able to react to this. And I can actually demonstrate this by, for now, in the constructor, which is simply a method executed at the point of time this component is created by Angular. By there, calling setTimeout, a normal JavaScript function. And here I define after which period of time or after how many milliseconds something should happen. So after 2000 milliseconds, which are 2 seconds, I want to execute a function. And here I'm using an ES6 arrow function. This syntax might look strange. It's almost the same as function like this, with some differences when it comes to handling the this keyword. But in the end, here you pass the arguments and here you have the function body. More importantly, in here, I can set allow new server, and now this would not work in the other syntax because this would then be referring to something else, can set it to true. So after 2 seconds, this will be switched to true, and since we hard-coded this, of course this doesn't affect our button here at all. It stays disabled. So I want to bind it to allow new server. So now to make this disabled functionality dynamic, we can bind to it by enclosing it in square brackets. Square brackets indicate to Angular that we're using property binding, that we want to dynamically bind some property, and disabled, the HTML attribute, in the end, in normal HTML, only sets a specific property on the underlying DOM element. You might know that each HTML element you use is parsed by the browser and kind of translated into an element on the document object model. This is totally unrelated to Angular. And therefore we have an element in this DOM, and this element has a couple of properties. A lot of these can't even be set through attributes on the HTML element. Well, one of the properties is the disabled property, and you can set it through the disabled attribute, but here we're not using the disabled attribute anymore. With these squared brackets, we are directly binding to this native disabled property this HTML element has. So now we can set this equal to, and now between the quotation marks here, an expression which for this property resolves to a boolean, but for other properties another type might be required. Because again, you can bind to a lot of properties, basically to all the HTML element properties. We'll soon learn that there are also other properties you can bind to. So for now I can simply pass allow new server here, my property name, because this will resolve to true or false, exactly the value the disabled property needs, because it has to decide whether it should be disabled or not. So now with that, if we reverse this, so by adding an exclamation mark, we made sure that this is only disabled if this is false. So if allow new server is not true, otherwise we would do exactly the opposite. So now with the exclamation mark, if we go back to the app, you see it's disabled, but after 2 seconds, let me reload this, it becomes enabled. Because now we're binding to this disabled property, this native element property, we're binding this to our own TypeScript property here. And the convenient thing is, and this is what Angular is all about, that this will update dynamically. So once allow new server changes, this is changed in the DOM, so now the button gets enabled. One of the main reasons why you use Angular, it makes it very easy for you to interact with your DOM to change some things there at runtime like we do here. That is property binding in place. Now, as I mentioned, besides binding to HTML element properties like we do here, you can also bind to other properties, for example of directives, something we haven't learned about yet, and your own components, something I will also show you later. So this is property binding. Before moving on to the other two forms of data binding, let's find out where you could actually use string interpolation instead of property binding. In the last lecture, we learned about property binding. Now, if we had the use case that we also want to output the current value of allow new server, we could of course use string interpolation to simply output allow new server, and a boolean can also be cast into a string. So now we see false here, and after 2 seconds you see this change to true because we changed it in the code. Nice. Now this is one of the cases here where you can easily use property binding instead of string interpolation. So you could simply bind to a property of this element, the inner text property, and set this equal to allow new server. Now I can remove the string interpolation here inside of the tags, and whilst they might look empty now, well, we set the inner text so we get the same behavior as before, because the inner text property of an element is just what's between the opening and closing tag. So in this case, we were able to easily replace string interpolation with property binding. So when should you use which of the two? Well, basically, if you want to output something in your template, print some text to it, use string interpolation. If you want to change some property, be that of a HTML element or, as you will later learn, of a directive or a component, typically use property binding. That is how you can differentiate it, and you will get a feeling for this once you work your way through the course project and so on. So this is this. One important note I want to make is don't mix property binding and string interpolation. You might notice that here we have disabled equals and then we have quotation marks and then directly our property name. There are no curly braces between these quotation marks, and there shouldn't be, because that will break the app. This will not work. Between the quotation marks of property binding, you can and you must already write TypeScript code, so to say, a TypeScript expression which will return the value this property expects. So for disabled, some expression which returns true or false. So just like with string interpolation, you may also call a method there, but you must not add curly braces in there. Whilst it might look we simply use a HTML attribute there, we aren't. This whole syntax here is a syntax recognized by Angular. So this is why between the quotation marks you can already, and you have to write TypeScript code, because again, this whole expression is evaluated by Angular. Mixing in string interpolation will break it. String interpolation only works in a normal template, not within another expression of that template, not within property binding or something like this. With that, enough about property binding and generally about outputting data in the template. Let's see how we can react to events. In the last lectures, we learned a lot about how we can use property binding and string interpolation to output data in the template. Let's now react to events. For example, we have a button here, and after 2 seconds this button is enabled, so it would be nice if we could do something once we click the button. Now, I will soon show you how we can actually add a new server, how we can add a new replication of our server selector, of our server component here. For now, what I want to do is, I want to output something. I will remove this text here, and instead here, I want to output the value of a property. I'll create this property, and again, you may ignore ng on init for now. I will come back to this. I will name it server creation status, and initially I will set it to no server was created, like this. Now this property can be output via string interpolation, server creation status. And I just told you I don't want to continue outputting data, we want to listen to events. So I promised it, we'll do it. I will add another method below here, and I will name this method onCreateServer. The on at the beginning to kind of make clear that this will be triggered from within my template. You don't have to name it on something, but it kind of makes it easier to understand who will call this method. Well, the user will basically by doing something. Some event will call it. That is what I want to symbolize with that. So in here I will set the server creation status to server was created. So the missing piece, of course, is to call this method, and now here is where event binding comes into play. We want to listen to this click event here, and typically you have the onClick attribute on the HTML element where you can now execute some JavaScript code. We won't use that with Angular though. Here we have the syntax Angular offers us event binding, which uses parentheses, like property binding used squared brackets. For events, parentheses are the signal that we're using event binding. And here we have to specify the name of the event between the parentheses. For example, click. And you can basically bind to all the events made available by the HTML attribute you're placing this on. So if you have onClick, on mouse enter, you could bind to click mouse enter without the on at the beginning. So we bind to the click event, and now between the quotation marks, we put the code we want to execute once this event occurs. Now, oftentimes you will call a method here. So let's do this. Let's point to the method we want to execute, which is onCreateServer with parentheses. So this method will now get executed whenever we click the button. As a side note, you don't have to execute a method here. You could also put the code you want to execute right between the quotation marks. Oftentimes, this is not very good because you want to execute more code if some event happens. But if all you want to do is set some Boolean property to true, for example, well, you can definitely do this inline the template. As a general rule, though, you shouldn't put too much logic into your templates, though. So now we're binding the click event, and we execute the onCreateServer method when it occurs. So let's see this in action. In our application, let's reload the page. The button gets enabled. And now watch this part here. If I click the button, it changes to server was created because we are triggering our own method here. And this is how simple event binding works. Use parentheses, the event name in between, and then between the quotation marks, the code you want to execute when this event occurs. In the last lecture, we had a look at event binding. Now, before focusing on two-way binding and explaining what this is, there's one other important thing you need to know about event binding. Let's say before this button, we also have a label, server name, and then more importantly, we have an input, which we maybe give a bootstrap class of form control. Here, I want to allow the user to enter the name of the server, which should get created. So here we could listen to the input event. This is a normal DOM event provided by the input element, which is fired whenever the user types. And here we could execute on update server name because it will be fired on every keystroke. So let's add this method to our component here. And now I somehow want to output what the user entered right now, what the value of this field is. Now we can do this by passing $event here. And $event, super important, is kind of a reserved variable name you can use in the template when using event binding. For this event, so only between these quotation marks here, $event will simply be the data emitted with that event. So input and click are default events provided by the DOM, you could say, and they ship us some data when they are fired. The click event gives us an object which, for example, holds the coordinates where we clicked. And the input event also gives us some data, some information about the event. Now we can capture this data with $event passed as an argument to the method we're calling, or used anywhere between these quotation marks in the code we're executing. $event, something to keep in mind. Reserved word which gives us access to the event data. So now we pass this to onUpdate server name. So here we know we will receive this event, and this will be of type any for now. So now let's simply log it to the console so that we can see it in this debug log. If we do this, and I now type something here, watch the console on the right. A couple of outputs were written there, 4 to be precise, because I typed 4 characters, did 4 keystrokes, so the input event was fired 4 times. And if we have a look at this event, we got a couple of information here, for example, the target. And the target simply is the HTML element on which this event occurred. So here on the target, since this is an input element, if we scroll down, we also got the value test, and this is what the user entered. So what we can do now in our TypeScript code is we can set a server name property, which is an empty string by default, and then here in onUpdate server name, instead of logging it, we could say this server name, and we just learned that on the event, which is of type event as we now also saw, here we have a target, and on the target we have a value. Now this is only available because the target is of type input element though. This is why my IDE doesn't like it. We can explicitly inform it about the type in TypeScript by adding HTML input element here in front of it like this. And again, this is just needed to inform TypeScript that we know that the type of the HTML element of this event will be an HTML input element. We do this explicit casting with this syntax, with the opening and closing tag, with the smaller and greater than sign, and the type in between. So with that, we assign this value to our server name. What we can now do is, in the HTML file here, we can output this for now. So with string interpolation, we could output the server name below the input. If we save this and go back to this application, and I type test server here, you see this dynamically updates below the input. This is how you can use this $event object to fetch the event data. Now with that, let's move on to two-way data binding to kind of finish this little example app here for now. In the last lectures, we learned a lot about event binding and property binding. Now let's combine both to two-way binding. We learned that we can get the event data like this, for example. There is another approach too, though. If I copy this and then comment it out, and now I replace this input event here with something else, you will find that we have an even easier way of binding to some data. With two-way data binding, we combine property and event binding. We use it therefore by combining the syntaxes, squared brackets, and within these, parentheses. Now here we have to use a special directive, and we will learn more about directives in a second, ngModel. Now we can set this equal to some property defined in our TypeScript code, so to the server name, for example. This setup will do the following. It will trigger on the input event and update the value of server name in our component automatically. On the other hand, since it is two-way binding, it will also update the value of the input element if we change server name somewhere else. And I can demonstrate this by going back to the TypeScript code and setting server name to test server here initially. So before it was an empty string, now it isn't anymore. With this, if we go back to the running application, you see that the input is pre-populated with that. Now if, for demo purposes, I comment in the other input, which does not use two-way binding, you see that this input is empty, because again, it's not using two-way binding. Now if I type something here, you see it updates the property name, and hence it updates it there where we use string interpolation, and in the other input. But if I type here, it's not getting changed in the first input, because again, we're not using two-way binding there. This is what two-way data binding is. A very simple way of binding in both directions and, for example, of reacting to changes in, well, the input value here. So I will comment out the first approach. I will leave the method in here though, even though we're not calling it anymore. But with that, you now also had a look at two-way binding, a nice and easy way of reacting to events in both directions. Now, let's fine-tune our app here a little bit more, and let's then move on to directives, another core feature of Angular. So with all four forms of data binding covered now, let's finish our little demo app for now. We got the server name, and this is live updated whilst we type due to two-way data binding in place here. I will comment out this server name here. Instead, I want to display the server name once we clicked this Add Server button. So once we create the server, we should not only say server was created, but also name is, and then simply add this server name like this. So now with this in place, we're now using the data we're changing through two-way data binding, or if we chose to do so through one-way data binding if we use the other approach, which is currently commented out. And with this in place, now you can see that if I change the server name like this and click Add Server, we see server was created, name is test server 2. With that, we're using all four forms of data binding together with each other, event binding to listen to the click, string interpolation to output the data here, property binding to enable this button in the first place after 2 seconds, and two-way binding to fetch our input data. So with that, we're pretty advanced into the basics of Angular. We use components, we know how they work in general. We use how to communicate with our templates from our TypeScript code and in the other direction. Now there's one more basic feature we have to cover to really be able to build first little applications before we then can dive deeper into the individual building blocks. So let's have a look at this next feature soon, directives. Before that, time to practice data binding though. We learned a lot about data binding in the last lectures. Time to practice that. Here's your assignment. I want you to add an input field below this list here, which updates a property named username on every keystroke. Two-way binding would be a good idea for that. I then want you to output that username right below that input in a paragraph, let's say, and string interpolation might be the tool you choose for this. Now it's getting tricky. I want you to add a button below that paragraph, and this button, which should say something like reset user maybe, should only be clickable if the username is not an empty string. So you need to check this and somehow disable the button if it is an empty string. And once the button was clicked, I want you to reset the username back to an empty string. You should see this then reflected in your template, of course. So these are the tasks. Should cover only things you learned thus far. Have fun with it. In the solution video, you will see my approach to solving this. So, were you successful? Here's my solution. We should add an input field. So I'll add a horizontal line again just to have some separation. And then my input field. The label, of course, is optional. I want the user to enter a username, so let's add an input which receives this class, which is form control. If we save this and have a look at our application, this is how it looks like. Now, if you don't want to have it sit directly on the edges, you can of course add some bootstrap styling to this. So maybe a container with a row inside of it, and then the call XS12 class. So feel free to wrap your content in there. It's not required for the solution of this, of course. So with that, we got our input field here with the username. Now let's bind this username to a property of our TypeScript file. So here I will add a new property to my app component, and I will name this property username. This will be a string, and I will set it to an empty string initially, like this. Now we learned that we can use two-way binding to bind to this. So on my input here, I'll add two-way binding by adding squared brackets and then parentheses. This is this two-way binding syntax, and then ng model. Now with that added, I can bind to my username like this. Now important, for ng model to work, you need to make sure that in your app module you have forms module added to the imports, because the ng model directive technically is part of the forms module provided by Angular. So make sure that you have this. You should have it there by default when using a CLI project. And then with that, we should update the username on every keystroke. Now to be able to see that, I'll add a paragraph below the input, and here I want to output username. Now with that being output here, we can save this. ng-served should be running, of course. And we should see that if I enter supermax here, we see it below the input. So the first two tasks here are solved. Now let's add the button. So we'll add a button below the paragraph where I will say reset user. And this button will first of all receive some bootstrap classes, button primary, to make it look nice. But more importantly, we should disable it if the username is empty. Now how can we do that? We have learned that we can bind to the disabled property. Now, even though we used that a couple of times, that's of course not the only property you can bind to, but it's the one we will need here. Now, disabled. We could set disabled to some property which is true or false, or we directly set it to true or false. But as I explained, between the quotation marks, you simply have an expression which resolves to a true or false. Now, since we want to disable this, if the username is empty, we could simply check that between the quotation marks here. So we could say disable this if username, this property, is equal to an empty string. So two single quotation marks inside here. With this expression, This will return true if username is empty, therefore then this button will be disabled, otherwise it will be false and the button will be enabled. Let's see if this works as expected. After saving this, the button is indeed disabled at the beginning because username clearly is an empty string, but as soon as I type anything in here, you see it gets enabled. So this is how we can use property binding again with any expression which returns as the value the property we're binding to expects. So in the case of disabled, true or false. Now with that we get this solved too. Now we should also add a click listener to this button so that we can reset the username once we do click the button. So event binding with normal parentheses. Let's bind to click for this. And here we could call onReset, a method where we then set the username equal to an empty string. But since this is all we're going to do, I can also just say username equals empty string. And now don't mistake this for the syntax we used here on the disabled property. There we have 3 equal signs to check something. Here we have 1 equal sign to assign a value. With this in place, we should now be able to go back to the application, enter supermax here, and if I click reset user, it's empty and the button is disabled again because we reset the username string. And that is our assignment on data binding solved. I hope you enjoyed it. So, were you successful? Here's my solution. We should add an input field. So I'll add a horizontal line again just to have some separation. And then my input field. The label of course is optional. I want the user to enter a username, so let's add an input which receives this class which is form control. If we save this and have a look at our application, this is how it looks like. Now if you don't want to have it sit directly on the edges, you can of course add some bootstrap styling to this. So maybe a container with a row inside of it and then the call XS12 class. So feel free to wrap your content in there. It's not required for the solution of this, of course. So with that, we got our input field here with the username. Now let's bind this username to a property of our TypeScript file. So here I will add a new property to my app component and I will name this property username. This will be a string and I will set it to an empty string initially like this. Now we learned that we can use two-way binding to bind to this. So on my input here, I'll add two-way binding by adding squared brackets and then parentheses. This is this two-way binding syntax. And then ngModel. Now with that added, I can bind to my username like this. Now important, for ngModel to work, you need to make sure that in your app module you have forms module added to the imports, because the ngModel directive technically is part of the forms module provided by Angular. So make sure that you have this. You should have it there by default when using a CLI project. And then with that, we should update the username on every keystroke. Now to be able to see that, I'll add a paragraph below the input, and here I want to output username. Now with that being output here, we can save this. ngserved should be running, of course. And we should see that if I enter supermax here, we see it below the input. So the first two tasks here are solved. Now let's add the button. So we'll add a button below the paragraph where I will say reset user. And this button will first of all receive some bootstrap classes, button primary, to make it look nice. But more importantly, we should disable it if the username is empty. Now how can we do that? We have learned that we can bind to the disabled property. Now, even though we used that a couple of times, that's of course not the only property you can bind to, but it's the one we will need here. Now, disabled. We could set disabled to some property which is true or false, or we directly set it to true or false. But as I explained, between the quotation marks, you simply have an expression which resolves to a true or false. Now, since we want to disable this, if the username is empty, we could simply check that between the quotation marks here. So we could say disable this if username, this property, is equal to an empty string. So 2 single quotation marks inside here. With this expression, this will return true if username is empty. Therefore, then this button will be disabled. Otherwise, it will be false and the button will be enabled. Let's see if this works as expected. After saving this, the button is indeed disabled at the beginning because username clearly is an empty string. But as soon as I type anything in here, you see it gets enabled. So this is how we can use property binding again with any expression which returns as the value the property we're binding to expects. So in the case of disabled, true or false. Now with that we get this solved too. Now we should also add a click listener to this button so that we can reset the username once we do click the button. So event binding with normal parentheses. Let's bind to click for this. And here we could call onReset, a method where we then set the username equal to an empty string. But since this is all we're going to do, I can also just say username equals empty string. And now don't mistake this for the syntax we used here on the disabled property. There we have 3 equal signs to check something. Here we have 1 equal sign to assign a value. With this in place, we should now be able to go back to the application, enter supermax here, and if I click reset user, it's empty and the button is disabled again because we reset the username string. And that is our assignment on data binding solved. I hope you enjoyed it. We're almost done with the basics about Angular. We learned a lot about components, the basic building block of any Angular app, about how it starts the app, how we can communicate with our templates in our components so that we can output data or react to events. Now there is one other key building block you probably use in any Angular app you build: directives. What are directives? Directives are instructions in the DOM. And we actually already use directives without knowing it. Components are kind of such instructions in the DOM. Once we place the selector of our component somewhere in our templates, at this point of time, we're instructing Angular to add the content of our component template and the business logic in our TypeScript code in this place where we use the selector. This was our instruction. Angular, please add our component in this place. And indeed, components are directives, but directives with a template. There are also directives without a template. So an example would be the app turn green directive, which would be a custom directive we could build. We typically add directives with an attribute selector, but technically the selector of a directive can be configured just like the selector of a component. So you could also use CSS classes or the element style, but again, typically you use the attribute style. And on this paragraph, this directive might simply color the text green, you could say. So Angular would find this instruction. Here we would have defined our directive with the directive decorator to inform Angular that this class holds a directive. And there we might have the logic to turn this green. Now we will learn how to write our own directives in the section focused on directives in this course, but there are a couple of built-in directives which are really useful. Let's take a closer look at how we use them and what they do for us in the next lectures. In the example application we built thus far, we haven't used any directives besides components, which are directives, that's important. But we haven't used any other directives, no built-in directives. Now let's say one thing we want to do is, we only want to show this server was created text here. There's no need to have this no server was created text to be displayed. So it would be nice if we could conditionally show this message. And for that, we need some help. We can use a directive shipping with Angular, the ngIf directive. Now it works like an if statement, and to be precise, it works like this. In our service component here, where we output the server creation status. I will comment this out so that we can still reference this code, but now I will add a new paragraph where I simply say server was created, server name is bind my server name. Now with this in place it will still work, but now we always see with every keystroke how we change this server name. Not really what I want. Instead I want to output it as soon as we click this button here. So what I can do is I can add a directive here, and as I said, typically directives are added by using an attribute selector, and pretty much all the built-in directives use that selector. ngIf does. And then ngIf is added by adding a star. This is important. ngIf. The star is required because ngIf is a structural directive, which means it changes the structure of our DOM. It either adds this element or it doesn't add it. So that's just some extra information for Angular. The directive itself is just ngIf, but the star is required. Without it, it will not work correctly. So ngIf, and then we can set up our condition here between the quotation marks. For ngIf, this has to be any expression returning true or false, deciding whether this should be added or not. So here, it would make sense to add a new property, which we name server created, and set it to false. And we set this to true once the button is clicked. So here in onCreateServer, which is triggered when the button is clicked, here we set server created equal to true, like that. Now with this, we can go back to our template and simply bind ngIf to server created. And again, this could also call a method which returns true or false, or directly perform the check between the quotation marks, anything which returns true or false. Now with this, if we save this, what you see is that there is no text, but if I name this test server 2 and click the button, now the text is added here. And the interesting thing is, if I reload the app and we inspect our DOM here, you see here that's our app server component. Below that is, above that is the button. But if I click this button, a new element was entered here, the paragraph. And here you see kind of the hook which Angular created to know where this should be entered. But the important thing is it's really added or removed to or from the DOM. It's not there all the time. It's not hidden. It's just not there, which is super important to understand. So that's ngIf. Again, the star at the beginning indicates that this is a structural directive really changing the DOM as you just saw. In the last lecture, we had a look at the basic ngIf syntax, and that's the syntax you're going to use most of the time. There is one alternative to it though. Sometimes you have not only the if condition, but also an else condition. So here we might want to say server was created, server name is something with ngIf, but we could also add an else block where we then want to say no server was created. Now we deleted that exact text for the reason that we don't want to see it, but imagine that we do want to show that alternative. So no server was created, could be the text here, and now we want to show this paragraph only if ngIf is not true, or this condition, server created, is not true. We can achieve this by placing a local reference on this element here, and local reference is something I will dive deeper into in the understanding components and data binding section of this course. For now, let's think of it as a marker. So I will name this no server, any name you like. Let's name this no server with a capital S. And now we need to change the paragraph here to ng template. That is a component, a directive shipping with Angular, which you can use to mark places in the DOM. And now I will add the paragraph back in this template with the text in between, like this. So now basically the text we want to output. And now with ng template, with the local reference, there's a marker on it, we mark a certain spot in the template which we want to show conditionally. Now to show it conditionally, we simply enhance ngIf by also adding else and then no server. So this marker we placed on ng template. And that's all the syntax we need. If we save this, you see no server was created, and as soon as I click here, that gets replaced with server was created. So that is ng if else. A nice little addition in a use case where you have, well, an else condition. Of course, the alternative would always be to simply use ng if with the reversed check, so with exclamation mark server created. But that here is another nice alternative. Now, I'm going to delete it. You will find an article after the section here though, where you can find this code again in case you're interested. And we will also use this code in the course project we're going to build. I just wanted to highlight that this option exists. Using ngIf like this, however, is the case you will see most often. Now let's continue. In the last lecture, we saw ngIf, super useful directive, and ngIf was a structural directive. The other type of directives are attribute directives, which are called like this because they really just look like normal HTML attributes without a star basically. Let's add one. On the server component here, we output the server status, right? And the server status always is offline. Let's mix this up. Let's say we want to dynamically create this. So I'll add the constructor, which is just a built-in method each TypeScript class has, which is called once this component is created. And here I will set the server status to a random value. I will use the math random function, and this gives us a random number between 0 and 1, a floating point number. And if this is greater than 0.5, I want to set the status to online, otherwise I will set it to offline. So with that, we shouldn't get the same status all the time. And now, let's check this. We see indeed online and offline. That's lucky. Could have, of course, also been both offline since we have a 50% chance. Now we have two different statuses here. And now let's say we want to change the color of the background color of this component depending on the server status. For this, we can use another directive. On this wrapping paragraph here, I can add it, and it's called ng_style. Now that's a built-in directive. You can recognize this on the ng at the beginning. And ng_style, that's the directive, is pretty useless like this. We need to give it some configuration to do something. That is why we will use property binding on this directive. And it's super important to understand that these squared brackets here are not part of the directive name. The directive name is just ng_style. The squared brackets indicate that we want to bind to some property on this directive, and this property name happens to also be ng_style. We will see this in practice on our own directives in the directives section later. But super important to understand that property binding is not the same as a directive. It's totally different. We are binding to a property of the directive. This ng_style property expects to get a JavaScript object. And here we define key value pairs of the style name as the key and the value of the style as the value. So for example, we could bind background color, and if you want to use this notation with the dash, you have to wrap it in single quotation marks to make it a valid JavaScript property name. Or you use the camel case notation background color like this. And then you could set this to red. But I don't want to set it to red, I want to set it to something depending on the server status. So here we could simply call a method getColor. So that is really mixing now all the things and make it clear that between the quotation marks we are executing TypeScript code here. So therefore we can of course call a method. Now getColor is a method we can add here. And getColor should now, let's say, return green if the status is online and red otherwise. So I will return something. First I check the server status, so this server status, and if this is equal to online, using a ternary expression here, I will return green, otherwise I will return red. So getColor will return green or red, and this is then assigned as the background color with ng_style. If we now save this, let's have a look at the result. We see indeed the running server has a green background and the offline server has a red one. So that is working. ng-style allows us to dynamically update that. If I reload, you see now both are offline, so both are red now. And that is the big advantage of ng-style. It allows you to dynamically update the styles. And of course, if the server status here did change over time, it would update the styling respectively. So this binding we set up here still is working. If the server status here, which is responsible for choosing the right color, changes, it updates the style. So that's ng-style, an attribute directive added like an attribute, and in this case also using property binding to configure it. We saw examples for ng-style and ng-if. Now, something related to ng-style is ng-class. Now we learned that ng-style allows us to dynamically assign a style. Now I will also add ng-class here. And where ng-style allowed us to change the CSS style itself, ng-class allows us to dynamically add or remove CSS classes. So let's create such a class. And for this, I will first of all add my styles here. And I will use backticks to write this over multiple lines. And I will give this a class name of online, in which case I want to color the text white. So that's all I want to do, because I think it's kind of hard to read the black text on the green background. So back here, ng-class also, this is the directive, also only works as intended when using property binding. So let's wrap it in squared brackets 2. And here we also need to pass a JavaScript object. And that's just the case for this property of this directive here, of course. Each property you bind to may take a different value, like disabled, which took true or false. So here it's a JavaScript object. And for ng-class, this object works like this. We also have key value pairs. The keys are the CSS class names, and the values are the conditions determining whether this class should be attached or not. So here we have the online class. You could also wrap this in single quotation marks if you had a class name with a dash inside of it or something like this. And here, well, I want to attach this only if the server is online. So only if server status equals online. Online here is a string between single quotation marks. Now, of course, you could also outsource this in a method you call this server status equals online check, but here I will write it inline. So if this is online, we should attach the CSS class online to this paragraph, otherwise it should not get attached. Let's view this in the running application. Both are offline, so none of the two should have the online CSS class added to it, and indeed, I can't find the class on any of the two. Now let's reload and hope that some of them is offline, or online, excuse me. Both are, so let's check it. Now we see the online class has been added, actually, to both of them, because this is how ng-class works. It only adds a CSS class if a certain condition is true. And that's an example for another built-in directive, another built-in attribute directive. With all these directives learned, let's now have a look at the last built-in directive for now. An important one though. It's sad that we can click the Add Server button, but we don't actually add servers to our list here, right? This list doesn't grow. This list is totally static. We can change this with the ng-for directive. So let's have a look at how it works. In our servers component here, we right now manually add our app server component twice. It would be nicer to have an array of servers which adds it dynamically. So in the servers component here, I'll add a new property, servers, and this is an array. And here I could have my test server and my test server 2 maybe. And when we create a new server here, I actually want to access this array of servers, and push a new server on it. And this should of course use the server name I set up. Now with this, I have an array of servers. It would now be great if we could replicate the app server component as often as needed to have a server for each element in the array. So 2 initially, and then a new one for each server we add. We can do this. I'll get rid of the second app server here. And on the first one, I will place another directive with a star, because this is now also a structural directive, changing the DOM itself. It's the ng4 directive. The ng4 base syntax looks like this. We define a temporary variable for inside the loop with let. Give it any name you like server, for example. And then of servers. Servers here is the property we defined in the TypeScript file. And this will now loop through all elements in this array and assign the individual element to this dynamic server variable. So that's just like you might know this loop from a normal, JavaScript code, the for of loop. This server variable can now be used in the template. But here we don't really need it, to be honest. We will soon learn in the next course section how we can pass data to our own components to output it there. So for now, we won't need that. But one thing we should see is that if I save this and we go back to our application, we still see 2 because we start with 2. But if I add more servers, you see our list grows. And we can click this as often as we want. Of course, the content of the individual server is still static because we can't pass the data, like the server name, to that component. But that is something we will learn in the next course section when we dive deeper into components, and we will learn how we can create our own properties on components. We can then set from outside a feature which would be great to have here. So let's dive into this in the next course section. Before doing so though, let's practice the things we learned in the last lectures, and then let's also set up our course project before we then dive deeper into components and data binding again. So see you there. Time to practice the things you learned. Before we dive deeper into components and data binding and learn more about it, learn more advanced things about it, it's key to understand how these directives you learned thus far work. Here are your tasks. I want you to create a button which says display details, and then I want you to add a paragraph below the button with any content of your choice, like for example secret password equals tuna. Then I want you, and that is something which might be a bit challenging, to toggle the displaying of this paragraph with each button click. So if you can see it, it should be hidden, and the other way around. You have all the tools you need for this. It simply is all about having a flexible property which changes its state, its value regularly. Thereafter, I also want you to log all clicks on this button in an array. So you add a new item to that array for every click. The value of that item you add could simply be the timestamp of that click, or maybe just the incrementing number. So that you have, for the first click you print 1, for the second click you print 2. And I want you to log all these items to the template. So output a list of items there, maybe with an unordered list with list items inside of there, maybe a paragraph, whatever you like. I then want you to style these log items, but only starting after or at the 5th item. So the first 4 items should have no style, no special styling, no background, nothing like that. But the 5th item and all other items coming after that should have a blue background added with ng style and a white text color added with ng class. Now that might also be tricky because you have to determine if it's the 5th item or not, right? Now you can easily determine this when using an incrementing number as an item stored in this array. When using a timestamp or something like that, it's not that easy. So I recommend going with the incrementing number. I will show the alternative in my solution though. So see you there, have fun with the assignment. Were you successful? Let's solve it together. I'll start right below this ordered list and add a button with some CSS classes, button primary, where I will say display details. Or maybe you should even say toggle displays now that I think about it, but I'll leave it at this. Then I'll add my paragraph where I say any text you like. Here I will stick to secret password equals tuna. And I only want to display this, well, if it is not displayed. And if it is displayed, I want to not display it. So really toggle it. That's super easy to implement. I'll add a property to my app component, which I'll name show secret, any name you like, of course. And I will set this to false initially. And now in my app component, I'll add a click listener to my button with event binding. And here, I will simply set show secret equal to what show secret currently is not. So that is a quick and easy way of toggling it. So if it is false, it will be set to true. If it was true, it will be set to false. Now with that, I can add ngIf here and check if show secret is true and only show it in this case. Now with this and ngServe still running, if we go back and I click this, now you see the toggling works as expected, so the first 3 tasks are already solved. Now let's move on to the fourth one, logging it to the console. For this, I'll actually duplicate this button and comment out the first solution with the easy toggling, because for logging, I will call a method now on toggle display maybe, or on toggle display, on toggle details, excuse me, any name you like though. I'll add this as a method in the app component. And first of all, I will still use my toggling code here. So I will set this show secret to what show secret is not. But then I want to log it. So I'll name this log and it should be an empty array at the beginning. And then here I will simply say this log push. And I want to push a new number. And this number should actually take into account the current length of this. So if this is at the beginning has 0 items, this will be 0. So I'll add +1. So if you have one element in the array, the length will be 1. So the next element should have a value of 2. So this adds these items to the log. Now I will output it below the paragraph and I will choose a div element here. I will use ng4 on it. And we learned that we use ng4 by saying let. And now we could say log item, any name you like, of log, so of the property you want to loop through, or generally the data piece you want to loop through. That could also be a method call returning an array. It has to be an array though. So here we loop through the log, and between the div opening and closing tags, I can now use string interpolation to output by log item. Now we didn't do this in the last lectures, but I told you that log item is a variable we can now use in the template. And that's exactly what we're doing here. I'm outputting log item. So with this, if we have a look at our application and I click this button, you see that I add this list. It's jumping around because I'm adding and removing this secret password, but you see the list is growing as expected, the log is working. Now about that coloring, the fifth step here. Well, it's easy to do when using a number like this. When doing so, I'll go to my div and I will start with the style, the blue background. So we'll use ngStyle, and we learned we need property binding for this to work correctly because we need to pass a JavaScript object configuring our styles when we want to attach which styles. So the style I want to attach is the background color. I'll again use camel case notation, though you could use single quotation marks to have background dash color as a name. And now here, it's easy to check if log item is a number, because I want to check if log item is greater or equal than 5. In which case background color should be blue. This is a string. Otherwise it will be transparent or white to basically have a non-blue background here. Log item, of course, is a number, so this check should be easy. And yes, you could outsource this part, of course, into a method you call here, generally having most of the logic in the TypeScript code, in the body of your component is a good practice, but here I think it's also okay to put it into the template and show that this is possible too. We have this check now in place. Let's see if it works as expected. If I click this button, the next item should have a blue background. And it does. So that's working, but pretty hard to read, right? So let's finish the second part here and give it a white color. For this, in my CSS file, I will define a white text class name, any name you like, of course, that's totally up to you. And I will set the color to white. Now this white text CSS class should only be attached if we are at element 5 or higher. So next to ng-style, I will also add ng-class and I will use property binding, so squared brackets, here too, because I need to pass a JavaScript object to the ng-class property on the ng-class directive to have it work correctly, because this directive needs to know which classes should be attached when. Well, between single quotation marks, since we have a dash inside the name, I'll add the white text class, the class we just created here, only if the condition specified here as a value returns true. And the condition simply is log item greater or equal than 5, just like on the ng-style directive. So if this returns true, we should have the white text class attached, which should turn the text white. Let's see if it works. I'll click display details. So here the text clearly is not white. That is working. And now, looks good, blue background, white text. Awesome. Now I will show a nice bonus to the solution in the next lecture actually, where I will use timestamps because it uses an extra addition of ng4 we haven't seen before. Were you successful? Let's solve it together. I'll start right below this ordered list and add a button with some CSS classes, button primary, where I will say display details. Or maybe you should even say toggle displays now that I think about it, but I'll leave it at this. Then I'll add my paragraph where I say any text you like. Here I will stick to secret password equals tuna. And I only want to display this, well, if it is not displayed. And if it is displayed, I want to not display it. So really toggle it. That's super easy to implement. I'll add a property to my app component, which I'll name show secret, any name you like, of course. And I will set this to false initially. And now in my app component, I'll add a click listener to my button with event binding. And here, I will simply set show secret equal to what show secret currently is not. So that is a quick and easy way of toggling it. So if it is false, it will be set to true. If it was true, it will be set to false. Now with that, I can add ngIf here and check if show secret is true and only show it in this case. Now with this and ngServe still running, if we go back and I click this, now you see the toggling works as expected, so the first 3 tasks are already solved. Now let's move on to the fourth one, logging it to the console. For this, I'll actually duplicate this button and comment out the first solution with the easy toggling, because for logging, I will call a method now on toggle display maybe, or on toggle display, on toggle details, excuse me, any name you like though. I'll add this as a method in the app component. And first of all, I will still use my toggling code here. So I will set this show secret to what show secret is not. But then I want to log it. So I'll name this log and it should be an empty array at the beginning. And then here I will simply say this log push. And I want to push a new number. And this number should actually take into account the current length of this. So if this is at the beginning has 0 items, this will be 0. So I'll add +1. So if you have one element in the array, the length will be 1. So the next element should have a value of 2. So this adds these items to the log. Now I will output it below the paragraph and I will choose a div element here. I will use ng4 on it. And we learned that we use ng4 by saying let. And now we could say log item, any name you like. of log, so of the property you want to loop through, or generally the data piece you want to loop through. That could also be a method called returning an array. It has to be an array though. So here we loop through the log, and between the div opening and closing tags, I can now use string interpolation to output by log item. Now we didn't do this in the last lectures, but I told you that log item is a variable we can now use in the template. And that's exactly what we're doing here. I'm outputting log item. So with this, if we have a look at our application and I click this button, you see that I add this list. It's jumping around because I'm adding and removing this secret password, but you see the list is growing as expected. The log is working. Now about that coloring, the fifth step here. Well, it's easy to do when using a number like this. When doing so, I'll go to my div and I will start with the style, the blue background. So we'll use ng-style, and we learned we need property binding for this to work correctly because we need to pass a JavaScript object configuring our styles when we want to attach which styles. So the style I want to attach is the background color. I'll again use camel case notation, though you could use single quotation marks to have background dash color as a name. And now here, it's easy to check if log item is a number, because I want to check if log item is greater or equal than 5, in which case background color should be blue. This is a string. Otherwise, it will be transparent or white to basically have a non-blue background here. Log item, of course, is a number, so this check should be easy. And yes, you could outsource this part, of course, into a method you call here, generally having most of the logic in the TypeScript code, in the body of your component is a good practice, but here I think it's also okay to put it into the template and show that this is possible too. With this check now in place, let's see if it works as expected. If I click this button, the next item should have a blue background. And it does. So that's working, but pretty hard to read, right? So let's finish the second part here and give it a white color. For this, in my CSS file, I will define a white text class name, any name you like, of course, that's totally up to you. And I will set the color to white. Now this white text CSS class should only be attached if we are at element 5 or higher. So next to ng-style, I will also add ng-class, and I will use property binding, so squared brackets, here too, because I need to pass a JavaScript object to the ng-class property on the ng-class directive to have it work correctly, because this directive needs to know which classes should be attached when. Well, between single quotation marks, since we have a dash inside the name, I'll add the white text class, the class we just created here, only if the condition specified here as a value returns true. And the condition simply is log item greater or equal than 5, just like on the ng-style directive. So if this returns true, we should have the white text class attached, which should turn the text white. Let's see if it works. I'll click display details. So here the text clearly is not white. That is working. And now, looks good, blue background, white text. Awesome. Now I will show a nice bonus to the solution in the next lecture actually, where I will use timestamps because it uses an extra addition of ng4 we haven't seen before. In the last assignment, we created this solution with our log here, where we could add items which get an incrementing number, and this number then determines whether we have a background color which is blue or this white text CSS class attached to it. Now, in the assignment, I said that it is one option to use an incrementing number in our log. Another option might be to use any other content. For example, a timestamp, but it could be any other text. So I will first of all change this here in my app component TypeScript file. And I will no longer push this number. Instead, I will use the timestamp here, which we can get with new date. Date is a built-in object JavaScript ships with. so there's no need to add any import. Now with that, we're pushing new timestamps on this array. I can demonstrate this with ngserve running by simply clicking this button here. But now everything is blue, of course, because our check here now always returns true, because a string, and this is just a string, is always deemed as being greater than 5. So our check doesn't work anymore. We can add something to ng4 here too. Separated with a semicolon, you can extract some extra information. The current index, or the index of the current iteration. With let, you can bind it to any variable name of your choice, like I or index, whatever you like. I will set it to I. And then you set equal to index. Now, equal to index kind of is also like a reserved expression, you could say. It gives you access to the index of the current iteration. So in the first loop, this will be 0. In the second loop, so in the second element in this array, I will be 1, and so on. Now with this information, you can of course update your solution here to no longer check if log item is greater or equal than 5, but if I is greater or equal than 4, because remember, the index starts at 0. So let's update both checks like this. And now with that, this should work with any content and not just with incrementing numbers. This looks pretty good. So that's a tiny addition, extracting the index of ng4 just like that. With that, enough about the basics. We got a lot of solid knowledge right now. Let's use it to set up our course project in the next section before we then dive deeper into components and data binding. Can't wait to see you there. Time to practice the things we learned thus far in our course project. Now, what is our course project? My goal in this project, which we will build throughout the course, to which we will come back after the individual sections of this course, is to build a recipe book and shopping list app. You saw it in the intro video of the course. Basically there we're going to have two sections, shopping list and recipe book, and we will be able to manage our recipes, view them in detail, and also to manage our shopping list and even push ingredients from a recipe directly to the shopping list. This application will use a lot of the features we learned throughout the course, and therefore I think it's perfect to practice these things and see them come together in a real app. First of all though, let's try to plan the application, because before creating the app, you of course need to have a plan. And therefore in the next lecture, we're going to think about which components we will need for the different features of this application. The first step in creating an Angular application, of course, is to lay out the structure of this app and especially plan which components you're probably going to need. Now, it's normal that whilst building the app, you decide to add another component which you didn't plan to add at the beginning, or maybe you decide that you can merge two components you thought you would have to split. But generally, this is still a good approach. And this should also show you how I approach this and how you may decide what should go into its own component and what can be merged into another one. So on this page, I try to lay out the general structure of our app. And at the bottom, you can find kind of a legend. So let's start with the features of this app. Well, we're going to have a shopping list and a recipe book section, as I said, managing either our single ingredients we need to buy, or in the recipe book, our whole recipes. Which components will we need for this? Obviously, a root component holding our overall application, the app component. Every Angular app has this. Then, since we have two sections, it probably makes sense to have some kind of header component where we can navigate between these two sections. Of course, you could also hard-code the header simply into the app component, but since it will contain its own business logic, in the end it will trigger a routing action later, and we will also add a drop-down there in the end, which allows us to store our recipes on the server and fetch them from there. So since we will have that logic attached to the header, outsourcing it into its own component makes sense, so that we don't have to put all the logic into our root component, which really mainly should only be responsible for holding our overall app. So that is the header. Now let's dive into the individual features. Let's start with the shopping list. Here I guess it makes sense to have the overall shopping list component. Remember, the purple box is only the feature, so we need a component holding our shopping list. And maybe in this shopping list component, we also want to have a shopping list edit part, which allows us to add new items, so an input field and a button, because that again has its own logic. We will have to decide if we're editing an existing item or adding a new one. We need to submit this, so it makes sense to create its own component for this, so that we have our overall list component, mainly holding the data of the list, and the edit component being responsible for managing this data kind of, though the edit component will be nested inside the list component. I guess that's it for the shopping list. Let's have a look at the recipe book. Here, it certainly makes sense to have, again, just like with the shopping list, a recipe list component, which shows us a list of all our recipes. Here, we might later also put each individual recipe into its own item though, since it holds a little bit more information than just one line of HTML code. And a recipe detail area would be great too. So an area where once we select a recipe, we can see informations about that. Later in the course, we will also add another component here, because we will then somehow need a component which allows us to edit existing recipes or add new ones. But since this is really advanced and we would not be able to fill it with much life right now, I will omit it for now and focus on the displaying part. So a list with items and then the detail section, which displays the details for the currently selected item. I guess this looks like a good plan. Each of these components should hold a significant amount of business logic, and I guess with the components sketched out here, we're really having each component focus on one main topic, displaying a list, displaying information about a single item, displaying detailed information about a selected item, and so on. So this is generally how I approach this. Of course, feel free to split this up even more, or if you want, merge them together as, for example, recipe list and a single item. But this will become more clear once we actually implement these components. Now, one last thing we should think about: which models will be used in this app? And with model, I simply mean which data. So we certainly will need some representation for our ingredient. We will use ingredients a lot in the recipe book too. Each recipe there has a couple of ingredients. So we should define how an ingredient looks like. That is something which your application probably also needs. Be clear about the data you're going to use and put it into its own class, so that you have your own type you can use later on, and that you have a clear interface or definition of what your data looks like, so that you can easily have your components talk with each other, something we'll dive in later in this course, so that there is no issue regarding the data you're exchanging. So besides the ingredients, which probably is a very simple model, only controlling the name and amount maybe, we also will need a model for the recipe, which contains things like the title, the description, the ingredients, and so on. And I think with this, we have a solid plan for now. Let's get started. Let's implement all these components, fill it with some dummy data for now, and take the first step in building our course project. I'm in a brand new project created with the CLI, and the only thing I did thus far is I cleaned up the app component, removed this property we had there, and cleaned up the app component HTML file. All the rest is still the same. I didn't change anything else. So the first thing I want to do, and you can of course recreate this project by simply running ng new, any project name you like, and then cleaning it up like I did. The first thing I want to do is I want to add the Bootstrap CSS framework, so that we have some CSS classes we can work with to give this some nice styling, because in this app I really want to focus on Angular and not on the styling. So of course we can add Bootstrap with npm inside this project folder. In the terminal I type npm install, then -- save, as it will be a production dependency, Bootstrap. And this will automatically install the latest version of Bootstrap in this project. Now once this finished, we got Bootstrap installed. Now we also need to inform the CLI that Bootstrap should be included in our final bundle it creates for us. Because of course the CLI bundles all our script files and style files, and by default it would not include Bootstrap. So to inform the CLI, we should go to the .angular CLI JSON file. And here in styles, in this styles array, we can add any global style sheets we want to add to our whole project. Now it already has the styles.css file, which is a file where you can define styles for the whole project. Here I will simply add the path to our Bootstrap styles. Now we can have a look where that is stored. In the node modules folder, which manages all our dependencies, if we have a look at the Bootstrap folder there, the dist folder sounds about right for distribution. There we have a CSS folder, and here the bootstrap.css file is probably what we need. So we can quickly import this here by adding a path to that. And now the important thing is we need to go up one level first, because you don't have to see this path relative from the CLI JSON file here, so this config file we're in, but you have to see it relative from your index.html file. And that is in the source folder, so it's nested one folder deep into your app, you could say. So here we target node modules, and then we can target the Bootstrap folder. And now again, just to make this really clear where this is coming from, in the Bootstrap folder, we can target dist CSS. So let's do this, dist CSS, and here bootstrap.css, just like that. To be precise, it would even be better to target the minified version, which is a file also lying in that folder. So let's add .min between bootstrap and .css. So this will already give us the minified code, which is of course smaller. Now with that, this should be added, and now we can run ng-serve to get our CLI to build this project for the first time and serve it at localhost 4200 as we did before in this course. And that is our running application. Now we don't see very much here, of course, because our app component HTML file is completely empty. We can quickly check if Bootstrap styles were added successfully by adding a div with the class container. And the shortcut I'm using here is a plugin called emmet, which allows me to just type .classname and hit tab to autocomplete it. It's available for many IDEs, so simply Google for it plus your IDE or editor, and chances are you will find it. And then in there I want to nest a row, and now let's say simply to get started, a column for medium-sized devices, which spans the full width for now, and I simply want to output in a H2 tab, I'm working. So with this, if we save that, it should recompile, and now we're seeing I'm working. This looks like Bootstrap is working too. We can see this on the font size, and also if we inspect this here in the styles, all these styles here down there are coming from Bootstrap. So this is working, and with that, we got our application set up. Now let's get started creating all the components we require. So in the last lecture, we set up our project and we added Bootstrap to it. Now I want to get started adding the components we laid out here. Here's your challenge. Try doing this on your own. Now with that, I don't mean filling these component templates with live. For now, each component may simply hold some dummy text so that we can see that it's there. I mean create the components and try to create a clever folder structure in your app folder. Not every component should have a folder on the root level. You should also nest them by feature maybe. And try to create at least one component manually, by hand, not using the CLI. I'll give you a chance to pause the video and then I will show you my approach. Chances are that we deviate in our solution, but that's a good practice for you. So definitely go ahead and try creating these components without any content in it for now on your own. So, were you successful? Let's see how I would solve this, how I would approach this. We got two main areas, recipes in the shopping list, and we got this header component. Now, I will create the header component manually. So for this, we can already start the discussions. Should we create a header folder in the app folder where we store this component, or should we create the component in the app folder itself? Now I will create a header folder, but placing the component directly in the app folder would also not be wrong, since it is really only used by our app component. So here I will create this new folder named header, and in there I'll add my header.component.ts file. Now As you learned, a component is simply just a TypeScript class, so let's name it header component here. And right now, that would not be recognized as a component by Angular. Instead, here, we have to add the add component decorator. And later I'm going to use the auto import feature of my IDE. For now, I'll import it manually. We have to import component between curly braces from @Angular core. That's important. Now with that, we need to pass a JavaScript object to this decorator to configure this component. Specifically, we need to add a template, and I'll put this in an external file, so template URL in this case, and a selector so that we can use this component. So the selector here is app header because I want to ensure that I have a unique selector and that I don't overwrite an existing HTML element, for example. And header would be an existing element. The template URL, here I want to point to the header.component.html file. And as you probably recognized, this file doesn't exist. So I can quickly create this by creating a new file in the same folder, in the header folder. Here, header.component.html is the full file name. And in this HTML file here, I simply want to output the header for now. I'm going to add some content soon. So that's my header component. And I can already include this in my app component, maybe above the container, because in the container, I later only want to contain my content component, I will say. So here I'll add the app header, just like this. So with that, we added it here. Now let's see if we can see it. And I just see loading ... which always is an indicator that there has been an error. So check the JavaScript console in your developer tools to see the error. And the error is pretty clear. App header is not a known element. This is a common gotcha, which is why I wanted to show it. Why is it not known? We added it here and we set up the selector here, right? Well, remember, you have to register all the features you're going to use in the app module. And since we didn't use the CLI to create this component, it wasn't added there automatically. So we have to add it manually to our declarations array. And that means we also have to add the import. So we should import header component from, and now pointing to the header folder, and then in there the header component file without the file extension. So that now unlocks the header component in our app. And if we save this, now we see the header. Now that's not pretty. We're going to change this soon, but we can see that it is working. Now let's move on to adding all the other components with the CLI for now. So we had a couple of components we wanted to add, and I will use the ng generate command, or just ngg as a shortcut. And then we want to generate a component, or just c as a shortcut. And the first component I want to add is the recipes component for this recipes feature area. I'll add spec false to prevent the creation of a testing file, which I don't need. So with that, we get a new folder in our app folder, the recipes folder, which holds our recipes component. That is great. Now, this will be our overall recipes feature component. And that actually is a component I didn't sketch out here. Here we only have recipe list, item, and detail. Now you could also just work with these, but I want to create a setup where I have a list on the left, let's say, and if I click an item, the detail component is displayed on the right. So I will need an overall component holding both. Now that is an optional setup. You can also go with another one where the detail is somehow embedded into the list component. I chose to create this overall component. Now besides that, I will go ahead and create the other components though. So besides recipes, I will also now create the recipe list component as laid out on the slides. Now here, I don't want to create the recipe list on the or inside the app folder though, which is the default behavior by the CLI if I now would hit enter. Instead, that should go inside the recipes folder because that is where all the recipe related components should go. We can easily tell the CLI to create this component in a subfolder by basically passing a path here. So instead of just saying recipe list, we can say recipes/recipe list. And since we already have the recipes folder, this will create the recipes list folder inside of the recipes folder. That is what I meant with structuring the folders by feature. Now with the recipe list added, I also want to add the recipe detail here, because the recipe detail should be displayed next to the list in my setup here. So I will add it to the recipes folder too, so that now we also have the recipe detail folder here. And we also need a component for a single recipe item, right? So recipe item. However, I don't want to add that to the recipes folder. That should go inside the recipe list folder, because it's in the recipe list where I want to, well, also have that item. So I'll point to the recipe list subfolder here and now hit enter. And now we got the component inside the recipe list, because again, a recipe item is just one item in this list of recipes. Now again, it's only one possible folder structure. You could remove the recipes component and put recipe list component as the main recipe feature component and add details somewhere in this component then. I chose to have this setup here though. Now let's move on to the shopping list. Well, for this I'll of course run ng-gc again to generate a new component, and I name it shopping list. I'll also add spec fault here to prevent the creation of this testing file. And this will give me a shopping list folder in my main app folder, so next to recipes and header. Inside the shopping list, there's only one other component I wanted to create, and that's the shopping list edit component, which will allow us to add new ingredients or edit existing ones. That should now go into the shopping list component. So just like before with recipes, I'll simply change this to shopping list/shopping edit, and this will now add it inside of this component. So now we got all the components we need for now, or at least I think we need for now. Of course, feel free to choose a different setup, but with all these components added, and since we used the CLI, they were also added automatically to app module. If you did create them manually, make sure to add them here too. So with all that created and added to app module, we can now use them. So let's start using them in the next lecture, and let's also start filling them with some life there. We created all these components, let's start using them. I will start using them in the app component HTML file. Here where I say I'm working, here I want to display my app recipes component, so the one we created here in the recipes folder, and below it the app shopping list component, so this component here. If we save this, we see recipes works and shopping list works, which of course are the default strings the CLI gave us here. So with these added and working here, let's now also work on the individual components here, starting with recipes maybe. In my recipes component, as I said in my setup, I want to have the recipes list and detail next to each other. So for this, I'll add a row div here, and in this row, I'll add a div with the class colMD5 to have a smaller column on the left, and then another one with colMD7 using these bootstrap column sizing classes to have a broader column on the right. So two columns next to each other. Now in the first column, I want to have my app recipe list component. In the second one, I want to have my app recipe detail component, just like that. So that should place these two components next to each other. If we save this and have a look at our app, we indeed see list and detail below each other, simply because due to the console, the viewport was so small. And then it automatically wraps them below each other. So if you have a normal page, they sit next to each other, and I actually want them to wrap below each other on smaller pages. So this is now working too. Now in my recipe list component here, as I said, I somehow want to include that recipe item. So here I will later output a list of items. For now I will simply include the recipe item here, app recipe item, so only the selector. which should now ensure that we no longer see recipe list works, but recipe item works, because that's the only content of our recipe list component for now. So that's looking great. Now for the shopping list, I'll do pretty much the same. In my shopping list component, here I want to display the list, and above it this shopping edit area. So I'll add a row here too. And in this row, let's say with call x as 10 to create a very wide column here, I'll first add my shopping edit component to have this editing area at the top where we can add new ingredients or edit existing ones. And then I want to have a horizontal line here and somehow output my list below this. So that is the rough setup I want to have in this component. So it should work like this. That will be the recipe list component later on. We're going to fill this with more life, but for now, I'm very happy with how that looks. Talking about how it looks, the header really kind of destroys our whole layout here. So let's work on the header in the next lecture, and let's actually bring it into its almost final form already. So we added all the components we created to our templates. Now let's fine-tune them and add the real content we want to have there, starting in the header. Of course, I don't want to have this h1 tag here. Instead, I will use a couple of bootstrap classes to create a nice looking header. So I'll create a wrapping nav element, and on this element I'll add the navbar class and then navbar default. Again, these are just bootstrap classes which will give me this default bootstrap header. In there, I'll place a container fluid div to have my own view container basically in there. And the first thing I want to have here is a header. For that, we get the navbar header class we can add to a div. And in this div, I want to have a clickable header. So I'll add an anchor tag with pointing to hash for now. We'll later, of course, add a route there once we learned how to do this. And this should have the class navbar brand to give this brand-like text style. I'll say recipe book here since this is the name of our application. So that's the header part of our header, so this main brand part. Now let's work on the actual links. For this, I'll add a div which will receive the collapse class and then the navbar collapse class. Now, I won't really use the collapse feature. I won't add a hamburger icon here since we will not have many links on our header anyways. But this gives us some nice styles. And of course, collapse here should have an E at the end, like that. So in here, I now want to have a group of list items, so a group of links in the end. This will be an unordered list with the CSS classes nav and then navbar nav. So make sure to create this unordered list with these classes. And in there, if we add some list items, they will actually sit next to each other. So they will automatically be positioned correctly by Bootstrap. Each list item should hold a link. So here I'll add an anchor tag, also pointing to just hash for now. One for the recipes section, and a second one for the shopping list section. Now with that added, I'll add another area in my header here. This will be another unordered list, which will receive the classes nav, and now also navbar nav like before, but then also navbar right to position these links at the right. And actually, this will only be one link here, which will receive a class of dropdown, this list item will, because later we will add our own directive, which will turn this into a working dropdown, where we can then choose some options to store our data on a server, something we'll also implement later in this course, or fetch it from there. So in this dropdown, I simply want to have my dropdown menu, which when using Bootstrap is added by adding an unordered list with the class dropdown menu. So this will hold the items of this dropdown. And here I'll add a couple of list items, which all hold some links pointing to just hash for now. One for saving data and one for fetching data. Again, this will be filled with working code later. So that's my header. Let's save it and see how it looks. It looks okay. I don't see my dropdown though. The brand looks off. So I'm not entirely happy with that. Let's see what is wrong. The brand is not working because that should be nav bar, not have a H in between. So if you fix this, the brand looks all right. Now what's wrong with the dropdown? Well, the dropdown simply misses the link we would see to open the dropdown. Because this unordered class here simply is the content of the dropdown, we of course also need a link to trigger it. So let's add an anchor tag pointing to hashtag here, where I will say manage, just manage maybe. You could of course change that text. And this should have a class of dropdown toggle, because this will be the button toggling the dropdown in the end. Therefore, it will have a role of button to add some accessibility to this. Not required for this to work correctly though. And with this, now if we save this, we see the dropdown. It would be nice to have a little arrow next to it indicating that it is a dropdown. So next to manage, I'll add a span with a class of caret, which will give us this arrow pointing to the bottom, this arrow here. And now we get a dropdown. It won't work if we click it because we haven't added any code which would open the dropdown. We will do this after the directives section though. So the header is now working. With that, let's move on and let's work on our recipes section. We added the header in the last lecture. Now I want to work on my recipes. So we got the recipes component, which holds the recipe list. Now I also want to fill the list with some life. For this, I'll go into my recipe list component, and we will learn more about ng on init later in the next module, in the components module. For now, what I want to do here is I want to add my recipes array, my array of recipes, which for now is an empty array. And here, let's go back to that slide from the beginning. I want to define how a recipe should look like. We're going to use a recipe a lot throughout this app, and therefore we should definitely clearly define how a recipe looks like so that whenever we use it in any component, we're always talking about the same structure, about the same kind of object. So for this, I will create a model. What is a model then? A model simply is a TypeScript file. So in the recipes folder, because it's going to be the recipe model, I'll add another file. It's called recipe.model.ts. Now .model is optional, but again, you should be descriptive about what's inside a file. And with that, it's pretty clear what will be inside. So I'll add this file. Again, it's now just in the recipes folder. And how should this file look like? First of all, I'm going to export a TS class, a TypeScript class, which is simply named recipe, because we define how a single recipe looks like here. Now you could think that we're going to add something like add model here. And we're not going to do this. There is no decorator like this. And we don't need to do this because we can use vanilla TypeScript for this. A model, in the end, should just be a blueprint for objects we create. And a TypeScript class does just this job. A class can be instantiated, so we can create new objects based on the setup we provide here in this class. So we can define how a recipe should look like in this class. So let's do this. A recipe should have a name. And I'll add an accessor to be really clear about that this is publicly available, so that this can be accessed from outside if using this as an instantiated object. So I'll add public in front of it and then name as the property name. I'll also assign the type of this by adding a colon, and the type will be string. And that is just how you assign types in TypeScript. You add a colon after the property name and then the type you want to assign. So string in this case. I also want to have a description in each recipe. So I'll add my description property, which also is a string because a description is just a text, of course. Now, maybe we also want to store an image for each recipe. So we should have an image path, since we won't store the image itself here, of course. That wouldn't work. We can't store files in our code, but we want to store the path pointing to the image. And we will simply use images from the web here, so this will hold a URL in the end. So that is also a string, a text in the end. That is the basic model for now, the basic blueprint. I'll also add a constructor to it so that we can instantiate this with the new keyword and pass the arguments right to the constructor. So here I expect to receive the name, which will be of type string, the description, I'll just write it a bit shorter here, which will be of type string, and the image path, which will be of type string. In the constructor body, and if that's brand new to you, the constructor simply is a built-in function every class has and which will be executed once you create a new instance of this class. I will show you how this works in a second. So inside of the body of this constructor, we have to assign the arguments we receive here to the properties of our object now, to the properties of our class. So this name, referring to the name up here, to our property, should be equal to name. And now the same for description. This description should be equal to desk. And this image path should be equal to image path. So with that, we got a recipe model we can use. Now let's use it in the next lecture. We added our recipe model, now let's use it. So back to the recipe list component. Here I added my recipes array, and now that we created the model, we can also define the type for this. So we can add colon to inform TypeScript that now we will define the type for this property. And the type will be recipe, so that will use our own model. And not just recipe, but an array of recipes, which is indicated by adding squared brackets after it. So now TypeScript knows the only thing which will ever get stored in this recipes property is an array which holds a couple of recipe objects, or also no such objects, that would be a possibility too, but certainly not a couple of strings or numbers, but objects like this, like defined in our model. Now, to inform TypeScript where this type is coming from, we need to add an import. So I'll import recipe. That is what we named it in here, right? That's our class name. So that's what we have to specify between the curly braces here. And now we have to move up one folder. Since we're in the recipe list folder right now, we have to go to the recipes folder because that is where our recipe model lives. So now I navigated up one folder, just like with the cd command in your terminal. And then it's in the recipe model file, again without the file extension. So with that, we can now use this model, and now we can manage our array of recipes here. And let's start with one recipe, one dummy recipe. So in this array, I will create a new recipe, and I can use the new keyword to create a new object based on this recipe blueprint, based on our class. And now when executing this like a method, we're actually calling the constructor. So now here, we need to pass the arguments we're expecting in this constructor. So name, description, and image path. Now you may choose any data you want here. I'll name this a test recipe. So that will be the title, the name of the recipe. Then the description. This is simply a test maybe. And the image path. Now, as I said, I'm going to use images from the web here. So we're going to use a URL. Now let's simply search for an image, and I will search for recipe. Let's use Google image search. I also want to make sure that I may use whatever I find here. So let's find a recipe, maybe this one here. Let's see if we take this. And deep linking like this, of course, should be done in a real app. This is just for testing this. So if we take this image here and paste the path in here as a string, now we should be able to use this later on once we output this. So with that, we are using our own model. We're using it here in the recipe list component. Of course, we won't be able to see anything for now. So to see that, we should actually do something in the template of the recipe list component. Here, I'm right now only outputting my recipe item, and I want to loop through all these items and use them to display my recipes. For now, what I will do is I will add a bootstrap row first of all, like that. And in that row, I want to add a column with the class colXS12 to have it span over the full width. And here, I will later add a button, or I will add the button right now, but I will later add the functionality to create a new recipe. So here, I'll simply set up a button with the classes button and then button success, where I say new recipe, like this. Now again, this will be hooked up later. So I'll add another row below this, which should now actually hold my list of recipes. Here I'll again use col xs12 to have this span over the full width. And keep in mind this will already be nested inside of this MD5 column, so it's only that wide to begin with. But inside this column I want it to span over the full width. And now here we will later output my recipe items. For now though, let's put the code we will later put into app recipe item into this component here directly. Because right now we will have no way of getting our recipe data down to the recipe item. So that is something I will actually do after the next section once we learned this. But so that we're able to see something, I will add the code for a single recipe item here into the recipe list directly. A single recipe item should be clickable. So it's going to be an anchor tag, because later once we click it we want to select it. And here I will then actually assign another class which will be list group item to make it look like a list group item in Bootstrap. Also add clear fix, otherwise it will probably look wrong. And then I'll add a div which will receive the class pull left, since I want to have this on the left of this list item. In there of h4 tag maybe with the recipe name. This should receive the class list group item heading. Again, these are all Bootstrap classes I'm using here. And there I will later output the name of the recipe, so recipe name for now. We will soon replace this with dynamic content. Below this, I want to have a paragraph with a class of list group item text. And here we will have the description of the recipe. And on the other side, I'll add a span with a class of pull right. In the span, I want to output my image. So here, what I'll do is I'll add a class image responsive so that Bootstrap will resize this image automatically for me. And again, all that content will go into the app recipe item component after the next course section. One more thing I want to set on the image though, I want to add my own style. I'll simply add an inline style here to set the maximum height of that item to 50 pixels so that we can't go above that, and Bootstrap will handle the rest and resize the image appropriately. So that's my setup for a single item. Of course, feel free to fine-tune this to your needs. Now with that, the goal is to replicate this item. Again, we will later put it into its own component, and then fill these spaces here with dynamic data. This is your challenge. We got a recipe list component with our recipes array. The array only holds one item for now. You, of course, are free to add more. But even with that one item, you should be able to replicate this part here as often as needed to create one section of this code for each item in this recipe array, and then fill name, description, and the source attribute here, property, with the right values for this recipe. I will do this in the next lecture, but definitely try doing this on your own first. So were you successful using our recipes array here and replicating this part in the code as often as needed and fill it with the data for the recipe? Now clearly we need ng4 for this. So let's add ng4. This is the directive which allows us to repeat code in our template. And here I want to loop through all the recipes. So I will actually create a local variable named recipe. This name is totally up to you. That will simply store the recipe of each iteration in our loop. And I will loop through all the recipes. So through this recipes property we created here in the TypeScript file. Now with that, I'll also bring this into new lines here to make it a bit easier to read. With that, everywhere inside this ng4 loop, so everywhere here, we can use this recipe now. So let's use it to output the name. We can use string interpolation for that. String interpolation, as you learned, allows us to output some text anywhere in our template. Now we got this single recipe, but that's going to be an object looking like our model. Because remember, The recipes array simply holds an array of our recipes, so a single item simply looks like this. It has a name, a description, and the image path. Well, with this information, we can of course access the name here, like this. And for the description, we can replace this with recipe description. So we're going to use the property names we set up here in the model. And important, you have to use the ones here at the top, of course, because down there, these are only the constructor argument names. They are not available outside of this model. So that's the name and description. Now about that image. First of all, for that alt text, here, that's a normal HTML attribute, of course, I will use string interpolation to output some text here, the recipe name maybe. But regarding the image source itself, and I'm just splitting this over multiple lines to make it a bit easier to read. Regarding that source, we can follow two approaches. You can either use string interpolation here to output recipe image path here, and that should work fine. Or, as an alternative, you cannot use the attribute plus string interpolation, but you could bind to the source property itself. And now here you don't add curly braces, instead just recipe image path, because now we're using property binding and not string interpolation anymore. So here is a great example of where you may use both string interpolation with the normal HTML attribute, or not using the attribute but directly binding to the source property of the image, and then just putting in a valid expression returning what this property expects, in this case a string, between the quotation marks. Now I will go with the property binding approach here, and since I can't comment this out in here without breaking the element, I'm going to remove it, but I want you to keep in mind that both approaches would work. With that, let's save and see if we see something. And actually, that looks pretty good, but looks like the image I chose does not support deep linking. So that's nice, probably good for them. Let me quickly pick a different image then. So I ended up with picking this image here then. So you can see it here. And now we got the list working. This is the style I want to have. Of course, it doesn't do anything if I click it, but that's something we can add in the future. For now, the recipe list component is taking shape. I want to add one more thing though. I don't want to have this button sit directly on top of this list. So what I'll quickly do in my recipe list component here, between the button and the list, I can simply add a horizontal line to have a little bit of a, well, spacing in between and this nice separation. So that's the list, and you should see that if you add more items to that list, that it automatically grows. So if I simply duplicate this, because I'm lazy, you should see the same recipe twice here. So that's working great. Now let's work on the details section next. In the last lecture, we finished this recipe list component. Now let's work on the recipe detail. Now for the recipe detail here, there I want to output the information about the selected recipe. So in here, in this HTML file, I'll add another bootstrap row and then a column spanning over the full width. And keep in mind, the detail will be added to our component here in the recipes component. So it will be in this column on the right to the list. But in there, I want to have a column spanning the full available width. And I want to start by displaying the image. So let's add the image here. And let's add the image responsive class to it. Now I will fill this with life and output some data there later. Below the image, I'll have another row. In this row, also have a column spanning the full width. And here, maybe output the recipe name. So recipe name would be nice to see here. Then maybe another row with another column in there spanning the full width again. And here, what I want to add is I want to have buttons which allow me to manage this recipe. So a button which allows us to add it to the shopping list, and then one which allows us to edit it or to delete it. And actually, we could use a drop-down here. Such a drop-down may be added here by adding a div with the Bootstrap class button group. And again, this is just how to create a nice looking dropdown using the Bootstrap CSS framework, which is the framework we use in this project. Here, we need a button which will open the dropdown. This will be of type button, and it will receive a class of button. Then I'll use the button primary look, which is this bluish button. And very important, it will also receive the class dropdown toggle because it will act as such. On this button, I want to say manage recipe maybe, because we want to allow the user to manage this single recipe. And I want to add this span with the class array to have this arrow pointing to the bottom again. And I will distribute this over multiple lines so that it's really easy to see what's going on here. That's the button opening the dropdown. Below it, I'll have an unordered list with the class dropdown menu, and that is exactly the same setup as we chose in the header here, where we also had this drop-down menu unordered list, because that's the nice thing about Bootstrap. Drop-downs work the same no matter if you place them here in the header or use a separate button for them. And then here, the list items, the separate actions I want to have. The first one, pointing to just hash for now, should actually allow us to add ingredients to shopping list maybe. Let's see if that is too long of a string. Then I want to have a button which allows us to edit recipe and one which allows us to delete the recipe. Maybe let's rename the first one to shopping list so that it's not that much longer than the other ones. With that should be a working dropdown, but we're not going to find out before we implement it. Something we'll do after the directives section. Now below this dropdown here though, I want to add another row. And in this row here, with another column spanning the full width, I want to output the description of this recipe. Well, and then at the very bottom, I'll add the last row for now, also with a full width column. Here, we'll output the ingredients. We're not storing any ingredients on our recipe now, but we'll do so soon. And this is a nice place to output it. So that is the recipe detail component, having all the logic inside of it, which we need to display the details, and then having some options to go somewhere else in our app or to trigger something else in our app, like editing the recipe. We'll of course add all those features throughout the course. And now with that added and set up here, let's see how that looks like. Looks pretty good. We got the name, the description, ingredients, a button which doesn't work, of course. We're going to fix this later in the course. And we don't see an image at the top because right now image, well, doesn't have a source or anything like that. Now, of course, it would be nice if we could select a recipe here in the list and display it in this recipe detail component. But one issue we have with this is we can't get our selected recipe into the detail component because the detail component is added here in our recipes component, where we also have the list. And communicating between the two components, list and detail, is something we don't know how to do right now. We have the same issue in the list component, where we had to put in the code for a single item temporarily, because if we would outsource it to the recipe item component, we couldn't pass our recipe in this loop of recipes to that component. So that cross-component communication is a huge issue right now, but no worries, that is something we're going to dive deeper into in the next course section, and thereafter we'll come back to this and enable all that communication, which allows us to outsource this code into its own component and make these links clickable so that we actually load the right recipe on the right. Before doing this, let's wrap up this section here, this first part of our project, by working on the shopping list feature. We've finished, for now, all our recipes components. Let's work on the shopping list now. Now, the shopping list component, if we have a look at it here in our files, here in the HTML file, we already added some content to its template here. But instead of saying the list, I want to output an unordered list of type list group, or with the class list group, I should say, so using this Bootstrap class. And in there, I want to have clickable list items. So I'll add an anchor tag pointing to just hash for now, again, to make sure it doesn't reload the page accidentally. And then add some bootstrap classes, or one class to be precise, the list group item class to make this look like an item in this unordered list. And I'll even get rid of the anchor tag here, of the ref I should say, and therefore set an inline style to enforce a cursor which looks like the pointer. The reason why I'm removing this is I will later use this like a button, and therefore I don't need this ref element there. It would simply lead to unwanted behaviors. So that will be a single element, a single item on our shopping list. Now to display something here, we need an array of ingredients though. So what I'll do for now is I'll add my ingredients property here to the shopping list, and this will be an empty array. But now, just like with the recipe, we're going to use ingredients a lot throughout our app, also in the recipe section, so we probably should also create a model for this. Let's do this in the next lecture. We're going to use ingredients a lot in our application, so having a model for it makes sense. Now, where do we store this ingredient model? We stored the recipe model in the recipes folder because it belongs there feature-wise. But where does the ingredient model belong to? Well, I believe it belongs in a new folder, the shared folder, which I'm going to create in the app folder. Shared is a fitting name for this folder because it will contain features or elements of our app which are shared across different features, like the ingredient, which we're going to use both in the shopping list and the recipes section. So here I'll create a new file, and this file will be named ingredient.model.ts. In there I will export a class named ingredient, and here we will basically define how an ingredient should look like. Now, how should it look like? It should have a name, so publicly available, which is a string, and an amount, so how many items of that type should we have. So maybe amount here, which would be of type number. Now in the constructor, we of course want to be able to receive that as arguments, name and amount, and then assign it here as before. So this name equals name, and this amount equals amount. Now, that is such a typical setup that we receive the arguments we want to assign in the constructor and then instantly assign them, that TypeScript offers a shortcut. We can get rid of the declaration of our properties up here and get rid of the content in the body of this constructor and simply add an accessor in front of the property name here. So public in front of both arguments. What that will do is, behind the scenes, it will create the same effect we had before, so it will automatically give us properties with the names we specify here as argument names, so name and amount in this case, and it will automatically assign the values we receive in this constructor to these newly created properties. So a nice and convenient shortcut. With that, we defined how an ingredient should look like. Now we can use it in the shopping list component. Let's do this in the next lecture. Let's use our newly created ingredient model. So just like with recipe, we can now define the type for our ingredients array, and this will be of type, well, ingredient array. And of course, for this, we have to import ingredients. So let's quickly do this from, and now we have to move up one folder so that we are in the app folder. And then we have to go into the shared folder, and there it's in the ingredient.model file without the file extension. With that, we can now create one first ingredient. So let's use our ingredient constructor. And we have to pass name and amount here. So the name could be apples, and we want 5, let's say. And then let's also say we want to have some tomatoes, maybe 10. That is our shopping list for now. Now we want to output it here in the component. So we got an anchor tag here, which represents a single item. And now you could put this into its own component too, but since this is going to be such a straightforward, easy item,
I don't see much sense outsourcing it into its own component, though it wouldn't necessarily be bad to do so, but I also don't see a great advantage. There also isn't a lot of business logic attached to this. So I will place ng4 on this anchor tag to loop through all the ingredients, so ingredient of ingredients, and now we can output the ingredient data here inside our anchor tag. So it makes sense to output the ingredient name, I believe, and then maybe in parentheses thereafter, and these parentheses here are no Angular syntax, that is normal text here I'm outputting. Inside the parentheses, I'm going to use string interpolation to also output ingredient amount. With that, if we now save this, we already see our shopping list here at the bottom. The last missing piece I want to add is this shopping list added section here, which should display as an input field, which then allows us to actually edit our items or add new ones. At least later in the course, it will add this functionality. So let's work on the shopping list added component. In its template, I want to add a bootstrap row, and in there I want to have a column spanning the full width, like that. And in there, I'll add a form element. Now important, remove the action because we're not going to send a request to the server once this is submitted. But we will have a look at submitting forms later in this course. We have a whole section about that, and that is when we will fill this form with more life. For now in this form, I want to have a row, and this should now maybe have a width of only 5 on small devices. On very small devices, it should span the full width, which is why I'm using the SM class here. And it should also have the form group bootstrap class attached to it, this div. And in here, I'll have a label for the name of my item. So I'll say name here as a text. And I'll add an input of type text, that's correct, with ID name, so that this label refers to it. And then here, this should receive the class form control to make it look nice in Bootstrap's world. Next to it, and that is why I chose to not give this column the full width, I want to have another div with a width of, let's say, 2, because it's going to be a very small input. Then also the form group div, or a class here. And in there, another label for the amount, so let's say amount here. And then an input of type text here, or maybe even of type number, to be honest, which gets the ID, amount, and then the class form control. So that should give us the inputs the user will later use to add new ingredients. Below my inputs here, I'll add another row, which will now span the full width. And here I want to have a couple of buttons which allow me to manage this item creation or editing process. The first button I'll add here with the style of button success to make it look green in Bootstrap's world will be of type submit, because this button should actually submit the form later. And I will say add there because it allows us to add a new item. The second button will be of type button because it should not submit the form. This button should simply delete the selected recipe ingredient, because later we will be able to click an ingredient. It will then be loaded into the input fields up here. And if we click delete, well, it simply will be removed. So delete item, or just delete maybe. And then a last one, which allows us to clear the form. If we loaded the item, we wanted to add it, and then decided to not do that, I want to have a button which allows me to clear the form. So here I will maybe make this blue with button primary. If we save this, this is actually how I want this form to look. We have an input field for the amount, for the name, and our buttons, which later will be filled with some life so that we can manage this ingredient. So that's the first basic setup. Of course, we can improve this app. For example, I don't want to have recipes and shopping list component on the same page.
We will fix this soon, first temporarily, and then with a real good solution later in the course. And I also want to have my components communicate with each other so that we can actually store the content of the items in our recipe list in their own component, that we can select a recipe here and load it in the detail section, and so on. For now, though, that is how far we can go with the knowledge we gathered. The blocking thing right now is the component communication, and that is why we're going to dive into this in the next course section. See you there, and then see you back in this project later in the course. Welcome to another course module. By now, the basics should be set, and we had a closer look at what makes up an Angular app. Now, chances are you already encountered your first error in your app. We even had some errors together in the apps we built. Now, fixing these errors is of course very important and not always straightforward. That is why in this section we're going to have a brief look at the tools we have at our disposal for fixing errors in our Angular app. Here's a little example app attached to this lecture, which looks nice but won't work as expected. We are on our server's dashboard, we could say, but if I click Add Server to add a new server, watch what happens. We get an error. Now, you might get such errors a lot, and generally, you might not always have your developer console open, though for developing that's a good idea. But if something doesn't work the way you expect it to work, like here when you click the button and nothing happens, opening the console, the developer tools, and there the JavaScript console is a great idea. Now here we clearly get an error message, and error messages have gotten better in Angular, so chances are the error message is indeed helpful. So let's have a look at the error message. You should find it right at the top, and here it says that in app component, that's the first important information piece. In the inline template, then this would be the line number and then the column where in the line. So line 4, now let's see if that is helpful. That there the error was caused because we cannot read the property push of undefined. Well, we get a couple of useful information pieces here. So let's go to the app component then, and let's have a look at it. If we go there, well, the line 4 argument is only kind of helpful because line 4 is neither the problematic core code in our template nor in the TypeScript file. It reports as line 4 because in the end everything gets merged together and rebuilt, so that is why probably the code then is triggered in line 4 in the final code, but not in our code. Still, we got one important clue here, property push of undefined. So we try to call push on something which is not defined at the point of time we do call it. So if we have a look at our code here, we see that there's only one place where we call push, and that is of course here in the on or add server method, which makes sense because this is the method which gets triggered once we click the button. So that would have been another way of finding where the problematic code has to be. As this error occurred when we click the button, it probably is somewhere in the method which is then executed. So here there's something wrong with pushing, though not with pushing itself. Remember, it said push of undefined. So the thing we're calling push on is undefined, so that would be this service. How can this service be undefined? We do declare it up here, right? That's exactly the issue in this case. We do declare it here, but we don't define it. We tell TypeScript there's going to be a property called servers, but we don't initialize it. It doesn't have any value assigned to it. It's not an empty array, it's not a string, it's nothing. So to fix our code, we simply have to make sure that before trying to push a new item on servers, we set servers to an array, because otherwise it could be anything. It's undefined in the end. So pushing is not as supported here. So what we can do is we can simply initialize an empty array here at the beginning, and with this little change in place, this should now work as expected. Once it reloads and we click add server, now we can add our servers to this list. So this was a brief example for a potential error message, how to read it and how to try to get to the root of the error. Now, of course, it's impossible for me to show all possible error messages and what can go wrong. And there are some more tricky error messages, But it's always great to not panic, but have a look at the message, read which file it points to, read the exact message. There are even error messages in Angular which are much clearer than the one I just showed you. And with that, you should be able to narrow down the issue and hopefully solve it. Sometimes reading error messages is not enough, or you don't even get an error message. Like here, I got my servers here, right? And if I click on them, I can delete them and it seems to work until I click the last one, or if I deleted all of them, the only one. So deleting the last server is not working. I can click it as often as I want. It's not going away. Now, if you have a look at our code at the template first, we see that on each list item, I call onRemoveServer, and I do pass the index of the current iteration, to that method. Now, of course, we could simply dive into the TypeScript code here and have a look at this. And there we see, well, we get the position of this item, and then we simply call splice to remove the item, the element in this array at this position. So you might say, well, that looks all right. Sometimes it's just not super easy to debug a message like this, because we're not getting an error message, but we get a logical error in our app. Now, debugging is supported by developer tools in the browser though. So it would be great if we could simply check at runtime why this is not working. In Chrome, you can simply go to Sources, and here you will find all these sources imported on this page. So in this case, all our script bundles. Now, there are a couple of bundles as you see. The important one for us is of course the main bundle. And if we have a look at the main bundle, yeah, that's not super easy to debug, right? Now, theoretically, of course, we can have a look at it. And there, let's find, this seems to be our template here with container and row. And maybe we can find the line responsible for splicing here. And now maybe we want to debug here. And if you try to place a breakpoint here, which you of course can do in your developer tools, you see something changed. It jumped to the app component TypeScript file. Now remember, TypeScript is not what runs in the browser. So there, the JavaScript, these bundles here are used. How can we now access TypeScript? Because these JavaScript files support source maps. Source maps are a little addition the CLI kind of adds to our bundles, which allow the browser to translate our JavaScript code to TypeScript, or to simply map the JavaScript code to our TypeScript files. In development only, these source maps will be stripped out for production, of course. So this is a great feature because now we can place breakpoints here in our TypeScript code. And if I now click somewhere, you see it indeed pauses. And now we can check and even see that ID currently is 2, which makes sense because I clicked this item here, which has an ID of 2. Just to show this again, here now with this item, now it's ID 1 because, again, the middle item, which is ID 1 in this case because we start at 0 for the first item. And then we see that position is undefined right now. Now we can move on a step. Now we see position is 2. And now we can also check servers. And in servers we see, well, position 2, of course, is the last server in the list. So if we let this continue, it looks like the middle one was removed, but actually the last one was removed. And we can confirm this by checking this. If I click on the last one, which was the thing which was not working, we see ID is 1, makes sense, it's the second element of 2 and the ID starts at 0, so ID 1 makes sense. But now position is 2 because we add 1 to the ID. So now we try to delete the element at position 2 in this servers array, and clearly we don't have that element here. We only have 2 elements with positions 0 and 1. So the logical error in our code is that we add 1 to the ID here. And that is how we could debug that with the TypeScript code here with that source map. That, of course, would allow us to now fix this bug. Now, correctly, you might say, that's awesome, that's great, but if I have to scan my main bundle to then click somewhere to open the TypeScript file, that's not really a great, tool, because if that bundle grows bigger, it gets even harder to find the right, spot. Therefore, you can directly access your TypeScript files. Under Webpack here, you should find a couple of subfolders. And if you open up the dot folder here and then source here in the app folder and so on, you find all your TypeScript files. So here is where you can directly access your TypeScript files in the same structure as in your project to easily find the file you want to dive into and you want to debug with the Chrome developer tools. So that is another great tool at your disposal besides reading error messages, using the debugger with source maps, with TypeScript files, to either of course dive into errors for which you have error messages, but also into logical errors like here. Welcome to a new module. We learned the basics and we set up our first project. Additionally, we had a look at how to find and fix errors. Now I want to dive deeper into components and data binding and how you can connect both concepts even closer to now make the next big step in your application. Let's start with an example project. You can find it attached to this in the next lecture and enhance this project to take advantage of components and data binding to make it a better app. That's the project you can find attached to this lecture here. It allows us to define a server name here and then some content for the server. And then we can either add a server or a blueprint. And as you can see, both look pretty similar, but the server is bold and red or has some bold and red text. The blueprint has some italic blue text. So that's the difference here. Now, this app is all running in one component as of now, in the app component. Here in the template we got a lot of code and we can do better. We can split this up because that's not ideal having all that logic in this component here. Maybe splitting it up makes sense because that would also allow us, if we build a bigger app, to reuse parts of that. So how could we split this up? We could create a new component for this whole cockpit here where we enter a name and content and click the buttons. And of course, we could also create a component for an individual server. And with that, we should have a much leaner app component HTML file, and we would bundle our business logic better into individual components. Now we learned how to create new components. I will use the CLI. You could of course also do it manually. And I will create new components with ng-g. And then let's say the first component could be this cockpit here. So I will simply name it cockpit component. Now as an addition, we can type --spec false to make sure this spec, this testing file is not getting created. I deleted it all the time anyways. And then I will repeat this step for another new component, which I will simply name server element. Server element because it could either be a server or a blueprint in this example. So with that, we got two new folders in our app component. So two new components, thus far nothing you don't know. Now we can of course take our code here from the app component HTML file from this template. So for example, this first bootstrap row here, cut it here and add it to our cockpit like this. Now, of course, if we remove the template part here, we also have to remove, or we have to move the methods we're calling here. So on add server and on add blueprint. So in the TypeScript code here, I will copy both, or I will cut both elements here and move them over to our cockpit. And we will soon also come to ng on init and what this does as a side note. Now, of course, my issue is that I try to push this to arrays or to an array which doesn't exist here. Server elements, that array is still in the app component. We could, of course, move that. Oh, and maybe I should also move that closing curly brace. We could, of course, move this server elements array, but then we would no longer have it in our app component, and we will need it there too, though. Because there we still will need to replicate these server elements to create the, service we output here. So, as a first step, what I can move, of course, cut and paste, are the two properties which are used here with two-way binding. So I can move that to the cockpit, but we will have to see what we do about this server elements array.
For now, let's go back to the app component HTML file and take a single server here. So this panel div here. So with that, all we have here now is the row and the column, and the other part will go into the HTML file of the server element, because that is a single server. Now here, of course, we have this loop, and that's not what I want to have in here, so I will get rid of it there, because I still want to manage my array of server elements in the app component, because we somehow need to be able to manipulate it from the cockpit and then replicate it in the app component to create multiple instances of this server element component, which is only a single server. Keep this in mind, this is not the list of servers. Now, of course, you could set this up differently, but this is the approach I will go with, and this approach won't work right now. We also try to access an element property now inside of our server element component, which we also don't have. So a couple of things to fix. I like the general way we split up our app, and that we now can add our app cockpit here, where we before had the full HTML code, we moved over there, and that we can add our app server element component here, and that we could also replicate this with ng4, let server element of server elements. So we can, of course, also place ng4 on a component, as you already learned before. So I like that. But I don't like that the app is broken, and if we have a look at it, that, well, we simply get an error that a couple of properties are unknown. So we somehow, and that is a key part, need to get the new server we add in the cockpit to this array of servers in our app component. So we kind of need to inform our app component that one of its child components, the app cockpit, changed, or that something changed there to which we should react, a new server was added. And then we also need to get the data we got from the cockpit, so this new server, which is managed in this array of servers in the app component, we need to get the individual server of a single loop iteration here down to the app server element. So we need to pass data between components, and that, of course, is a super important task we haven't touched yet, but we will dive deeper into right now. In the last lecture, we split up our app into multiple components, which is great, that is why we use components. But one issue is that we need to pass data between these components. Now, in the basics section, we learned about property and event binding. And there we used it to, for example, bind the disabled property of a HTML element. So we kind of passed data to that element. We passed the information that it should be disabled, that this is set to true, to this HTML element. The same with event binding. When we clicked this HTML button, something happened. This button emitted an event to which we were able to listen. So it sent us some data. The same for the input, where we even used that data with $event, if you remember this. There we got data from the input element. This is exactly the behavior we need now with our own components. We need to be able to send data into a component or receive data, receive an event. And Angular, of course, gives us great tools to implement this flow. We can use property and event binding not only on HTML elements and their native properties and events, as we did thus far. We can also use it on directives. And we also did this with ngClass and ngStyle, there we use property binding. But, and that is important, we can also use it on our own components and bind to our own custom properties and custom events. We can emit our own events. That is what I'll dive into in the next lecture, starting with custom property binding. So we learned that we can use property binding to bind to our own properties of our components. Now this is what I'll start with. So to temporarily prevent my app from crashing, I will simply comment out the code in the cockpit so that this doesn't give us any errors anymore, for now. We won't be able to use it, but it will not crash. Now in the server component, server element component, if we have a look at its TypeScript, at its HTML file, you see that we try to access the element, the single server element. And therefore, we should create a property in this TypeScript file element which represents our server.
We can even assign a type by adding a colon and then simply defining the type, which will be a JavaScript object, hence the curly braces. And just because it's important, this is not the value, this is TypeScript's syntax for defining the type to make sure that element may only have this type. And we then know that an element will have, well, what we're trying to access here, a type, a name, and a content. So we'll have a type, and type on its own will be of type string. We will then have a name, which will be a string, and we will have a content, which will be a string. So that is all now our type definition for a property we want to use in our HTML code. We use here in all these places. Now still, this element, this property, is part of this component only, of the server element component. We can't access it from outside. Now it would be great if in our app component, where we manage our server, or our array of server elements I should say, if we could somehow access this property. Because let's say, just so that we can see something, we start with one server here, which is of type server, has a name of test server, and a content of just a test. And just to be super clear, these colons here are not type definitions. We're on the right side of the equal sign, so here we are assigning a value, and the value here simply is a JavaScript object, and in JavaScript objects, we simply assign key value pairs, or we create key value pairs by having the key, then the colon, and then the value. So normal JavaScript syntax here. So now we got our server elements array. We're looping through this array here on the app server element. And in the app server element, we have our element property. So a property in that component. Now we want to access this component from outside. So it would be great if we could bind to it, just like we were able to bind to disabled. So maybe add squared brackets, enter the name of the property in between, so the name of the property in the component, here, this name, and then assign the server element, so simply the element we store for each iteration in this variable here. Would be great if we could do this, and if we try this and our app reloads, we see that we get an error that we can't bind to element because it isn't a known property of app server element. Now you might say, that is not true. It is a property of server element. Here, we defined it as a property. It's even public, right? We didn't add private in front of it or anything like that. So why can't we access it? Simple answer, because by default, all properties of components are only accessible inside these components, not from outside. And that generally is a good thing. You don't want to make all your properties bindable from outside. So you have to be explicit about which properties you want to expose to the world, so to say. So if you want to allow parent components to be able to bind to this property, you need to add something to that element property. You need to add a decorator. Remember, I said that decorators are not only available for classes. Here we're going to add one to this property. The decorator we need to add is @input. And here important, you need to execute it. It's like a function in the end, so add parentheses. And input now needs to be imported from @AngularCore. With this in place, now we are successfully exposing this property to the world. So now any parent component, any component hosting our server element component, so implementing it through its selector like we do here, is now able to bind to element. And I can demonstrate this if we save this. You now see just a test here. You see our component because now we replicate this component for, well, each element in the array, and we successfully can pass the element, the property, down to that component and bind to the element property in that component. And this is how you can set up custom property binding on your own events, exposing your own properties to the components where you implement these components through the selector.
In the last lecture, we learned something crucial. We learned how to bind to our own properties with @input parentheses in front of it. Super important. Now, you can even configure this a bit more. Sometimes you don't want to use the same property outside of the component as you use inside of it. So inside this component, you might say element is exactly the property name I want to use because it makes the most sense. But outside, so here, you maybe don't want to bind to element. Maybe you want to bind to srv element to make clear it's a server element, anything like that. Now that would of course not work because now you would try to bind to a property. Angular doesn't know that it would be bindable because there is no server element property in this component with @input in front of it. You can assign an alias. You can pass an argument to @input with the property name as you want to have it outside of this component. So srv element could be added here. And now from the outside, so from the component where you implement this component, you now have to target srv element if you want to bind to this property. Element will no longer work. It has to be srv element now, which is why now, with these two places changed in the app component and in the server element component, we see the same as before, but now binding through the alias. And just again, to be really sure, or to make this really clear, now you have to use srv element. Element will no longer work. So that's a little bonus, a little alternative in case you want to bind to some other property name outside of the component. This is how you assign an alias. Great. In the last lectures, we learned something crucial, something we will use a lot in our demo app in this course and probably in any app. How to pass data from a component down to another component which was implemented there. Now about the other direction. What if we have a component and something changes in there and we want to inform our parent component, so the component which implements the other component? For example, here in app component, we're implementing app cockpit, and in this child component in app cockpit, something can change because here we got two buttons, and when we click the buttons, we want to do something. And right now, the code which would normally get executed was simply commented out. So here, we want to inform our parent component, the app component in this case, that a new server or a new blueprint was created. So in our app component, we maybe still want to implement these two methods. So let's simply add them here. However, I will adjust the names and say on server added, because these methods will kind of only be executed after this button has been clicked. So not once the button is clicked, but thereafter, once we really already are done creating the server, so to say. So on server added and on blueprint added sound like more appropriate names here in the app component. Then, however, we can comment out this code and still create a new server or a new blueprint. However, this will not work as expected here because we're referencing new server name and new server content which are not available in the app component. But that is exactly the information we kind of want to pass from the cockpit to the app component, because the app component is the central place in our app for now, which manages this array of servers. So how can we emit an event, our own event? How can we inform our app component? It would be great if it would look something like this. On the app cockpit, so in the app component HTML file where we implement app cockpit, it would be great if we could listen to server created, any name you like, but that would be a fitting name for the kind of event we want to listen to. Of course, this event doesn't exist by default. So just like we listen to click, now we want to listen to some event like this, server created. And once a server was created, we execute some code. So just like in any other built-in event like click, here on the right side of the equal sign between the quotation marks, we want to call on server added, the method we prepared for this. And we even expect to get some data with $event. This is how you could catch this data. That could be some object which gives us the required information about that server, like the name and the content. So in onServerAdded now, here, we would expect to get event data, or let's say we would actually expect to get the server data. And that could be of type, let's say a JavaScript object which has a name field with a string, or let's be more explicit, let's name it server name, which is of type string, and server content, which is of type string. So that would be the type of object we expect to get in this method. And with that, we could use it here and use server data, server name to assign it as a name for our newly created server, the one we push onto our array here. And the same, of course, down here for the content. So that is how it should work. We get this data in onServerAdded, and we call onServerAdded once our custom event occurs on the cockpit component. And this event even should give us this data we expect to get, and we catch it with $event. Now, obviously, we can also replicate this for the, let's say, blueprint created event. Here we would execute on blueprint added. And of course, you could also kind of merge these two methods. I keep them separated to be really clear about what's happening here. And there again, we also expect to get our, well, blueprint data in this case. So blueprint data maybe. And there we also would receive the information we require, like the server name, and then of course also the content. This is how it should work. Now in the cockpit component, we actually need to emit our own event. We are waiting for events named server created and blueprint created, maybe with a lowercase p. So in the cockpit component, I kind of want to create two new properties here. Properties, that's important. Server created and blueprint created. Now before, we placed add input in front of them to mark them as properties you can set from outside. Now we want to do the opposite. We want to make sure that both properties kind of are events we can emit. And to make them events, we first of all have to assign a new value, new event emitter, and event emitter needs to be imported from @Angular core. So you should add this import here at the top. Event emitter is a generic type, which is indicated in TypeScript by using this smaller than and greater than sign. And in between, you simply define the type of event data you're going to emit. And here, well, we know this will just be the data we expect in the app component. So this will be an object with a server name and server content. So we can pass this in between these smaller and greater than signs. And important, add parentheses in the end to call the constructor of event emitter and create a new event emitter object, which is now stored in server created. I'll do the same for blueprint created. Now we get two event emitters, and that's the first step. Event emitter is an object in the Angular framework which allows you to emit your own events. What we can do with that is in onAddServer, we can now call server created, and here we can call the emit method. This will, well, like the name implies, emit a new event of this type, so of the server created here, using this event emitter. Well, and here we simply want to create the object or pass the object we kind of said we would pass here. An object where we have a server name, which of course is our new server name, so whatever we save here. And then a server content with the value of new server content as a value. And I can split this over two lines to make it a bit easier to read. So this is what we emit in onAddServer. And let's do the same for onAddBlueprint. Here, however, of course, we use blueprint created, the second event we set up there. So with that, we're emitting our own events, pretty awesome. We're passing the data. One piece is missing though. Remember, we added add input,
to make a property bindable from outside. Now we need to add something to server created and blueprint created to make it kind of listenable from outside. That something is another decorator, and it's not input because we're not getting something passed into this component. It's add output with parentheses because we're passing something out of the component. We're passing our own event out of the component. And the same for blueprint created. Make sure to import output from add Angular core. With this in place, now if we save this and have a look at our application, if we create a new server, some test content, and we click add server, you see it gets displayed down there, so it successfully emits this event. Let's check the same for the blueprint. That looks pretty good too. So with that, we got our app working again, but now split up into several components which can communicate with each other. And that is a key building block because component communication is so important. In the last lecture, you learned how to use add output to enable other components to listen to your own custom events, which you could create with event emitter. Now, just like on add input, on add output, you also can assign an alias. Like here for blueprint created, maybe you want to name this BP created. Now with this is the event you can listen to from outside. So in the app component, where we try to listen, we now need to rename it here too and listen to BP created, which is now just like on add input, the one and only event you can listen to when it comes to this blueprint created event. The other name, blueprint created here, will not be exposed to the outside anymore, so it has to be BP created now. All the rest stays untouched and works just like before. Let me quickly summarize what we learned thus far because it really is important. This component communication is such a key feature. And with add input and the ability to make your properties bindable from outside, from the parent component using this component. And the same for add output, which allows parent components using this component to listen to your own events which you created with new event emitter. These are such important features in your app. We will use it in the recipe book in the next section because this really allows you to make your application very dynamic, use many components and have them talk to each other. Now, one issue you could say with that approach is that if you want to talk between two components sitting next to each other, it can get kind of complicated to emit an event in one component, change something in the parent component, and then pass this new data down to the child component. And these chains of inputs and outputs can really grow more complex. So whilst this is absolutely fine here, and this is a feature you will use a lot because it's not bad at all, there are some use cases where the distance between two components that should talk to each other is so great that building a chain of outputs and inputs is not very practical. That is why in the services section of this course, I will then show you another approach of having components talk to each other, though, and that is important, this will not be a better approach, it is just a better tool for a specific use case. A use case like this here is typically handled with input and output like we're doing it here. It's the perfect tool for this job and it's so important, you will see it getting used a lot throughout the rest of this course. I'm not sure if you noticed it in the last lectures. With our working application, if I add servers and blueprints, something changed. A new server down here in the blueprint, as well as the paragraph right at the top, no longer has a blue color. Now it was colored blue before, because in the app component CSS file, we defined that paragraphs should have a blue text color. But both paragraphs were moved. They are no longer part of our app component here. The first paragraph is part of the cockpit, and the second paragraph, well, that is inside of our server element. But isn't that strange? Here,
on this CSS definition, we just say paragraph. So it should affect all paragraphs in our whole app. Now you might say, well, no, it's in the app component CSS file, so clearly it only belongs to this template. But is that so clear? Because the way CSS works, it doesn't really care in which CSS file you define a rule. It simply is applied to the whole document normally. So this actually is a behavior enforced by Angular, which is not the default behavior of the browser. So whilst, of course, these CSS files have the goal of encapsulating styles for the component they belong to, this again is not a default behavior. Angular gives us this behavior. And it's a great behavior because with that, we can make sure that whichever styles we define in a CSS file will only get applied to the component they belong to. However, here, of course, this means that now we would have to copy this blue color here to all our other, components where we want to use it. Well, I never wanted to use it on the cockpit anyways, but I will copy it to the server element. And if we now change this and let it reload and enter something here and add a new blueprint, now you see this is blue again. Now it's interesting if we inspect this text here in the developer tools, you see that if you have a look at the styles, clearly here we assign a blue color. But do you see that? The selector changed. Before we had just P here, just paragraph. Now it's paragraph and then this very strange attribute, _ng-content -ejo-2. Well, I don't know about you, but I didn't add it. You can see this attribute here on the paragraph. That is why this style gets applied here, because this style definition says make every text blue, which is in a paragraph, where the paragraph has this attribute, something which is true for the paragraph holding this specific text. Now the other paragraph we have in App Cockpit, here in the div, this paragraph does have a different attribute, _ng-content ejo1. Down here we have ejo2. That is why the styling gets not applied to this paragraph. And all these strange attributes, which you can see all over the place here, all these strange attributes are applied to their specific elements by Angular. Angular, as I told you, enforces this style encapsulation. And it can't do that magically. So the way it does it is it simply gives the same attribute to all elements in a component. So all elements in this cockpit component have ng-content ejo1 attached to it, as you can see. And it does this for each component with different unique attribute names, ejo1 and ejo0 and ejo2. And with that, it can make sure that once it changed your style selector, it automatically adds this attribute selector to all your styles defined for a component, that these styles get only applied to elements of that component. This is how it enforces this behavior. It kind of emulates the shadow DOM. The shadow DOM is a technology not supported by all browsers, where each element has its kind of own shadow DOM behind it, where you then could assign styles to each element. But as this technology is not supported by all browsers, this is how Angular emulates it. And that is the default behavior of view encapsulation in Angular. In the last lecture, you learned how Angular encapsulates your styles. Now you can override this encapsulation though. If you go back to your code, to the server element component, you can add something to the add component decorator. It's called encapsulation, this property, and there as a value you can access view encapsulation, which needs to be imported from add Angular core, so make sure to add this import. And then you can choose between 3 modes. Emulated is the default, so you don't need to add this. None, if you add this, would make sure that if we have a look at our component again, and we inspect our server element, that now in here, we don't see these strange attributes being added to our elements. Therefore, this component now does not use view encapsulation. The other components still will use it. There you still see these attributes. But if you now define any styles for this component in the CSS file of this component, they will actually get applied globally. And I can demonstrate this by going into this CSS file, and if I change the label color, and the label is in the cockpit, not in this component, to red, yeah, now you will see the label there is overwritten. Whilst this label of course still has its custom unique attribute, it still is a label in the end. And in this server element component, we disabled encapsulation. So there our selectors aren't changed by Angular. They don't receive their unique selector. Therefore, they are enforced, they are used application-wide, also affecting other components. Might be the behavior you want. Chances are that this is not the case, but it's important to know that you can change this behavior. Now, besides none, you also could choose native, and native uses the Shadow DOM technology. This should give you the same result as before with emulated, but only in browsers which support it, which is why for most cases you want to choose emulated, but be aware that you could switch to non or native here too. So I will go back to emulated, which again you wouldn't have to add, it's the default anyways. With that, our label should no longer be red now. So that is how you can change it and how view encapsulation works. A nice tool ensuring that by default only your component receives the styles you define for it. But as you learned, it can be overwritten. Back in the application we built throughout the first lectures of this course with our cockpit and the server element component, with using output and input to pass data around our own custom property and event binding. Now in the cockpit, right now I'm using two-way data binding to get the server name and content. Now there's nothing wrong with that, but maybe we don't need to use two-way data binding. Since I only want to save or use the data at the point of time I click the button, the add server or the add server blueprint button, it would be enough to get the value of the input at this point of time. And there is a nice way we can achieve just that. So I'll duplicate this and comment out the old solution, and now I'll structure it out over a couple of lines and remove the two-way binding. There, the other option we would have is to place a local reference on that element. A local reference can be placed on any HTML element, so not only on an input element, on anything you see here in the template, and you add it with a hashtag and then a name of your choice, like for example server name, since this is, well, what this reference will hold, a reference to this element, so maybe server name input. Now important, this reference, as I just said, will hold a reference to this element. So not to the value we entered there, to the whole HTML element with all its properties. We can see this if we pass this now as an argument once we click add server on add server. Here I can pass server name input because the other important thing you need to know about references besides how to create them is that you can use them everywhere in your template, but important, only there, not inside your TypeScript code, only in the template. But we do call the method here inside the template, of course. So here we can use server name input, and that is a way how we can pass it to the TypeScript code. Because in onAddServer, we now know that we will receive the name input. You could also name it server name input. And if we log this, we can analyze what this actually means, what we actually got here. So let's save this and let our app reload. And now if I test something and enter something here and I click add server, of course this was broken here, this is broken because we're not fetching the data correctly right now. You see, we actually got the input element itself. So this is the element we got here. That is what the local reference gives us. The element with all its properties. So here we could also output value, the value of this input, since we know that an input element has a value. And of course, this will depend on which kind of element you placed your local reference on. Not all elements have the same properties. So with this, if we try this again, you'd see we now print test because we access the value of this input to which we got access through the local reference. So local references, a very nice feature to get access to some elements in your template and then use that either directly in the template. You could also output server name input value here, or you can pass it on like we do to use it in the TypeScript code. A nice and handy feature. Now with that being passed, we can use it here to not only log our data to the console, but instead here, once we define or once we create the server, we could access name input value. And we should also be explicit about the type. We know that this will be a HTML input element, so we know that this value property will be there. Now the same can of course be done on the blueprint, where we can also replace this new server name with name input and then value. And with that, we can get rid of new server name. We don't need it anymore. I will comment it out so that we still have it there for reference, but the new approach now only uses this local reference. Now for this to work, we of course also need to pass this reference to our onAddBlueprint method. So these are local references. In the last lecture, we learned about local references. Now, there is also another way of getting access to local references or to any element actually directly from within our TypeScript code. Right now, we're passing the reference here when we call a method, and that works fine. But sometimes you want to get access before we call the method. And there is a nice little decorator we can use in TypeScript to get this access. Let's do the same for the server content. So here I will quickly duplicate that input and comment out the old solution using two-way binding. And the new solution will not use two-way binding, but instead this will now also have a local reference, the server content input maybe. Now in the cockpit component, I will also comment out the old new server content here. And I will add a new property which I'll name server content input. Now server content input like this is just a property, but we can add viewChild in front of it, this decorator with parentheses, and we need to import viewChild from @AngularCore. Now viewChild like this won't work. We need to pass an argument here. And this argument actually is the selector of the element, how we want to select the element. And selector now not like a CSS selector, but for example, we can simply pass as a string the name of a local reference. So server content input could now be passed as a string. If you don't want to pass a string but want to select a component, you could simply pass the component type here. So in the cockpit, we don't use any other components, but in the app component, we could pass cockpit component. So the type like this, not like a string, to get access to the first occurrence of this cockpit component in the app component. But here I'll switch this back to getting access to the local reference, which probably is the use case you'll see the most often. And with that, we now get access to our server content input. Now, what does this actually hold then? Let's quickly comment out this code so that it doesn't break. And let's log this server content input. So our property here, which is kind of set through viewChild. So with this, if I also comment this out down here so that we can run our app, and if I now save this and we go back to our application and I enter something here and I click add server, we see that this is of type element_ref. So unlike the local reference we passed directly from the template via the method, which was the element itself, this is of type element_ref. So we can set this type here, element_ref, a reference to that element. Element_ref needs to be imported from @AngularCore. It's an Angular type. So this element_ref, however, has a useful property we can use, and that's the native element property. We can use server content, this server content input here, and then native element to get access to the underlying element, which now has a value because this will now be the input element. Now we can do the same, of course, for the onAddBlueprint method. And with this, we get direct access to elements in our DOM, in our template, through addViewChild. And you should see that this now works again if we enter some content here and click the buttons. Works perfectly, now without two-way binding, but with local references passed to methods or local references fetched through ViewChild. Now, one important thing to watch out for is you should not change the element through this, because of course you could use our server content input, the native element, and then set value to something, right? You can't do this. And if we actually do this like this and I click Add Server Blueprint, you see something was now added here. I strongly recommend not doing this. You should not access the DOM like this. Angular offers you a better way of accessing the DOM, and you will learn about this in the Directives section. Generally, you should use the other tools like string interpolation and property binding if you want to output something in the DOM, and not directly mess with any elements you can get, even though if you have gotten them through Angular. So we learned a lot throughout this section. We learned how to pass data around, how to get access to elements in our DOM, how to use local references, so our application now is much more dynamic. We got much more tools to interact between the different pieces we have in our app. Now, there is another way we can pass data around, the last way for now. In our server element component here, right now we check if we have a type server or a type blueprint server, right? Nothing wrong with that, but sometimes you have complex HTML code like this, which you want to pass into a component from outside. So imagine you don't want to set this up inside the component here. I cut it. Instead, in the app component, you somehow want to add this here between the opening and closing element of your own component. And there we simply would have to replace element with server element, and we should expect this to work, right? So if we save this and let it reload and we add a new server, we don't get an error, but the content is also not there. And that is the default behavior. Everything you place between the opening and closing tag of your own component is lost by default, is simply removed from the DOM. Angular will not take care about it. But you can change this. There is a special directive, and it is a directive even though it looks like a component, but it doesn't have its own template. A special directive you can add in the server element components template here. In the place where I want to render the content, I can add ng content. Opening and closing, again, it still is a directive, just using this element-like selector. And this serves as a hook you can place in your component to mark the place for Angular where it should add any content it finds between the opening and closing tag here. So this content in this case. With this tiny addition, you should see that once you save this and let it reload, if we add this, and we click Add Server, you now see the content is back. It looks exactly the way it looked before, but technically something totally different works or happens here. Now we add this via the ng content hook. We add it between the opening and closing tags, and therefore it will be projected into your component, projected into your server element component. A nice feature, especially if you think about building reusable widgets, like a tab widget, where each tab will have a content which probably comes from some other source and which you don't want to pass through property binding, which always would be an alternative. But if it's more complex HTML code, property binding really is not the best solution, because Angular will escape HTML tags there to prevent cross-site scripting attacks from happening, and you could kind of work around that, but really ng-content then is how you want to display this. And that is a great tool to have at your disposal. Whew. We're nearing the end of this section, but there's one thing you might have recognized before where you weren't sure what it does. What's up with this ng-on-init method we have in new components created through the CLI? What's it doing? ng-on-init is a lifecycle hook, and Angular supports a couple of lifecycle hooks. Let's take a closer look. If a new component is created in Angular, and of course Angular is responsible for creating these components, when it finds one of our selectors, for example, it will instantiate a new version of that component and add it into the DOM. So once a new component is instantiated, Angular goes through a couple of different phases in this creation process. And it will actually give us a chance to hook into these phases and execute some code. We can hook into these phases by implementing some methods Angular will call if they are present. The first phase, the first hook we can hook into is ng-on-changes, and this may actually be executed multiple times. It's executed right at the start when a new component is created, but thereafter it's also always called whenever one of our bound input properties changes. And with that I mean properties decorated with @input. So whenever these properties receive new values. Now the second hook is ng-on-init. This method gets executed once the component has been initialized. This does not mean that we can see it. It has not been added to the DOM yet, so to say. It has not been displayed yet. But Angular finished the basic initialization. Our properties can now be accessed and initialized, for example. So the object was created, you could say. And if you're interested, ng-on-init will run after the constructor. Then we have ng-do-check. That will also run multiple times. Actually, this method will be executed a lot because this will run whenever change detection runs. Now, change detection simply is the system by which Angular determines whether something changed on the template of a component, or inside of a component, I should say. So whether it needs to change something in the template. So whether some property value changed from 1 to 2, let's say, and that property is output in the template. Well, of course, Angular needs to re-render that part of the template. And ng-do-check is a hook executed on every check Angular makes. Now, important, on every check. So not just if something changed. A lot of times ng-do-check will run because you clicked some button which doesn't change anything, but still it's an event, and on events Angular has to check if something changed, because how else would it know? You don't tell it, right? So it has to check on certain triggering events, like you clicked somewhere, or a timer fired, or an observable was resolved. And on these occasions it will check your code and ng-do-check will be executed. Now, whilst this might sound very inefficient, Angular does this in a very efficient way. So change detection Angular works pretty great and doesn't cost a lot of performance. ng-do-check is a great method to use if you want to do something on every change detection cycle. Like maybe manually inform Angular about some change it would not be able to detect otherwise, though that is a very advanced use case. Well, then we reach after content init. This is called whenever the content which is projected via ng-content has been initialized. So not the view of the component itself, but instead you could say the view of the parent component, especially the part which will get added to our component through ng-content. And ng after content checked is executed whenever change detection checked this content we're projecting into our component. ng after view init is then reached once the view of our own component has been finished initializing. So once our view has been rendered, you could say. And the same after view checked, well, that is called whenever our view has been checked. So once we are sure that, well, either all changes which had to be done were displayed in the view or no changes were detected by Angular. And finally, if you destroy a component, for example, if you placed ng-if on it and this gets then set to false and therefore it removes it from the DOM, ng-on-destroy is called. And here's a great place to do some cleanup work because this is called right before the object itself will be destroyed by Angular. These are the hooks.
Nice to see them in theory. Let's see them in practice in the next lecture. So we learned about all these hooks. Now let's see what they actually do. In the server element component, this is the component I will choose for demo purposes. We already get the constructor and ng on init. So in the constructor, I will simply log constructor called so that we can see when this happens in the console. And I'll do the same for ng on init, but of course here I'll say ng on init called. Of course I will add the other hooks then too, but let's start with these two. And if we reload the application here, we see right at the top constructor called ng on init called. And for every new server we add, we see this again, of course, because a new instance of this component was created, and therefore all these hooks are executed again because it's a brand new instance, doesn't have anything in common besides the class it was created of with the first instance of that component here. So that is constructor and ng on init. Now I told you that ng on changes would run first. So let's implement ng on changes, and this would be enough, though it is a good practice to implement the on changes interface too, and that is true for all hooks. Implementing the method alone will do the trick, but it is a good practice to be very explicit about which interfaces your component uses or which methods your component will have. So therefore implementing these interfaces is a really good practice. It's very clear then which methods may be called in your component and which methods you won't have. Now here we're getting a lot of imports, which is why I will split this up. And as you can already see, you have to import all these interfaces on init and on changes. So ng on changes runs first, as I told you. So let's say ng on changes here. And this hook here actually receives an argument. It's the only hook that does. Here we receive a changes argument, which is of type simple changes, which also needs to be imported from @Angular core. So I will simply log changes here so that we can have a look at it and see what's inside. So let's save this. And here at the top again, we see constructor called ng on changes called, as mentioned before ng on init. And then we see the simple changes. That's an object which has element, which is of type simple change. An element, of course, is our bound property. Here, it's this property name. That's the name we see reflected here. And then Angular simply gives us some information. What's the current value? Well, that's this object with just a test server, and of type server. Is this the first change? Yes, it is. We just initialized it. And what's the previous value? There is no value because we didn't change this before. Now to see that ng on changes actually gets fired more than once, I'll add something to this app just for demo purposes. I'll add a button, change first element, to my app component template above this list of server elements. Give it some bootstrap styling here, but that's not really important. More important, give it a click listener. On change first would be a name you could choose. And then in the app component TypeScript file, I want to change the name of the first element. Now for this, I also need to change the way we pass this element to the server component. Right now, we receive the full element, the full object, and I will leave this here for demo purposes, so that we can reference this code. But now I only expect to get the name, because the name is the only thing I'm outputting here anyways. So I'm duplicating this and I will comment out the old code. And now we only output the name, because all the other element information was projected via ng content into this element anyways, into this component. So we only get the name now. This name will simply be a string. We added input so that it can be bound from outside. And we're outputting name here. So in app component, when we loop through this, I will now actually bind the name to, and I will bind to server element name. And we wouldn't need to bind server element here anymore because that is not used, but I will leave it here for reference. So this is now how we pass the data, how we pass the name. In the app component TypeScript file here in onChangeFirst, I will now access my server elements, the first element, and therefore this will fail if we were to empty this array, and set the name to changed. So again, I did these changes so that we can really see when ng on changes gets fired.
And we couldn't use the element as an object because objects are reference types. So we passed the object via input. Therefore, both properties in the server element component, this one here, and the object in the array of server elements here in the app component, they both point to the same place in memory. And therefore, if we change the name there, it will update in the child component, in the server element component, but it will not trigger ng-on changes because technically the property we're binding to, we use here with add input, that didn't change, the value of that didn't change. It's still the same object in memory. So it's simply this difference between reference and primitive types. And you should look this up if that's all brand new to you. It's a JavaScript concept, has nothing to do with TypeScript or Angular. So that is why now I'm binding to a primitive with name, which is just a string, and therefore ng-on changes should get fired again if I click the change first element button. Let's do that. And indeed, it does. Note that constructor and ng-on init weren't called, but ng-on changes was, and here now we also see the previous value and the new value. And therefore this hook could be interesting to you if you want to react to any changes and then do something with the old value, store it before it gets dumped or something like that. That's ng-on changes. We get a couple of other hooks, so let's move on. Besides ng-on changes and ng-on init, we get doCheck. And as I said, this also needs to be imported from @AngularCore. This will give us a method which is executed on every change detection run. So ng doCheck is the method we need for this. And here we can simply console log ng doCheck called. So let's see when this gets called. If this reloads, you see it gets called right at the beginning, then one more time here, but that is only because we're running in development mode. There, Angular has one extra change detection cycle. But it also gets called if I click this button, as you can see, and if I click this button a couple of times here. So ng doCheck, as I told you, gets called whenever Angular checks for any changes. And there are a couple of triggers which trigger this method. An event was called by clicking, or a promise gave us back some data. So a lot of triggers for ng doCheck. So that is not something where you want to run amazingly powerful code in because that will cost you a lot of performance. But the fact that change detection runs as often as it does on its own is not a problem. And this can be a great hook if you want to check if you do need to change something manually because Angular didn't pick it up or something like that. So the next hook is after content init. This needs to be imported from @AngularCore2, this interface. And with that, we need to implement ng after content init. Now let's call this console log ng after content init called. If we do this here, you will see that here it is, there it is called after doCheck, and it is called only once because it doesn't get initialized again. Remember, content is the thing we projected into this through ng content, so this here will be our content in the end. Let's move on. The next hook then is, and this is getting long here, so I will split this up over multiple lines too. All these interfaces I'm implementing. So the next hook will be after content checked, like this. This also needs to be imported from @AngularCore, and it requires us to implement a method ng after content checked. And well, now I'm just going to copy the code from after content init and replace init with checked. If we save this and have a look at it, you see here it is called, and here it is called again after doCheck, which makes sense because it is called after each change detection cycle. Well, now I'm going to copy these two here, and also I will add two new interfaces. The first one being after view init, and then after view checked. Both need to be imported from @AngularCore2. Now these require me to have ng after view init as a method and ng after view checked.
And I will replace the text here in the console log so that we can see when these get called. So if we log this, you see it happens after the content has been checked. Well, and with that, we're almost at the end. The remaining piece is ng onDestroy, and onDestroy is called, well, right before this gets destroyed. This component gets destroyed. So let's add it here on the implements list, on the interface list, I should say, and make sure to add the import from @AngularCore. And then you need to implement ng onDestroy here, and here I will say ng onDestroy called. Now, to be able to actually see this being destroyed, I will add a new button destroy first component. Give it a class of button and then button danger to make it red. And here I will add a click listener on destroy first. I will copy that, add my method here in, just on destroy first, of course, just the name. Will add it here to my TypeScript code, and there I will simply call server elements the splice method, splicing at the first element and then just one element, therefore removing it. So with this, we should now see all the hooks called, view checked, and so on. And if I destroy the component, you see ng onDestroy was called because we removed it from the array. Therefore, ng4 reran and didn't render this first element because it was removed. Therefore, it was removed from the DOM. Hence, this component hook was called. So these are all the lifecycle hooks in action. You rarely need to use all of them, but some of them can be very helpful for your application to hook into a specific piece, a specific phase, and run your code. Before concluding this module, one more thing related to our hooks here. We learned about add_viewChild, which we can use here in the cockpit to get access to an element from our, well, DOM, from our template. Let's do the same here in the server element component HTML file, where we have all these lifecycle hooks. Let's say I want to get access to this heading, so I'll simply place a local reference named heading on it. Therefore, I'll add a new add_viewChild property. Make sure to import viewChild from AngularCore. And with that added here, I'll store this in a header property, which is of type element ref, as we learned, which also needs to be imported from AngularCore. And I want to select the heading local reference, which I just placed on this div here. So with that, we got access to it. And now we would expect that we can't use this before we reached after view init. So let's try it in ng on init. Let me actually console log this header, and there the native element. And now let's access something which is definitely available on a div, and that is the text content. If we do this and I save this, let's view the console. If I reload the application here, you see this empty line here? This is where I would have expected the text content. Can make this even clearer by outputting text content and then, well, rendering the text content if there were any. There is no text content in here, as you can see, an empty space. If I copy the exact same code and place this in after view init here, so after the view should have initialized, now you will see that here, when it's called the second time after view init, we see test server. So that is the difference between, well, the points of time where these hooks run. After view init gives you access to the template elements. You can then access them and use their values and so on. Before this hook has been reached, you can't do that. You can't check the value of some element in your DOM because it hasn't been rendered yet. In the last lecture, we learned that we have viewChild and how we can access it in our lifecycle hooks. Now there's one other nice little addition. In app component, where we add our content, which we then project into our server element, let's say we also want to place a local reference on this paragraph.
so the content paragraph maybe. But now we want to use that in our server element component, which is where this content will end up in the end. Now in the app component, which is where we currently place this in the template, we could use add_viewChild because it's in the template of the app component, even though it will be kind of passed on to the server element component later. Since we know that it will be there, it would be nice if we could also access it from the server element component, but add_viewChild won't work because it's not part of the view, it's part of the content, which is why we also have separate hooks here, content in it and view in it. The great thing is, we don't only have add_viewChild, we also have add_content_child, which also needs to be imported from @Angular core. This now also allows us to pass a selector, so the reference name, content paragraph would be the selector we chose here in the app component HTML file. And then, just like with add_viewChild, we can store this in some property which will be of type elementRef, like this. And now we can use it, and just like with viewRef, we of course can't access the value or anything before we reached content init. So that is something I just wanted to add content_child to get access to content which is stored in another component but then passed on via ngContent. Now let me log this, and I will log it here in onInit to demonstrate that it is not there. Here I will simply output text content of paragraph, paragraph, and access this paragraph native element text content, and then I will copy this to after content init. Now once I save this and I reload the application, you see that the first time we call it, it's empty here after on init, but thereafter in ng after content init, or after this has been called, once this hook has been called, we see just the test, so now it was initialized. That is the missing piece, understanding how we can get access to elements in our DOM and how we can work with these lifecycle hooks. So throughout this section, you learned a lot about components. We really had a deep dive on them. You learned how to use data binding with custom properties and events, how to pass data around, how to access elements in your DOM, how to use local references, how to really create a dynamic app, and how to use lifecycle hooks to run some code at specific points of time. With that, a lot of core features of Angular have been set now, have been taught. Now it's the time to, of course, practice them in the recipe book in the next module, where we will enhance this with our new knowledge, and of course to play around with that knowledge in your own apps. So let's move on to the recipe book before we then dive deeper into directives. So we learned a lot about components, how to use them, and especially about how to pass data between components in the last lectures. Time to practice this in this assignment. Here are your tasks. I want you to create 3 new components, game control, odd, and even. And the game control component should hold 2 buttons, one to start the game and one to pause it. When starting the game, so when clicking this button, I want you to continuously emit new events. You can use the built-in JavaScript function setInterval. Simply Google for JavaScript setInterval if you quickly want to find out how it works. And you need to store a reference to this timer you created in some property in game control so that you later can cancel it. Important again, an event should get emitted on each tick, and this event should hold an incrementing number, starting at 1 or 0, whatever you like. This event you emit should be listenable from outside. So you should be able to catch the event in your app component, which is where you use the game control component later. Well, and when clicking the stop button, I want you to clear the interval. For that, you can use the clear interval method, but there you will need to pass a reference to the interval. Well, that was the game control. Now the other 2 components, odd and even, I want you to create a new odd component, maybe with ng4, so somehow you manage that through an array, something like that. I want you to add a new odd component whenever, well, an event with an odd number was emitted by the game control component. And the same should of course happen for the even component and even numbers. Simply output odd dash and then the number, or even dash and then the number in these components, maybe wrapped in a paragraph. And this element you wrapped this text in, so maybe that paragraph, should receive a different styling of your choice in both components. So that is your task, only using things you learned thus far. Again, Google setInterval if that is unclear. The starting code is attached to this lecture. Enjoy the assignment. See you in my solution, where I will show you one approach of solving this. So, were you successful? Let's solve it together. Let's start with the first task, creating these components. I'll use the CLI for this. So with ngGC, I'll create my game control component with spec false to not get this testing file. And then I will repeat this for my odd component and then my even component here. So just like that. With that, we should have three new folders here. And now let's start in the game control. I'll keep this relatively simple. Here I will add two buttons where I say start game and also give this some bootstrap classes, button. Let's make it button success to have a green button. And then here I will say pause game on the second button. Maybe let's make this of type button alert to make it a red button. Button danger would be the right class. So with that, we have two buttons in game control. In app component, these were of course added to app module automatically since we used the CLI, these components. So in app component, I can now add them. So I will simply do this here in a new div with the row class here, and then call x as 12 as the width. Here I will add app game control. Let's have a look at our running application. ngServe is already running. That looks all right. That is the behavior I want. I'll open up the console so that we could see any potential errors, but that of course looks all right. Now when starting the game, we should emit an event. So in the game control component, first of all, I need to add a click listener to start game. And I will execute on start game, any method name you like here of course. And I will add it to my component TypeScript code. So here in onStartGame, I now want to set this interval. And I will store it in a property so that I can later access it and clear it. So I'll simply name it interval here. And here in onStartGame, I will set this interval equal to setInterval. As I said, a method supported by native JavaScript. And here I want to emit an event every 1000 milliseconds, which would be 1 second. And then the function here is a ES6 arrow function again. You could use a normal function, but then you would have to bind this to get the correct reference to this. So here I will use a ES6 arrow function. This is the function which gets executed on each tick. The function doesn't have any arguments, but here I want to emit an event. Now this event needs to be created. So at the top of this file, I'll add another property, and this I'll simply name interval fired. Any name you like. This will be a new event emitter, and keep in mind event emitter needs to be imported from @AngularCore like that. Now this event emitter will in the end only hold a number as a value, so that is why I'll set the generic type here, or this value of this generic type, to number. Don't forget the parentheses to instantiate this event emitter so that you really get an instance of this object. And with that I can now call this interval fired and here emit, and I want to emit a incrementing number. So maybe there are a couple of ways of implementing this. I will simply store last number here and set this to 0 initially, and then I want to emit last number, this last number plus 1. Therefore the first emitted number will be 1, and thereafter I will increment last number so that I simply keep track of what my last emitted number was. So with that we should emit incrementing numbers. The next task is of course to make this listenable from outside. I can do this by adding @output in front of it. with parentheses, and output needs to be imported from @Angular core. Now this event can be caught from outside this component here. So that is my own event now firing, and I should be able to listen to it. Interval fired will be the event name since I didn't assign an alias here. So in the app component here on app game control, we can listen to this interval fired event and maybe execute on interval fired here. Of course, you can choose a different name. Now here in on interval fired, I will implement this method in app component. For now, I simply want to log the last number. So I will pass it on with $event. Remember, $event gives us access to the event data, which is the number in this case. So in app component, I know that I will receive my fired number or something like that, which is of type number. So I can simply output this here. So with that, if I save this, we should have a working application. We should be able to click this button, and then on the right in the console, we should see incrementing numbers every second. And that looks pretty good to me. Pause game, of course, won't work for now. So let's make it work by, well, implementing this pause game button. So here I'll add a click listener to the pause game button. And I want to call on pause game here, of course. So let's implement this method in the game control component too. And here I can simply call clear interval. And now I need to pass this interval, which was the reference of my interval I want to clear. So if we do this and reload the application, let's start the new timer. And if I click pause, we don't see any other values because interval is not firing anymore. No new events are emitted. Of course, if we restart, we continue at 3 because our last number wasn't overwritten. You could do this, but I don't want to do that. I don't want to reset the game state. I simply want to pause and resume here. So this is working. Now we need to implement the other components, odd and even. We already got them here, odd and even. And in there, in odd here, I want to output a paragraph, let's say, where I say odd dash and then the number, which I output via string interpolation. Now, of course, number is a property which doesn't exist right now. So I'll add a property, number, which will be of type number, but it's not initialized. Now, again, this should be passed from outside. So, as you learned it, we have to add input here with parentheses and importing this from @Angular core. With that, we're now able to pass the data from outside into this component. So with that, number can be set from outside. So in the app component HTML file, we probably want to add something below our game control here, maybe a new row, but without the app game control component, instead with the app odd component here. And we will use ng4 to replicate this, though we don't have an array right now. We have to create this array. In the app component TypeScript file, right now we're logging any fired number. Well, we should do something else. We should have an array, odd numbers would be a fitting name. And odd numbers is simply an empty array at the beginning. We can even be clear about which type it will hold. The type will simply be an array of numbers. That would be the type definition. Now I'm going to duplicate this because we're also going to have even numbers. Now in onInterval fired, I want to check if the fired number, if it is odd or even. Now we can check this with the modulus operator. If fired number, and the percentage sign is the modulus operator, divided by 2. If what remains here, equals 0, well then we know it's even. So then we should use our even numbers and push the new fired number on it. Otherwise, we know there is something left over from this division, so it is an odd number, so we should push it to odd numbers. So now we're managing these arrays, and with odd numbers getting items which are odd, numbers which are odd. In the app component, here in ng4, I can now loop through them, so odd number of odd numbers, so looping through this array.
I can now pass this to my odd component because remember, there we exposed the number input here. So I can bind to number. You could of course also choose a different name or assign an alias as you learned it. And I want to pass my odd number there. So the number I'm currently at in this iteration. Let's try this. We don't have even numbers yet, but let's see if odd numbers work. If we start the game, we indeed see odd 1, 3, 5, and so on. So this is working. This is working as expected. If we pause, we shouldn't see any other numbers. Now let's do the same for even. So for even, I will basically just copy the template code from the odd component, replace even, odd with even, of course. And well, here in the even component itself in the TypeScript file, I will also receive a number, which will be of type number, and where I have to add input with parentheses to make it bindable from outside. So now just like with on the odd component, I can do the same with the even component and bind number from my parent component, which in this case is the app component HTML file, or the app component in general. So I'm going to duplicate app odd and replace it with app even. Of course, here I want to loop through my even number, so even numbers. So I'll store it in a temporary variable named even number of even numbers. Let's pass the even number here. And with that, we should now log both with odd and even in front of it. Let's see this if it reloads and I click start game, odd, even, and even. And the behavior you see here, that this kind of is below each other. Well, that simply happens because that is how we placed odd and even. Odd numbers will always be sorted to the top here. You would have to manage all in one component to have them alternate. But that is exactly the behavior I want here in this case. So this structuring where we first have all the odd and then the even numbers. With that, the remaining pieces to change the styling. Now both templates look pretty much the same. We have a paragraph in both of them. So for odd, why don't we style this paragraph to be blue, have a blue color, blue text color. And for even, maybe we could choose green. And since we use style encapsulation here, even though we use the paragraph selector in both cases, each component will only receive the style set up in the respective style sheet. So if we do this and start the game one more time, we see odd is blue and even is green. So style encapsulation is also working fine here, and you really see the difference. So that was our assignment. I hope you enjoyed it. And with that, let's move on and dive deeper into components. So, were you successful? Let's solve it together. Let's start with the first task, creating these components. I'll use the CLI for this. So with ngGC, I'll create my game control component with spec false to not get this testing file. And then I will repeat this for my odd component and then my even component here. So just like that. With that, we should have three new folders here. And now let's start in the game control. I'll keep this relatively simple. Here I will add two buttons where I say start game and also give this some bootstrap classes, button. Let's make it button success to have a green button. And then here I will say pause game on the second button. Maybe let's make this of type button alert to make it a red button. Button danger would be the right class. So with that, we have two buttons in game control. In app component, these were of course added to app module automatically since we used the CLI, these components. So in app component, I can now add them. So I will simply do this here in a new div with the row class here, and then call x as 12 as the width. Here I will add app game control. Let's have a look at our running application. ngServe is already running. That looks all right. That is the behavior I want. I'll open up the console so that we could see any potential errors, but that of course looks all right. Now when starting the game, we should emit an event. So in the game control component, first of all, I need to add a click listener to start game, and I will execute
onStartGame, any method name you like here, of course, and I will add it to my component TypeScript code. So here in onStartGame, I now want to set this interval. And I will store it in a property so that I can later access it and clear it. So I'll simply name it interval here. And here in onStartGame, I will set this interval equal to setInterval. As I said, a method supported by native JavaScript. And here I want to emit an event every 1000 milliseconds, which would be 1 second. And then the function here is a ES6 arrow function again. You could use a normal function, but then you would have to bind this to get the correct reference to this. So here I will use a ES6 arrow function. This is the function which gets executed on each tick. The function doesn't have any arguments, but here I want to emit an event. Now this event needs to be created, so at the top of this file I'll add another property, and this I'll simply name interval fired. Any name you like. This will be a new event emitter, and keep in mind event emitter needs to be imported from @AngularCore like that. Now this event emitter will in the end only hold a number as a value, so that is why I'll set the generic type here, or this value of this generic type, to number. Don't forget the parentheses to instantiate this event emitter so that you really get an instance of this object. And with that I can now call this interval fired and here emit, and I want to emit a, incrementing number, so maybe there are a couple of ways of implementing this. I will simply store last number here and set this to 0 initially, and then I want to emit last number, this last number plus 1, therefore the first emitted number will be 1, and thereafter I will increment last number so that I, simply keep track of what my last emitted number was. So with that we should emit incrementing numbers. The next task is of course to make this listenable from outside. I can do this by adding @output in front of it with parentheses, and output needs to be imported from @AngularCore. Now this event can be caught from outside this component here. So that is my own event now firing, and I should be able to listen to it. Interval fired will be the event name since I didn't assign an alias here. So in the app component here on app game control, we can listen to this interval fired event and maybe execute on interval fired here. Of course, you can choose a different name. Now here in on interval fired, I will implement this method in app component. For now, I simply want to log the last number, so I will pass it on with $event. Remember, $event gives us access to the event data, which is the number in this case. So in app component, I know that I will receive my fired number or something like that, which is of type number, so I can simply output this here. So with that, if I save this, we should have a working application. We should be able to click this button, and then on the right in the console, we should see incrementing numbers every second. And that looks pretty good to me. Pause game, of course, won't work for now. So let's make it work by, implementing this pause game button. So here I'll add a click listener to the pause game button. And I want to call on pause game here, of course. So let's implement this method in the game control component too. And here I can simply call clear interval. And now I need to pass this interval, which was the reference of my interval I want to clear. So if we do this and reload the application, let's start the new timer. And if I click pause, we don't see any other values because interval is not firing anymore. No new events are emitted. Of course, if we restart, we continue at 3 because our last number wasn't overwritten. You could do this, but I don't want to do that. I don't want to reset the game state. I simply want to pause and resume here. So this is working. Now we need to implement the other components, odd and even. We already got them here, odd and even. And in there, in odd here, I want to output a paragraph, let's say, where I say odd dash and then the number, which I output via string interpolation. Now, of course, number is a property which doesn't exist right now. So I'll add a property, number, which will be of type number, but it's not initialized. Now, again, this should be passed from outside. So, as you learned it, we have to add input here with parentheses and importing this from @Angular core. With that, we're now able to pass the data from outside into this component. So with that, number can be set from outside. So in the app component HTML file, we probably want to add something below our game control here, maybe a new row, but without the app game control component, instead with the app odd component here. And we will use ng4 to replicate this, though we don't have an array right now. We have to create this array. In the app component TypeScript file, right now we're logging any fired number. Well, we should do something else. We should have an array, odd numbers would be a fitting name, and odd numbers is simply an empty array at the beginning. We can even be clear about which type it will hold. The type will simply be an array of numbers. That would be the type definition. Now I'm going to duplicate this because we're also going to have even numbers. Now in onInterval fired, I want to check if the fired number, if it is odd or even. Now we can check this with the modulus operator. If fired number, and the percentage sign is the modulus operator, divided by 2. If what remains here, equals 0, well then we know it's even. So then we should use our even numbers and push the new fired number on it. Otherwise, we know there is something left over from this division, so it is an odd number, so we should push it to odd numbers. So now we're managing these arrays, and with odd numbers getting items which are odd, numbers which are odd, in the app component, here in ng4, I can now loop through them, so odd number of odd numbers, so looping through this array. I can now pass this to my odd component, because remember, there we exposed the number input here. So I can bind to number. You could of course also choose a different name or assign an alias as you learned it. And I want to pass my odd number there. So the number I'm currently at in this iteration. Let's try this. We don't have even numbers yet, but let's see if odd numbers work. If we start the game, we indeed see odd 1, 3, 5, and so on. So this is working. This is working as expected. If we pause, we shouldn't see any other numbers. Now let's do the same for even. So for even, I will basically just copy the template code from the odd component, replace even, odd with even, of course. And well, here in the even component itself in the TypeScript file, I will also receive a number, which will be of type number, and where I have to add input with parentheses to make it bindable from outside. So now just like with on the odd component, I can do the same with the even component and bind number from my parent component, which in this case is the app component HTML file, or the app component in general. So I'm going to duplicate app odd and replace it with app even. Of course, here I want to loop through my even number, so even numbers. So I'll store it in a temporary variable named even number of even numbers. Let's pass the even number here. And with that, we should now log both with odd and even in front of it. Let's see this if it reloads and I click start game, odd, even, and even. And the behavior you see here, that this kind of is below each other, well, that simply happens because that is how we placed odd and even. Odd numbers will always be sorted to the top here. You would have to manage all in one component to have them alternate. But that is exactly the behavior I want here in this case. So this structuring where we first have all the odd and then the even numbers. With that, the remaining pieces to change the styling. Now both templates look pretty much the same. We have a paragraph in both of them. So for odd, why don't we style this paragraph to be blue, have a blue color, blue text color, And for even, maybe we could choose green. And since we use style encapsulation here, even though we use the paragraph selector in both cases, each component will only receive the style set up in the respective style sheet. So if we do this and start the game one more time, we see odd is blue and even is green. So style encapsulation is also working fine here, and you really see the difference. So that was our assignment. I hope you enjoyed it. And with that, let's move on and dive deeper into components. So now that you learned more about components and data binding, and especially how you can communicate between your components, and how lifecycle hooks work and so on, you gained a lot of new knowledge, which is super important for most projects you're going to build, including our course project. So in this section, what we're going to do is we're going to fine-tune this. We're going to make sure that we can navigate between recipes and shopping lists, though our solution we'll add right now will not be the final one. We will improve this even more later in the course. And we will make sure that we can select recipes here and load them in the detail section. And generally, that we have a working communication between our components. So let's dive into this. The thing with which I want to start in this course is to hook up navigation to either load recipes or the shopping list. Now, we will later learn a way to do this in the way it is meant to be done, but the solution we will create now also is very creative and not bad. I will use ngIf to only load one of the two sections at a time. So somehow in my app component probably, because that is where I include both, here I will need to manage which one should be displayed, and I should determine which one is displayed in the header component. So I should kind of pass the information which link was clicked there to my app component, so that I can then switch a property there to only display one of these two components. I will admit that this task involves multiple steps. It doesn't cover anything you haven't learned thus far though. So definitely take this as a challenge to implement such a navigation on your own, emitting some event in the header which allows us to determine which component should be displayed here in the app component. Now is your chance to pause the video. We'll do it together thereafter. So were you successful? Here is my solution, how we could get this to work the way we want it to work. I'll start in the header component template. Here we got these two links, and I want to attach some click listeners to these links. Here I will say on select, and I will pass a string here, recipe maybe. We can of course pass our own data to the methods we execute here. And here I will select another one or add another click listener, and I will say on select shopping list. Now you could of course also work with numbers there or fire two totally different methods. So that is my onSelect method. Now in the header component, I of course need to implement onSelect, and we get an argument here. We pass it here, right? We get a string on what to select. So maybe let's name it feature, and that will be a string. So let's assign the type string here by adding a colon and then string thereafter. And now, as I said, I want to emit my own event. Hey, we learned how to do this. First of all, I'll need to add a new property, which I'll name feature selected. You can, of course, choose another name if you want. This should be a new event emitter. And now remember, event emitter is imported from @AngularCore. That's a generic type, and we will pass a string here, the feature which was selected in the end, and we have to add parentheses to instantiate this, so to create an object based on the event emitter class. That is our feature selected event. Now I want to use this property, which now holds this event emitter as a value, to emit an event whenever we click one of the buttons. And I will then emit feature, so this string we receive from these method calls here in our template. Well, with that in place, the missing piece is to enable this event to be listened to from outside of this component. So we have to attach something to this property to make it listenable from the parent component, the app component in this case. That something is the add_output decorator, don't forget the parentheses, which also needs to be imported from @Angular core. add_output enables us to use this event or to listen to it from the parent component. So in the app component, which is the parent component, which adds app header here, I will listen to the feature selected event, and then here I will execute onNavigate, let's say. And of course, I'm interested in the data I'm receiving from feature selected, so I can get access to it with $event, this protected name we could use in the template to get access to any data an event passes to us. Now, just because this might be confusing, if you don't specify $event here, but other data, like we did here, right? We kind of overrode $event. That doesn't actually override it. You simply determine which data you want to pass to your own method. And $event may also be used as a second argument here. $event will always refer to the event data anywhere between these quotation marks here. So no matter which place it has in the method argument list here. So I just wanted to make sure that this doesn't lead to any confusion. So let's turn this back to $event to get access to the data we actually pass in our own event. And now in the app component TypeScript file, I will add onNavigate, and here I will receive the where should we navigate to information. So you may choose any name you want. I'll go with feature again. This is the feature we want to navigate to. And now we should make sure that we actually store this feature. So maybe here we should say loaded feature because, we store which feature should be displayed. And initially, that might be our recipes. And maybe to make sure that we always use the same string, let's check it here. Recipe is the name here, this recipe feature. So let's go with recipe here too. And then in onNavigate, I will set this loaded feature equal to the feature we receive here as an argument. And you could even omit this method and directly set loaded feature equal $event here. But I will go for the longer approach to be very explicit about what's happening here. So with that, we're getting this loaded feature. Now we can use ngIf to determine which of the two components should be displayed. App recipes should be displayed if loaded feature equals recipe, and shopping list should be displayed whenever loaded feature, let's say, does not equal recipe. So that will also catch cases where it somehow is set to something else. So with that, we're using ngIf. Now let's see if that works. We only see the recipe now, and if I click on shopping list, we see the shopping list, and the other way around. So now navigation is kind of working. Again, we will later improve this, but for now, that is a great solution. Now let's move on to making the list items here real list items living in their own component. So we added navigation in the last section. Now I want to work on this list of recipe. Right now, if we have a look at its component here, we see that the code for a single list item is this one here. We do have a separate recipe item component, but right now it doesn't hold any template because we had to outsource this code and put it into this recipe list component temporarily, because otherwise we would not have been able to display our recipe data. Now we know how to pass data to a component though, so we can cut all that code here and put it into the recipe item component template. Now the goal, of course, is to get this ng for loop here and remove it from inside the item and move it back on the item here, and then pass down the individual item, the individual recipe of each iteration to that component
so that we can still output recipe name and so on here. So that is your chance to do this on your own again. Pause the video and try to loop through the component itself. So get ng4 out of this component and then pass down the selected recipe or the recipe of the current loop iteration. In a few seconds, you'll see my solution. So, were you successful? First of all, I'll cut the ng4 loop here, and I'll go back to the recipe list component and add it to the app recipe item selector, so that now the whole component is replicated for each recipe. Now the issue, of course, is that we don't have the recipe, which we access, inside the recipe item component anymore. So we should probably add a recipe here, the recipe of that single recipe item component. It will be of type recipe, of course, so we have to import this from our own recipe model, going up 2 folders, and then it's there, right in the folder we, then moved to. And initially this will not be defined. There won't be a value assigned to it, because I want to get this recipe from outside. So to get a recipe from outside, or any data from outside, we need to add something, a decorator. Add input with parentheses, which needs to be imported from @Angular core. Add input allows us to bind this component property from outside. And of course, I want to bind it from my recipe list component here. So in this list where I replicate the single recipe item a couple of times. Now here, we can now bind to our recipe, referring to the property in the single recipe item, and bind the recipe of the current loop iteration. Now, I'm not happy with the naming here, because that can be very confusing. We're having recipe 3 times here. So to make super clear what each name here refers to, I'll rename the recipe here in our loop to recipe L for element, and that also has to be replaced here then, because we're passing the single recipe element as a value, therefore on the right side of the equal sign, to the bindable recipe property. And keep in mind, the recipe here between the squared brackets simply is the recipe property in the component we're placing this on. So in the recipe item component, this recipe here. That is what that refers to. And actually, to make this super clear, I can split this horizontally to have the receiving component, the recipe item component, and the sending one, here template of the sending one, the recipe list component above each other. So that is what we're binding to here. So let me close this. With this, if we save that, we should see the same as before, which makes sense. It's a good thing that we see this. It means it didn't break. And it makes sense because now we're successfully passing down the data, which, keep in mind, is stored in the recipe list component here in this array. We're successfully passing this down to the recipe item component. Now let's work on the feature that once we click an item here, we actually select it and then we load it in the recipe detail component. So that is what we'll work on next. So with all these features added, let's make sure that we can click on a single item here and load it in the recipe detail section. Again, this is the challenge for you. It only uses tools we learned thus far. You somehow need to emit an event on the single recipe item component that it was clicked, and then get this event somehow to the recipes component, which then also holds the recipe detail, to pass down the event data, which recipe was selected, to that component. Now you're going to have to work with property and event binding for this. Again, only things you learned thus far. And if you're getting stuck or something like this, of course, we will solve it together in a couple of seconds. Here's your chance to pause. So, were you successful? Now, the approach we're going to follow now, is only a temporary approach. We'll later learn how to do this more elegantly and easier. But it's also a great approach because it uses the things we learned thus far and it gives us an impression on when a different approach might be useful. So what's our goal? Here in the single recipe item component, here we got this link. And we want to make sure that whenever this link is clicked, we emit an event informing our parent component that this recipe was selected. So for this to work, I'll add a click listener to this link, and I will say onSelected here. Of course, you can choose any method name you want. I'll implement onSelected here, and there I want to emit my own event. So I will name it recipe selected, and this will use the event emitter as you learned. Again, make sure to import it from @AngularCore. The event emitter here won't pass any information, so I'll set the type to void because it will contain no information. And we have to add @output so that we can listen to this event from outside. @output also needs to be imported from @AngularCore. In onSelected, I then want to trigger recipe selected and call emit. Nope, not error, emit. Again, we don't pass any error because here we specified that we won't. We don't need to pass any. You could argue that you want to pass the recipe on which this was emitted, but you don't need to do this because what is the parent component listening to that? That, of course, is our recipe list component. That is where we use the single recipe item. Now, if we implement our own event here and listen to recipe selected, well, we already got the information which recipe this will be because we have it here from the ng-for loop. Keep in mind, this will replicate this element, so for each element, it's absolutely clear, well, which element it is. In recipe selected, we again need to emit an event though, because we're not there where we want to be. We have to go up one level because we want to reach our recipes component, which is the one implementing the recipe list. This is probably where you see that this is kind of complex to simply inform another component that we clicked something. For now, it's the only method we have, and it's a great practice, but no worries, we will improve this in the future. So in recipe list, we need to emit another event. So here I'll execute on recipe selected, of course, choose any name you want. And that method, of course, has to be implemented here. Now here we need to get some extra information, which recipe was selected. And therefore, I will pass the recipe element here. So that is the recipe which we did select. Now that we have that information, we know here we will get the selected recipe, which will be of type recipe. We're already importing the model, therefore we can easily use the type. And then we, as I mentioned, want to emit another event. So here we need to find a fitting name. Before we used recipe selected, that would be a fitting name here too. But to make it super clear that this is a different event, because custom events don't propagate up, so we can't listen to the event of a child, I want to choose a different name, recipe was selected maybe, which also uses the event emitter, so make sure to import it from @AngularCore. And here I will pass my recipe as a type. Here I will pass the recipe which was selected because that is the information the recipes component will need in the end. Now, as before, we need to add @output here and import this from @AngularCore so that we can listen to this event from outside. And then here in onRecipeSelected, we can use recipe was selected, emitted, and pass the recipe as data. Now with that, we can go to our recipe component, our main component for this feature area. And on the list, we can now listen to recipe was selected, the custom event we created a second ago. And here, I now want to store this selected recipe. So in my TypeScript file, I will create a selected recipe property, which will be of type recipe. Make sure to import recipe from your model file then. And initially, this is undefined because I'm not assigning a value. I will assign a value here once this event here occurs. So then I will set selected recipe equal to $event. And of course, you could also put this into a method, but since this is all I want to do, I can put it into the template here. Generally though, you should try to put as little logic as possible into your template. So here I'm referring to the selected recipe property of my recipes component, and $event, as you learned, refers to the data we passed with an event. Now we can pass this information to the recipe detail component. First of all though, I will add ngIf to this detail component to determine if we want to display it, because I only want to display it if selected recipe is set. So here I will check if selected recipe, and if it is undefined, that will resolve to false. And if it is not set, I want to say a dummy text, so I will use ng template for this to define a paragraph where I say, please select a recipe. And ng template will receive a local reference of info text. And now with that placed on ng template, we can use this ngIf else syntax where I add a semicolon and then else info text, so that else the content of this template should be displayed. If we save this, we see please select a recipe here, so that is working as it should. Now if we select a recipe by clicking here, we see the recipe detail. Now of course we don't see the detailed data because we're right now not passing this recipe down to the component, but at least our if check is working and we're passing the recipe this event successfully. Now as a final step, let's pass the selected recipe to the app recipe detail. For that we have to go to that component and add a property for this. Here I'm going to name this recipe again, which will be of type recipe, so make sure to import this from your recipe model file. It's not set initially, but I will add input so that we may set it from outside. Input, of course, as always, has to be imported from @Angular core. And with that, we can now go back to the recipes component and bind to that recipe. And of course, we want to bind our selected recipe. And keep in mind, this whole component will only be rendered, only be attached to the DOM if this condition is true. So if selected recipe is not undefined. Therefore, once we pass this down to the recipe detail component, we know that we can safely output the recipe name here. So recipe name, keep in mind recipe is the property name in this component, the one to which we're binding to from outside. And this will never fail because recipe will always be set, otherwise this component wouldn't be rendered due to ngIf. Here I also want to use property binding to display my image. So recipe image path then. And here I'll use string interpolation to display the name if we can't load the image for some reason. The buttons are fine, but below in the description, I will set recipe description. Now with this, if we save that and we click on the recipe, we see the recipe here. Now the image is a little bit too big, so maybe on this image, let's simply add some styling to it, an inline style, where we set the maximum height to 300 pixels maybe, like that. Now with that, that looks better. So now we got this working. Looks like nothing changed because we got the same text here. So let's quickly go to our recipe list component and name this another test recipe so that we can actually see if we correctly switch. And we do. So that is working. The missing piece now is the shopping list where I want to make these input fields here work, at least in a basic way. We added a lot of functionality in this course section. Our recipe book is really taking shape. Now, of course, there are also some features we haven't added yet, which we will add later. For now, I want to make this shopping list input fields here working so that we can add new items to our shopping list. We will overwrite this later when we learn about forums, but it's a great exercise to work with local references and add viewchild for now. So what I want to do is I want to
work on this shopping list added component here. Here we got a couple of input fields and we got the add button, which submits our form later, delete and clear. Now I want to allow the user to add new items. So what I'll do is I will restructure both inputs to use multiple lines, simply to make it easy to read and understand. And on the first input for the name, I will add a local reference named name input. On the second one, I'll add one named amount input. Now, with that setup, your challenge would be to get this add button to kind of use these local references, preferably by either passing them as an argument or, more advanced, by selecting them with add view child, so that once you click the button, you use the values of these inputs to create a new ingredient and add it to your array of ingredients. Here's your chance to pause the video and try this on your own, then we'll do this together. So, were you successful? Let's do it together. We already have our local references here, so all I have to do for now is add a click listener, and I'll name it onAddItem. And I could pass the local references, or even already local reference.value here as arguments. I will use the addViewChild approach though. So in the shopping list added component, I'll add the onAddItem method, and then at the top I'll add two properties, the name input reference, and that will be of type elementRef as we learned. Make sure to import this from @AngularCore, and it will get a value by using addViewChild, which also needs to be imported from @AngularCore. And here we pass the name of the local reference. So name input for this first input field. Well, and now I'm going to duplicate this and simply rename this to amount input and amount input ref. That's the local reference we put on the second input here. And with these two inputs added in onAddItem, I now want to emit a new event where I pass this data to the parent component, which is the shopping list component, which manages my array of ingredients. So we learned how to emit our own events, so I'll quickly go through that again. Here, I'll name it ingredient added, which will be a new event emitter. Of course, you could choose another name for your event. I will pass an object here as an argument, which will hold the name, which will be a string, and the amount, which will be a number. And that here, also close the parentheses, that here is simply just a type definition. So the type will be a JavaScript object with two properties, name and amount, where the first property, name, is a string and the second one is a number. So that's not a value, that's just a type definition. Now, of course, for this exact type definition, we got our ingredient model. So we can replace this with just ingredient. Make sure to import ingredient from the shared folder and then the ingredient.model file though. Well, and with this in onAddItem, we can create a new ingredient here with the new keyword and then ingredient. And we simply pass the name input ref native element value here. And that will simply be the value of the input element. And the same for the amount. But since this is really long, I'll create two new temporary constants, so to say, or constants to make this code a bit shorter. So the ingredient name will be retrieved from the name input reference, from the native element, which is the input element, and then from the value field. And the same for the ingredient amount. Here, I will simply get this from the amount input ref. And with these two constants here, I will simply pass ing name and ing amount here. So I will create my new ingredient with that data. Important, the constants here are used, or I use constant instead of let, because we're not going to change these variables, but they won't be variables anymore then, as well we only assign these values one time. And you should declare something as a constant if you don't plan on changing it. So with this, I can now emit my own event here and pass the new ingredient as data. Well, and with this, all we have to do is we have to add add output in front of our own event here so that we can listen to it from outside. Make sure to import output from Angular core. And now in our shopping list component, which implements the shopping added component, we can listen to our ingredient added event here. And there I want to execute on ingredient added. And we will get some data, which is always stored in $event, which I want to pass to my on ingredient added method. Let's implement this method here. So on ingredient added, I know I will receive an ingredient here of type ingredient. That is what our event emits, the data we set up there. And now we can reach out to our ingredients array and push a new ingredient, the one we got here as data, on it. And with that, we should be able to indeed add some, add some bread to it. One click add, and you see it on the list. So we got a halfway working shopping list. Of course, delete and clear is not working. We also can't select items here. That is something I'll work on later once we learned more about forms, which give us some nice tools to manage them. But we greatly enhanced our app in this section. We added some kind of working navigation. We are able to select a recipe here, and we are able to add new items to the shopping list already. Even though some of these behaviors will get overwritten later in the course, it still is a great start. Now let's move on and learn more about directives so that next time we come back to this project, we can make our drop-down buttons here work. See you there. Time to take another look at directives and not only repeat quickly what we learned thus far, but also learn how to build our own directives and really dive into the difference between attribute and structural directives and what this star means on the structural directives. Well, I already said it, right? We got attribute and structural directives. Attribute directives are called like this because they sit on elements just like attributes, and structural directives basically do the same, but they also change the structure of the DOM around this element. If you have ngIf on a paragraph, if that condition is false, this paragraph is removed from the DOM, so the overall view container is affected. Whereas on the attribute directive, you never destroy an element from the DOM. You only change properties of that element, for example, the background color. So that is why we have attribute directives only affecting the element they sit on, and structural directives, which also affect the whole DOM or the view container, the area around the element which they were placed on. That is the difference. Now with that, let's briefly have a look at the directives we already know and how to use them, before we then dive into building our own ones and learn more about structural directives. I prepared a little project, which you as always can find attached to this lecture here. And it's a super simple project. We got a button where we can toggle to only see odd numbers, but right now we don't see any numbers because whilst I do have an array of numbers here in my app component TypeScript file, I'm not outputting it here. However, I did set up a list. So with this, why don't we go ahead and simply add ng4 with a star, since it is a structural directive, to this list item. And then we could simply say let number of numbers. We already learned this syntax. And we could also extract the index if we wanted, but we don't need that here. So that is our single number. And that of course allows it to now output it here. We can output it anywhere inside this element we placed ng4 on. So on any nested elements too. With that, we're outputting the number, and now we see 1, 2, 3, 4, 5. The button still doesn't do anything though. The reason for this is that, well, right now we do something upon clicking. We set only odd, which is this property, to what it currently is not. So if it was false, we set it to true and the other way around. But we're not using this information. Let's use it. Now we could try placing ngIf on the same element we already have ng4 on and check if number modulus, so the percentage sign 2, if that is equal to 0, which would mean now we only display even elements, right? If we do this, we get an error because we can't have more than one structural directive on the same element. It just doesn't work. But we don't need that. We can change it differently. We can simply make a tiny change to our main app here and implement odd numbers, which is 1, 3, and 5. And then, of course, even numbers. And that is just a demo app for directives, right? So that might not be the best solution for your app where you really need this behavior. Later in the pipes section, you will learn how to dynamically filter an array, for example. So here, even would be 2 and 4. With that, I'm going to comment out the first numbers array. And instead here, I'll loop through all my odd numbers and output odd here. And of course, we can do the same for the even numbers now. So even of even numbers. And now to display only one of the two, we can simply wrap them in, let's say, a div. So let's put the list item inside of the div. And on the div, we could place ngIf. And now the first one should only be displayed if only odd is true. And let's do the same for the second one here. Let's place them in here, and we place ngIf on that too, where we check if not only odd. And maybe also replace even here. We now see we can toggle between the two lists, so this is now working with ngFor and ngIf. Nothing new, something we already learned. So these are the two structural directives we learned about, and how we may use them, and that you can't combine them on the same element. Before we dive deeper into this, let's also have a look at the two attribute directives we learned thus far, two of the most prominent ones. There are, of course, many attribute directives, and throughout this course we will see different ones. Two we already learned about are ngClass and ngStyle. Now, just to quickly refresh how they work, let's add a class to our CSS file here. Let's maybe name it odd. And here I simply want to set the color to red. Now in my template, I want to assign this class if it is odd. So here, of course, I could always assign the class, since we already make sure that this list item list is only displayed if only odd is checked. Still, we could also use ngClass here, like this, and make sure that we assign the odd CSS class, therefore we define it here as a property name, only if the number we currently look at divided by 2 with the modulus sign equals something else than 0, so not equal to 0. That means we have a remainder for this division, which means it's odd. Now we can copy this to the even list, and again I know that this will never be odd here because we already make sure that this is only rendered if we are not displaying odd items. We don't have any odd items in the even numbers array. So just to show how this works, of course we have to check even here. Now you see even numbers are black, odd numbers are red. Again, not super surprising, but just a brief refresher on how ngClass worked. And important, I mentioned it before, the squared brackets here indicate that we are binding to some property on our ngClass directive. Now ngStyle was the other famous directive we had a look at thus far. ngStyle allows us to also pass an object to some property, which is also named ngStyle on the same directive. And here we could simply set the background color, and we could set it to red like this. Now it would always be red, but of course we can also set a dynamic value here. So we could simply repeat our check from up here if it's an odd number, in which case I want to give this, let's say, background color of yellow, otherwise it's transparent. Now I'll quickly copy this over to our other list. Here, of course, I check if even is basically even, and guess what? I think it will be. And now the even numbers, still no styling at all, and the odd numbers are really ugly now, to be honest. But that means our directives here are working. Now let's build our own ones, because that is something we can do too. Let's start with our own attribute directive. So we already use attribute directives like ngClass and ngStyle. it's even easier to understand what they do once we've built our own one. So I want to build a directive which simply highlights an element I hover over, let's say. Of course, I could achieve the same with normal CSS styles, but this is just a good demo. So I will create a new folder and I will name it basic highlight, like this, because in there I create a new file, basic highlight, and now directive.ts. So before we always had component files, now this is a new element. It's not a component, it will be a directive, hence the file name. Now in this file, I'll export a class, which I'll name basic highlight directive, again to be descriptive about what this class is. And to make it a directive, just like with a component where we added add component, here we have to add directive. And directive needs to be imported from @Angular core, so make sure to add this import. And we need to pass an object to this decorator to configure this directive. Now, how do we configure a directive? The one thing our directive absolutely needs is a selector, because remember, we do place directives in our template to attach them to elements. So we need to have some way to give Angular that instruction, and that is the selector. Here, that should also be a unique selector. So typically, here you use a camel case notation to give it app highlight as a selector, or here maybe app basic highlight, like this. Now that would select it by element. Now I want to have this attribute style, so I'm going to wrap this in squared brackets, which means this will now be recognized whenever I add app basic highlight without squared brackets to an element. Now to show this, we need to do something which gives us some visual clue that this is working. So the basic thing is, the most basic use case is we change, let's say, the background color of the element where we attach this directive. For this, we need to get access to the element the directive sits on, and the cool thing is Angular gives us this access. We can inject the element the directive sits on into this directive. And injection is something we'll take a closer look at in the next course module, in the big next course module, which is about services. I can say that much. It basically is an easy way to get access to some other classes without having them to instantiate on our own. We do inject by adding the constructor, which every TypeScript class has. We don't need to write anything in the constructor body for now, but here on the list of arguments, we list a couple of arguments you want to get whenever an instance of this class here is created. And of course, Angular is responsible for creating these instances. So therefore, if we tell it to please give us a specific type of argument, this is what injection is. Angular will try to create this thing we need and give it to us. Well, this thing we need, in this case, simply is a reference to the element the directive was placed on. So an element ref, and this name is totally up to you, but the type is important. The type has to be element ref. You might recognize this from @viewchild. There, it also was a reference to some element. Here it is too. Now, to be able to use this data in our class here, everywhere in the class, we can use a TypeScript shortcut of adding private in front of it, which will make this both a property of this class, so property element ref, and automatically assign this value, so this instance we're getting, to this property. Now with that, we got access to the element. Now we can use it here in our constructor, for example, access the native element, and then do something with it. Though a better place than the constructor is on init. And just like the component, the directive also has the ng on init lifecycle hook. So here I can therefore add ng on init, and in there we could access element ref, that's the shortcut which automatically gave me this property, access the native element, and there access the style and maybe the background color, and set this equal to green so that we can see something changed. So what we're doing here is we're getting access to the element the directive was placed on, getting access to that exact element, and then we're overwriting the style of this element. Now let's use this directive. To use it, we have to do two things. First of all, like for a component, we have to inform Angular that we have a new directive. Just like with components, it doesn't scan all our files, so it doesn't know. So we have to go to app module, and here in declarations, we have to add our basic highlight directive and also add the import pointing to the basic highlight folder and there to the basic highlight directive file. Now with this, we can use the directive in our app since we informed Angular. Now let's use it in our app component HTML file. And here below all our lists, I will simply add a new paragraph, style me with basic directive, something like that. And now to this paragraph, I can add app basic highlight, my own selector. We don't need to set any value, and importantly, we don't use square brackets, because as I already emphasized, the directive name is just a selector we set up here. And these squared brackets here are not part of that name, it's part of this selector style, telling Angular, please select it as an attribute on an element. And that's just how we add it here, like an attribute of the paragraph. Now with that, if we save this, we indeed see a green paragraph below our list because our directive is doing its job here, it's styling it. So that's our first basic attribute directive. We can enhance this though. In the last lecture, we created our first basic directive, and it's doing its job. We learned how to create a selector, how to use that selector, like an attribute in this case, since we set up an attribute selector, and how to register it in app module. We also learned how to get access to the element the directive sits on. This, however, is not the best way of changing that style, because as you might recall from some earlier lecture in this course, accessing elements directly like this is not a good practice. You should use a different tool, which I'll show you in a second, because Angular actually is also able to render your templates without a DOM. And then these properties might not be available. It could do this when using service workers, so basically some advanced use cases, but nonetheless, it's not a good practice to directly access your elements. How should you access them then? Well, there is some other helper you can inject. It's the renderer. So let's do this, but actually let's not do it in our basic highlight directive. Let's create a new one, and for this I will create a new one with the generate command, or just G as you learned with the CLI, and then directive, or just D, and then any name of your choice, and I'll name this better highlight. So this will give us a new file or two new files. I can delete the testing file. And we can also put this into its own folder, of course. It's not the default, but let's do it here. Better, highlight. You could also create a central shared or directives folder where you store all your directives. For now, just for demo purposes and to have a clear separation and make this easy to see, I'll put them into individual folders. So better highlight directive here. In the app module, I will need to adjust my path since I just moved it to the better highlight folder, so make sure to point to the right path in the right file then. In there we got a selector, app better highlight. Now let's inject this better tool I was referring to. It's the renderer, which is of type renderer2. And this needs to be imported from @angular/core. Now with this injected we can use it, and I will use ng on init again to still stick to this best practice of doing initialization work there. Make sure to import ng on init, or just on init here, from @angular_core, and now let's implement ng on init here. And there I can now use the renderer. I do this by calling the property which I created here, the private renderer, and there we get a couple of helper methods you can use to work with the DOM basically. Now, one important method I'm interested in here is the setStyle method. This method allows us to, guess what, set the style of some element. Now, the problem here is, for that, we need to have the element for which we want to set the style. And of course, in Angular, there are different ways of getting such an element. Here in the directive, it's exceptionally simple. We already saw how to get one in the basic directive, the basic highlight directive. We can simply inject the element reference. So I'll add another private property here, or argument, which will automatically be bound to a private property, I should say, which I'll name lref. And this will be of type element ref, which we then also, as before, need to import here, element ref from @AngularCore. Now with this import added here, now I can use this element ref here by calling this lref. And here I then want to access the native element. And that's important. We can't pass the reference itself. We need to get access to the underlying element and pass this as a first argument here to setStyle. Now setStyle takes a couple of other arguments. We defined which element we want to style. Now we have to define which style we want to set. And that would be the background color in our case. With the style property defined, the third argument we pass to the setStyle method is the value we want to assign for this property. Now we could set the background color here to blue. The fourth and final argument is a flags object. Here we can set a couple of flags for this style. And this is optional. I will leave it out here. What you could set here are things like if you want to add an important tag, so this exclamation mark important annotation for a style to override other styles or something like that. Now this however does it for my cases here. And now if we save this with our better highlight directive already added to app module, we can go to the app component and add it here too. I will simply duplicate this paragraph here and use app better highlight here, our new directive, again, which is available through the selector since we also added it to the app module. And then here I want to style this with a better directive. Now if we save this and let it recompile and reload the browser, we already see the blue background here behind this paragraph. So our new directive here, the better directive, is working, and now we're using the renderer, which is a better approach of accessing the DOM. Now why is it a better approach? Angular is not limited to running in the browser here. It, for example, also works with service workers. And these are environments where you might not have access to the DOM. So if you try to change the DOM as you did here in basic highlight, by directly accessing the native element and the style of this element, you might get an error in some circumstances. Now, to be honest, in most circumstances you probably don't, and you probably also know if your app is going to run in the browser or not. Still, it is a better practice to use the renderer for DOM access and to use the methods the renderer provides to access the DOM. You can learn more about the renderer in an article after this lecture here if you're interested. Just another note, I had to re-record this part here because the renderer type here changed from renderer v2 to just renderer 2, as did some arguments you could pass to setStyle. Therefore, in the other videos in this section, you will see that this code looks slightly different, not by much though. Don't get confused by this. The code you see here is the code you should use and the code which will work. All the other code shown in the section, of course, is not changed, is still the same. It's only this renderer setStyle method and the renderer type, which is now renderer 2 and not renderer v2, as you will see in the other videos. With that, let's move on. So we saw two examples for directives now, and the better approach definitely is a good approach, but it's not very interactive, right? It always gives us a blue background, and I want to change this. I only want to style this blue or give this a blue background if I hover over it. And if I move my mouse away, it should go back to transparent. So let's improve the better highlight here a bit. We need to react to some events occurring on the element the directive sits on. And a quick and easy way to do this inside of this directive is to simply add a new decorator, and this is the host listener decorator, which needs to be imported from @AngularCore, and add it to some method we want to execute. So the method here could be mouse over. Now I will move this from the top of the file below ng on init here. So now this can be triggered whenever some event occurs, and that event is specified here as an argument as a string. Host listener here takes the argument name as an input, and that would be mouse enter, let's say. That is one of the events supported by the DOM element this directive sits on. So you have basically all events available you could also use with event binding before. So that's my host listener targeting this event. And we could also receive the event data here. So event data of type event would be passed to us here. So that works. You can also listen to custom events here and retrieve that data. So this is just like the method you execute when you add a click listener or whatever your event is, and then pass the method between the quotation marks. So that's happening here. Host listener is just a convenient way of listening to events on that element. So with that, we listen to the mouse enter event. We get the event data, which I don't need here. But what I want to do in this case is I want to change the background color of the element. So what I can do is I can copy this code from ng on init and comment it out. And now set the style here on mouse enter. And now I can quickly copy this and add another method, which I'll name mouse leave maybe, where I will listen to the mouse leave event, another official event I can listen to. And then I want to set the background color to transparent maybe. Now with this in place, we should have a reactive directive. So now, no background color, and if I hover over it, it gets blue. So that is working as intended, now with host listener reacting to user event or to any events. So we learned about host listener, and this setup here is absolutely fine for what we're doing. But we got another decorator we can use, which then allows us to not use the renderer. There is nothing wrong with using the renderer, but we got an even easier way of simply changing the background color if that is all we want to do in the directive. Again, using the renderer is not wrong though. The decorator I'm referring to is called @HostBinding, which also needs to be imported from @AngularCore. And since we got a lot of imports, I'll quickly restructure this to cover multiple lines. So host binding, that's the new decorator. And I will come back to what we pass here in a second. First of all, we need to bind this to some property which value will become important. So that could be a background color property, a new property I create here, which is of type string. Now in host binding, we can pass a string defining to which property of the hosting element we want to bind. Now, properties of the hosting element, that is simply what we also access here in the basic highlight directive. Style would be such a property, and there then the background color property to be precise. Therefore, we can simply say style dot and now camel case background color, and that's all. Camel case is important here because we're accessing the DOM property, which doesn't know dashes. So with this, what we're telling Angular is, on the element this directive sits, please access the style property, which pretty much any input has. On other directives, which access something like the value, you of course have to make sure that they are only added to inputs which have this property. But here again, the style property should be available on any element. So here we access the style property, and then there a sub property, the background color, and we set this equal to whatever background color is set to here. Well, and we can simply change background color here when we mouse over it. We can set background color to blue in this case, and set it to transparent in this case here, transparent. And I will comment out the renderer code here. Again, not wrong to use it, but no longer needed in this example. Of course, we also have to set some initial color so that we don't get an error before we mouse over it the first time. So here I will set this to transparent initially, give this initial value. With this, it's transparent, no error, looks good. And if we hover over it, it works the same way as before, but now solely driven through host listener and host binding, a great way for working with the element inside of a directive. And of course here on host binding, you can bind to any property of the element you're sitting on. Our directive is looking really great. We're almost there, but there's one other thing I want to add, one functionality I want to add. Right now it's dynamic in a way that we can mouse over and then move the mouse away, but we can't decide which colors get used. Now if that were a directive we want to ship with, like say a third-party package we're offering, the user, the developer using this directive should be able to dynamically set the value. Maybe we even want to do this in our own app because the color we want to set changes depending on some other parameters in our app. Right now, the color is hard-coded in there, transparent by default and blue if we mouse over it. So that is something we can improve, and we can improve it with a tool we already learned, custom property binding. As a side note, custom event binding also works in directives, but you probably won't use that often. So how can we use custom property binding then? Let's add two properties to which we bind. I'll add it with input here, and I'll name the first one default color and set it equal to a string and even assign a default color which is transparent. Now add input of course needs to be imported from add Angular core. I'll duplicate this and I'll set this to highlight color. That will be blue by default. So we do have some default values to use, but they can be overwritten from outside. So now by default here, I will assign my highlight color for initially setting this. And in my host listeners here, if I mouse over it, I will assign my highlight color, here it should be my default color at the top, of course. So default color when we initialize this, and then highlight color once we mouse over this, and then default color again once we move the mouse away. So here, default color. So with this, it should still work just the way as it did before, but now we can actually bind this from outside. So in our app component where we use the better highlight directive, we can now bind to default color and maybe set this to yellow, should be a string though, yellow. And we can bind to highlight color and pass a string which could be red. And now if we save this, notice that app better highlight, the directives itself, the name, is not enclosed in squared brackets. Now you see it's red and yellow here. Though we also detect a bug, initially before we mouse over, it's a white. The reason for this is when we assign default color here, it's just not set here. So to prevent this from happening, what we can simply do is we initialize it here in ng on init instead. That's also before anything has been rendered, but after our values here are available. So here we can set this background color to this default color, and now it should work fine. Now we have yellow by default. So this now works, and now we are able to override this. There are a couple of interesting things we can observe regarding the way we pass down these values though. The first interesting thing is that we have two extra directive-like looking things on the paragraph. And this is just property binding. Now how does Angular know if we want to bind to a property of paragraph, which of course doesn't have a default color, or to a property of our directive? The answer is it just figures that out. It simply checks our own directives and so on first before it reaches the custom, the native properties of elements. That's another important takeaway. We can bind to properties of our own directives by simply placing them on the same element. These properties, I mean, enclosed in square brackets, of course. Now, for ng class, you see that somehow the directive itself is enclosed in squared brackets. And that's a typical use case, especially if you only have one property to bind, or at least one main property. Then you can provide an alias, and we can do this here for, let's say, the highlight color, and set this equal to your directive selector. So app better highlight in this case. If I set this as an alias for the highlight color, Now this assignment here won't work anymore, so I will remove it. Instead, now I can enclose my main directive into squared brackets and set this equal to red. So now we should still see yellow and red, but now we're having the same style of enclosing the directive itself. And it's important to understand that this is only an option. You can set such an alias, but that's not something you have to do. And by default, as you saw before, the directive name is not enclosed in squared brackets. That really only happens if you want to bind to a property which has the same name or alias like your directive selector. One other thing about how we pass down data, one other thing which is true about property binding in general. If you pass down a string, like now we use squared brackets and then single quotation marks, well, you can take a shortcut. You can remove the squared brackets and remove the single quotation marks, and that is a special case. If you're passing down a string, you can add property binding without squared brackets if you then also omit the single quotation marks between the double quotation marks. And that should work as it did before, no error. You can use this, you will see me use this later in the course with official Angular directive. Be careful that if you use it, it's really clear that this is property binding, that no one thinks that this could be a real attribute existing for the element you placed it on. Then this is absolutely fine to be used. And this is our directive finished with some extra features like host listener, host binding, and dynamically setting values from outside. So now that we had a closer look at attribute directives and created our own one, before creating our own structural directive, let me explain why this star is actually required. This star indicates to Angular that this is a structural directive. The question is, why does it need to know? Because structural directives with that star actually are just a nicer way for us to use them, basically. Behind the scenes, Angular will transform them into something else. Because there is no star in Angular syntax when using, well, directives or when using property binding or anything like that. There is only property binding, event binding, two-way binding, and string interpolation. And there is no star operator or something like that. So behind the scenes, Angular needs to transform this ngIf usage into something where we end up with these tools, property binding and so on. And it does. I can write the same list here differently. So if I try to write this only odd block differently, I would end up with the following. I would have a ng template element that is provided by Angular as the ng indicates. And inside this element, we have the content we conditionally want to render. So in this case here, we would have a div inside of this, and in this div, our list item. Now, you probably see that it's basically the same, but that it's wrapped in ng template. The reason for this is that ng template is an element which itself is not rendered, but which allows us to define a template in the end for Angular to use once it determines that this template, some element, needs to be rendered because this condition is true in this case. So on the ng template, we place ngIf, and now not with the star, because this is the form to which it will get transformed due to the star, but instead with the tool we already know, with property binding. And here we simply bind, well, not only odd. So the condition. So now we're back to the tools we know without the star, and that's why we have the star, because obviously that's the more intuitive syntax to use, directly placing it on the element we want to conditionally render. But that would be the real content behind the scenes to which it gets transformed. Now you don't need to use that, but I find it super important to be aware of this. Now therefore, if we save this, we see the list twice, and we see it disappear and appear twice, because it works exactly the same. It is exactly the same code behind the scenes. This is what the star transforms it to. Now that we understood what the role of the star is, we can write our own structural directive. So let's create a new directive, and I will use the CLI for this. I will name it unless. So I will basically create the opposite of the ngIf directive. This directive here will attach something only if the condition is false. ngIf does it if the condition is true. So here I'll again delete the spec file here. And in the unless directive I get my selector, which is fine. Now here I need to get the condition as an input. So I'll add input. And remember, in the end we will use property binding with the squared brackets because Angular transforms it for us. We need to, of course, import input from @AngularCore. And then here I want to bind to a property named unless, which kind of simply is the condition we get. But whenever this condition changes, so whenever some input parameter here changes, I want to execute a method. And therefore I can implement a setter with the set keyword. This now turns this into a method, though technically, and that's important to understand, this still is a property. It's just a setter of the property, which is a method which gets executed whenever the property changes. And it of course changes whenever it changes outside of this directive. So whenever the condition we pass changes or some parameter of this condition. Unless therefore needs to receive the value the property would normally get as an input. And we know that this will be a Boolean because it will be our condition in the end. So we could also name this condition. Then we can check if the condition is not true, which is the case in which I want to display something, because unless is the opposite of ngIf. And if the condition is true, well then I want to display nothing. So that is how we get the condition, how we use it, how do we display something. Keep in mind that our unless directive here in the end will sit on such a ng template component, because that is what it gets transformed to by Angular if we use the star. So we can get access to this template, and we also need to get access to the place in the document where we want to render it. Both can be injected. The template can be injected by adding template ref, any name you like, but the type is of type template ref. So just like element ref gave us access to the element the directive was on, template ref does the same for a template. And this is a generic type. You can simply pass any here. And we need to import template ref from @AngularCore. The second information piece we need is the view container. So where should we render it? The template is the what. Now the question is where. So I'll name it vcref for view container reference. And the type is view container reference or view container ref, which is also imported from @AngularCore. That marks the place where we placed this directive in the document. Angular marks this place, and you can see this if you inspect it in the developer tools actually. So with these two tools available, we can use the vcref whenever the condition changes to call the create embedded view method, which does just what the name implies. It creates a view in this view container. And the view simply is our template ref. So this template we created there is exactly this reference to the template there is exactly what we need. Well, and if the condition is true in this case, so if it's not what we are looking for, then we will simply call the clear method to remove everything from this place in the DOM. With that, our own directive is set up. Of course, we need to make sure that it is added here. The CLI did this for us. And now in the app component, we can use our own directive, maybe, to replace ngIf here. So I'll comment out all this stuff here and only copy the original div down there. Comment this in, of course. So here, instead of using ngIf, I'll use app unless. And the star is important because it still is a structural directive. Otherwise, we would have to manually write it with this ng template syntax you learned before. So here, of course, we don't want to check if only odd is false, because keep in mind the unless directive will check for the opposite already. So here we have to pass just only odd. And with this in place, we get that we can't bind to app unless because it's not a known property. Why do we get this? Can be really hard to track. We get this error because what we're trying to do is we have property binding here, custom property binding with add input. And we're binding a property named unless. Now keep in mind, the star automatically transforms this in this ng template syntax where we then try to property bind to the directive name, which is app unless. So we have to make sure that our property here shares the name of the directive, app unless, exactly the same as the selector. Now with this, it works fine. And as you can see, if I toggle here, we get the same behavior as before, even though I commented out the ngIf block and use my own app unless directive instead. So this is our own custom structural directive built. I want to conclude the section with one other built-in structural directive, which might be handy from time to time, ng-switch. Imagine the case that we have a value like this, which is simply 10. Anything you want. Now we got a place in our app where this value changes. And we got a couple of different messages we want to display for each of these values. For this, we can use ng-switch. So let's add a new div here below our paragraphs with our own attribute directives. And ng-switched is used like this. We bind to ng-switch with property binding, so no star at this point, and we bind to value. So this is our condition basically, what we want to check. And then you might be aware that switch has a couple of cases we can now cover. So let's say we have a paragraph where we say value is 5, then we have the same for 10, then we have the same for 100, and maybe for default. Now we need to add something to these paragraphs to control which paragraph gets shown, because it should only be one of these at a time. That something is ng-switch case. And we simply pass the value for this case here as an argument, for example, 5. And we need the star at the beginning. That's super important. So here the star comes into play again, because behind the scenes, this is then also transformed by Angular. So now we can use this here for the other two use cases too, with 10 and with 100. And finally, for the default case, we have ng-switch default, like this. Now here, we also need to add the star, of course. With this in place, if we save this, we only see 10 here. And if I go to my component and I change this to 5, like this, then of course we see 5. So this is ng-switch, super easy to use, might be useful in some cases where you find yourself creating a lot of ngIf conditions. ng-switch might be the better solution in such cases. So that is structural directives finished, and that is directives overall finished. You learned a lot about them, and I hope this knowledge allows you to create awesome directives for your applications in cases where the built-in ones aren't everything you need, even though these already cover a lot of the default use cases, to be honest. So let's move on. Let's add a directive to our recipe book in the next section, and then let's move on in the course. See you there. Welcome back to the recipe book. We already use ngIf and ng-for in this section, so we're already using directives. But now I want to enhance this project by adding our own directive, which allows us to open the drop-downs, which don't work as of now if you click them. They don't work because we didn't import Bootstrap's JavaScript code, and I don't want to import this because Angular should be the only thing interacting with my DOM. But now with the directive knowledge, we can create our own directive which will manipulate these buttons. I'll add the directive in the shared folder, and I will name it dropdown directive. So the file is named dropdown directive.ts. Of course, you could use the CLI to create it, and you could even point to the shared folder in the command to automatically generated in this shared folder. I'll do it manually though, always a good practice. And here the name should be drop-down directive like this. And of course, we need to add a decorator to turn this into a directive. So it's the add directive decorator, which needs to be imported from @Angular core. And here there is one thing I need to set up. On the selector, I want to define how I can add my directive. And I will use an attribute selector, therefore I'll enclose the name in squared brackets. The name now will be app dropdown, to have a unique name which doesn't accidentally interfere with an officially existing attribute name or anything like that. Now what should this directive do? I want to add some functionality to it, which allows us to add a certain CSS class to the element it sits on once it is clicked. So once this element the directive sits on is clicked, and remove the class once we click again, let's say. So this is your challenge. Try implementing such a method which basically listens to clicks and then toggles some property which determines whether some class is attached or not, and also try implementing some code which dynamically attaches a CSS class or not. Before you actually start though, let's find out which class we need to attach. If you go to the recipe detail component here, if you attach the open CSS class to the div which holds button group, and you go to your application and select the recipe, you see now it looks like the dropdown was opened. So it's this open CSS class, the same for the usage in the header we need to attach. So that's your challenge. Build a dropdown directive which attaches this class whenever we click on it or removes it once we click a second time. Let's build this directive together now. So as explained, I want to toggle it upon clicking this. So to listen to a click, I should add host listener, which is to be imported from Angular core, and I want to listen to a click event. Then I want to execute toggle open, which looks like or sounds like a fitting name because that is what I want to do. I want to toggle whether this should be opened or not. Well, then I will add isOpen directive, which I'll set to false initially. And in my host listener, I'll simply set open or isOpen to, well, what it is currently not. So if isOpen was true, it will now be set to false and the other way around. So with that, I'm toggling that property. Now to dynamically attach or detach a CSS class depending on this, all I have to do is I'll add host binding, which needs to be imported from Angular core and allows us to bind to properties of the element the directive is placed on. And here I want to bind to the class property of that component, of that element. Class simply is an array of all the classes. And here it's all about this open class. As you learned, that's the CSS class we need to attach dynamically or detach. And now the rest will be handled by Angular. Since I bind to isOpen, this will not be attached initially. Whenever isOpen switches to true, it will be attached, and whenever it switches to false, it will be removed. And that's our entire directive. Now to be able to use it, I need to go to app module and add it here, add the dropdown directive, and add the import pointing to the shared folder. And with that imported now, I can use it. I can use it in the detail component. Here, I have to use it on the div or on the element where open should be attached to in the end. So in this case, the div with the button group class. And here I'll add my own app dropdown directive without squared brackets, without assigning any value because, well, I don't need to configure anything on this directive. And now in the header, here the place where I need to add it is this list item with the class of dropdown. Here, this is what will actually need the open class to show something. With that in place and ngserve still running, let's save this and view this in our application and see if this works the way it should. Let's test it in the header. Looks pretty good. We close it by clicking again. And here on our recipe, that looks awesome too. So that's working exactly the way I want it to work. And with that in place, that already is everything I wanted to build. So a relatively short recipe book section here. Now we can move on to services, a very powerful tool. And then we will add services in this app here to greatly enhance it and fix some things which we had to do kind of complicated thus far. We'll also add some new features. Welcome to a new module in this course. This module is about services and dependency injection. Now, what is that? Let's start with services. What are services? Let's consider this application. We got an app component, an about component, an user component, and a user detail component. Now, we might have some methods in those components. Let's say we want to log some data to the console in the about component and in the user detail component. And somehow this log statement is pretty similar, so pretty much the same text. So we're basically repeating ourselves here. We're duplicating code in two different components. Let's say in the user component, we also want to access some data, some array of users maybe. And maybe we also don't know if we will later use that in some other part of our application. Both use cases, duplication of code and data storage, providing data, are typical use cases for a service, because a service is basically just another piece in your Angular app, another class you can add, which acts as a central repository, as a central business unit, you could say, something where you can store, where you can centralize your code in. So we could create a log service, for example, to centralize our log statement. We could create a user service to manage the data storage here. Let's see this in a real app so that it becomes more clear though. Here's an example app which you can find attached to this lecture. Here we can create some accounts. You see we start with 3 accounts here at the bottom. We can switch the status of these accounts, and you can see that whenever I switch it, I log something to the console. You can also see that this gets logged if I create a new account here. And overall, what we got here is the logging and the data storage. So in general, tasks which might be centralized. We also communicate between these components. That's another area where services can be really helpful. Because let's have a look at our code. I got 3 components, the app component, then the account, and the new account component. The app component is where all comes together. There in the template I embed the app new account and the app account component, and I use property and event binding to pass data around. For example, I loop through all accounts, which are right now stored in the app account, in the app component here, and I pass them via property binding to the app account component here. And there, on the other hand, I have an event which gets fired when I click one of the 3 change the status buttons, which is emitted here, which will be catched by my app component, where I then handle it again. So I do have event binding to be informed in my app component whenever something changes in the account component. Pretty much the same happens in the new account component. There I can also listen to a click when I create a new account, and on such a click I emit some data to the app component. So this is all fine, but we already got quite a complex setup here to pass data around. And that even though that it's still relatively simple, it's not a complex app here after all. Now in this lecture, we're going to see how services can help us with that and what we have to watch out for. So let's dive into it and build our first service in the next lecture. As mentioned at the end of the last lecture, I want to start by building our first service here, a service which takes over this logging task here. So a service where we can log data. Now, how do we create a new service? How does a service look like in Angular? Creating it is super simple. First, we have to choose a fitting place. Now, since this service will do some generic task, I will place it in the app folder. You could also create a shared subfolder there. I will again place it right in the app main folder, and I will simply name it logging. And the file name should be logging.service.ts to follow this convention of being pretty clear about what's in a file. So here, this file will hold a service, so that's why I'll name it like this. There, I will export a TypeScript class, and I will name this class logging service2, again, to be explicit about what this class does. Now, a component becomes a component because we attach this add_component decorator. A directive becomes a directive because we attach add_directive. You could think that we now simply add service, right? But we don't do that. A service is just a normal TypeScript class. Like this. This can already be used as a service. So here we could create a helper method, log2console, and simply pass the message. But since we know that we simply want to log the change of account status here, I will simply say log status change like this and take the new status, which will be a string, as an argument. Here I can then simply copy the code I do have in one of my components right now, this console log code here, and copy it into my logging service here. Of course, account status now is just status here, this argument we're getting. So with that, remove the colon, semicolon. With that, I centralized this code. Now we need to use this service in our other components. So everywhere where we console log. Now you could think that we simply use it by importing it at the top of our file. So here we could import the logging service from, and now let's move up to the main folder, and then here from the logging service TS file. And then we could simply create our service like this, new logging service, and on our service here we could call log status change and pass the new account status. And actually, if I get rid of this code here, this will work. Let it recompile, and if I now create a new service here, you see I do log it to the console. So this would work, and still this is wrong. This is not, and this is super important, this is not how you use a service in Angular. The reason for this will become more clearer throughout this module, but generally Angular provides a much better way of getting access to your services. And therefore you should not create the instances manually. So let's get rid of that import and of that instantiation, and let's learn in the next video which tool Angular offers us to get access to our services. In the last lecture we created our service, and I told you to not instantiate it on your own. I told you that Angular offers some great tool which will give us access to our services. It's Angular's dependency injector. What is a dependency injector? Well, a dependency is something a class of ours will depend on. For example, the new account component depends on that logging service because we want to call a method in that service. And the dependency injector simply injects this dependency, injects an instance of this class into our component automatically. All we need to do is we need to inform Angular that we require such an instance. So how do we inform Angular that we require such an instance? We add a constructor to the class, to the component, in this case where we want to use our service. So there I can bind it to a property by using this TypeScript shortcut of adding an accessor in front of the name of the argument to instantly create a property with the same name and bind the value to it. So here I will name this logging service. This name is totally up to you. Now this is the important part here though. Add a type assignment here. This is not optional. You need to set the type, and the type has to be the class you want to get injected. Logging service in this case. Make sure to also add the import at the top. Now let me close the body of this constructor, and this simple task here informs Angular that we will need an instance of this logging service. Correctly, you might ask, well, how do we inform Angular? Why does this matter if we write this in the constructor? Think about who gives us the instance of this account component, this new account component here. This is a TypeScript class in the end, so somewhere this needs to get instantiated so that something happens in our app. Well, who is responsible for creating our components? Angular is, of course, because we're placing selectors in our templates. And when Angular comes across these selectors, it gives us instances of our components. Now, since Angular is responsible for instantiating our components, Angular will need to construct them correctly. So if we define in the constructor that we require some argument, Angular will recognize this, and now it tries to give us that argument. It tries to give us this, well, type in this case. So it knows we want an instance of the logging service class because we defined a type here. This is why this is important. Now, that is almost enough, but not quite. Now Angular knows what we want, but it doesn't know how to give us such an instance. We need to do one additional step. We need to provide a service. Provide simply means we tell Angular how to create it. And that sounds very complicated, and it is very simple. All we have to do is add one extra property to the add component decorator, the providers property here. This also takes an array like other properties we added before. And here we again just have to specify the type of what we want to be able to get provided, you could say. So logging service again. Now with that, Angular, when analyzing the component, recognizes that it should be able to give us such a logging service, and it will set itself up to be able to do so. And when it then actually builds the component, constructs it, it sees that we want to have such an instance, and it will know how to give us such an instance. And now we can simply, in our component, anywhere in this component, access our logging service property, which is created automatically since I used this TypeScript shortcut here, and call log status change. So now I'm not creating that instance manually, Angular does it for us. And why is this better than creating it manually? You will see some other advantages later, but this basically lets you stay in the Angular ecosystem, and Angular knows how your app works. Again, some other advantages will come up later. So with this, we now have the same code as before. So if we have a look at our application again and create a new account, we still see the log here, depending on which status we chose here. So this still works, but now we're injecting the service. Now let's also do the same by copying that in the account component here. So here I will also add the constructor. And of course here we also need to add the import, because TypeScript needs to know where this logging service comes from. Not Angular, TypeScript. And I will also add my provider, of course, because for this component too, I need to inform Angular how to create this logging service. So if we do this and then go back to the application here, let it reload, create a new service again. This works. Now let's change the status, and this also still works. Now, of course, because I didn't replace this here, so let's call the logging service now and call log status change and pass the status. Now if we save this and try to change this, it still works. So now we got this same logging functionality outsourced, centralized in a service, and therefore our code here is a bit leaner. And I guess you can imagine how in bigger applications where you have duplicate code, a service can really help you to get more dry, to don't repeat yourself all the time, but instead to really cleverly outsource your code into a service and have it there. We saw how to use that logging service in the last lecture. Now let me show you another typical use case for a service to store and manage our data. So for example, our accounts. Right now I store them here in the app component, and then we have this chain of property and event binding to get data to the app component so that we there can update our accounts. Let's create a service for that. The account service maybe. So I will create this, and I will export my accounts service class here. just like that. And here, I will now copy in my accounts. So I will remove them from my app component and paste them into my accounts service. And I will add an add account method here, where I simply expect to get an account name and status. And I will add a update status method where I expect to get the ID of the account I want to update and then the new status here. Now, the logic for these two methods is basically the same as in the app component. For a new account, or in the add account, I simply want to push a new account onto my array of accounts. And here I will simply quickly create a new object where I assign the name and the status, so the data we get passed into this method. And for the status changed, well, here I basically want to also just access my account with that ID here and set the status to, well, the new status we get passed as an argument too. So with that, this service looks all right. We got our our accounts there, and we got our methods to change something there. Of course, the app is broken though, because for one, I don't need that code in the app component anymore. If we have a look at the app component template, we still loop through all the accounts here. So I should still have my accounts here in the app component, but we removed them from here. They're now in the service. So we should maybe re-add them here, but now this should simply be an array of accounts. So each account object has a name, which is a string, and a status, which is a string. So I'm just defining the type here. And we want to have an array of such objects. Initially, it should be an empty array. This is what I'm saying here. Now, since we have our account service, we should inject it here as we learned it. So let's add our accounts service here of type account service. The type is super important to inform Angular about what we need here. Let's close this body of the constructor and make sure to add the import at the top pointing to your account service file. Now, what did we learn? We also need to add a provider. So here at the providers array, we should add accounts service so that Angular knows how to create such an account service. With that, we can now add, for example, onInit, this onInit lifecycle hook, as most initialization should not be done in the constructor, but instead here, and simply set this accounts equal to this account service, which is available as a property because I use this shortcut with the accessor in front of the argument name. And here I can access my accounts field. Just as a little note, since accounts here is an array, it is a reference type. This is normal JavaScript behavior. So this is a reference type. So by setting it equal here, we're actually getting access to the exact same array as stored in the service, just as a side note. So with that, we do have access to the accounts. And if we save this and have a look at our application, this still seems to work. These buttons will not work and will actually give us errors because I removed the event listeners. But in general, this looks all right. We can see the free accounts which are now stored in our account service. So with that, let's go back to our application. And here, I now want to update the account component and the new account component. Let's start with the new account. Here, we no longer need to emit this event here because we're not listening to it anyways. So we can get rid of the output here, get rid of the imports up here of event emitter and output. And instead, we should inject our service, our accounts service of type accounts service. And what did we learn? We should provide it, right? So let's add account service, and make sure to add the import at the top. Now with this, in here, I can call account service, add account, and pass the account name and the account status, as this is what this method expects to get as arguments. So with that, let's go to our account component now. Let's also get rid of the output here. We still need the inputs because we're still receiving that data from outside. And we can get rid of this event calling here. We remove the output anyways. Get rid of the imports we don't need anymore. And now here, I also want to get access to the account service. So let's inject it here too, maybe in a new line to make it more readable. The accounts service of type accounts service, like this. Make sure to add the import at the top, and let's add it to the providers array here. With that, I can now call it here, account service, call update status, pass my ID, and the new status. Again, this is what this method expects. If we now save this and go back to our application, it looks all right, but we quickly realize that if we click on add account, we don't get an error, we get the log, but I don't see the account. If I click these buttons, I also see the log, but I don't see the change here. So something is not working correctly. It seems like it doesn't, right? Well, let's have a look at what's going wrong here in the next lecture. In the last lecture, we set up our account service and hooked it up in our app, and still, our app seems to be broken. If I click these buttons, the status is not changed. So somehow our code is not working. Actually, it's working correctly. We're just using services wrong here. In this specific case, we're not using the service in the way we should use it in our app. What's going wrong? The Angular dependency injector actually is a hierarchical injector. That means that if we provide a service in some place of our app, let's say on one component, the Angular framework knows how to create an instance of that service for this component and, important, all its child components. And actually, this component and all its child components and the child components of the child components will receive the same instance of this service. There are other places where we can provide a service too. The highest possible level is the app module. We haven't done this yet, but we will see this soon. If we provide a service there, the app module does have a providers array, the same instance, and that's important, the same instance of the class of the service is available in our whole app, in all components, in all directives, in all other services where we maybe inject a service. Yes, we can inject services into services. I'll come back to this. The next level, for example, would be the app component. There, the app component and all its child components do have the same instance of the service. And this is true for any component. So even if we have a child of the app component, if we provide it on that child, all the children of this child will have the same instance and the child itself. But not the app component. The instances don't propagate up. They only go down that tree of components. The lowest level, therefore, is a single component with no child components. If we provide a service there, this component will have its own instance of the service, and well, it doesn't have any child components, so this instance will only be available for this component. And this will actually even override if we were to provide the same service on a higher level. And that's exactly what we're doing. So let's take a closer look in the next lecture. In the last lecture, we learned about that hierarchical injector. And actually, this injection behavior leads to the behavior we see here. Now, that's not a bug, that's intended. You might have an application where you want to have many different instances of the same service, where you absolutely don't want to have the same instance. But sometimes you want to have the same instance. And we definitely do. Because right now, for our account service, we have 3 instances. The first one gets created here in app component. We provide it here. App component receives its own service, or its own instance of the service, I should say, as do all the child components. Now you might say, fine, because new account and account are child components. Right. But there we provide it again, and hence we override the instance we would get from the app component. Now new account and account component have their own instances. So these are the other 2 instances of this service class. And therefore, if we add a new service, we call add account. There we push it on this array of accounts, and this actually works, but it's a totally different instance of the service
than the one we use here in app component, the one through which we loop. How can we fix it then here for our app? Simple. We just remove it from the providers array. Don't remove it from the constructor. We of course do need it here because that tells Angular that we want an instance. The providers array basically tells which instance, so there we needed to remove it. And the same for account component. Leave it in the constructor, leave the import at the top, but remove it from the providers array. With that little change, if we go back to the application after saving it, let's add another account. Now you see it at the bottom. Now you can change the status again. So this is the difference. Different instances of the service. Now we're using one and the same, before we weren't. Both may be the behavior you want in your app, but make sure that you get the correct one. In the last lecture, we learned about this hierarchical injector and that we can choose between one instance or multiple instances of the same service class. I mentioned that the highest possible level is actually not the app component. So let's remove it here, this providers array, leave it in the constructor and leave the import. But the highest possible level is in the app module. Here we also have a providers array, add it if you don't have it. And here we can also provide the accounts service. Make sure to also add the import at the top here then. With that little addition here, we're making sure that our whole application, everything in our application, receives the same instance of the service unless it overrides it as we did before. Now with that, we can now even inject a service into another service. Because that's not possible by providing it on a component level. For that, we need to provide it in the app module. So let's say we want to log something if we call an action in the account service. So I would have to provide the logging service in my app module now. And therefore, I will simply comment out providers here in my add component decorators. And I don't want to call logging service here anymore, so we'll comment this out, and I will actually leave the injection here so that you have it for reference if you download the code. I'll also comment it out here in new account component. Instead, let's say I want to use this logging service in the account service, and I might want to call the log status change method there, because this is in the end the place where the status changes, either because we added a new account or because we called update status. So to use the service there, generally we start in the same way. We add a constructor and we inject our logging service in this case, set the type, import this type at the top, make sure to add the import, and we provided it an app module. So you could think that we are set to go, that we can now go to add account, call logging service, log the status change, pass the status here, and do the same here for update status. You could think this is how we do it, and it's not unlogical to think so, but let's see if this works. If we load our app, we already get an error. Can't resolve all parameters for account service. Something's not working. The reason is if you inject a service into something, this something needs to have some metadata attached to it. Now, a component has some metadata because we have add component. A directive has some metadata because we have add directive. A service doesn't have any metadata. It's just how Angular works that we need to attach some metadata. And of course, not any metadata. You shouldn't attach add component here. There is a specific metadata you should attach in such cases. It's add injectable, which needs to be imported from add Angular core. This tells Angular that now this service is injectable, or that something can be injected in there, to be precise. So that's important. You don't add injectable to the service you want to inject, but to the service where you want to inject something. So the receiving service, you could say, the to be injected in service. And you don't need to add it to any other service. If you don't want to inject anything in a service, like here for the logging service, you don't need to add injectable. Only add it if you expect to get something injected.
Now, one important note here, as I explained, we don't need to add injectable, the injectable decorator here to this class, because this is a service which we only inject somewhere else, but where we don't inject anything into this service. And you technically really only need injectable if you inject something into this service, not if you just inject this service somewhere else. In newer versions of Angular, however, it is recommended that you always add injectable. It technically makes no difference right now. In the future it might though, so it's already a habit you might get into that you add it. Here I do omit it, but you could consider adding it also to ensure that in the future it doesn't unexpectedly break. What I explained about why you need it and that you don't need it here technically still holds though. With this, if I now save this and we let the app reload, now it works. And now you see that if I save this, we still log it to the console with the correct status. The same happens if I click here, but now everything is centralized into our service, and now we're also injecting a service into a service. We talked a lot about services in this module. And I hope you saw how services can clean our app up, make the code a bit leaner, more centralized, easier to maintain. You don't have to build these complex output-input chains where you pass events and properties to get data from component A to component B. It's much leaner now. Let me show you how much we actually saved. Let's say that if we click on the button here in the account component, for some reason, we want to output something in the new account component. Normally, without services, we would have to emit an event in the account component that something was clicked or something happened so that we changed the status, for example. We would have to catch the event here in app account. As a side note, we can of course remove these events here. They aren't triggered anymore. So we would have to catch these events here. And then we would have to pass the new data down via property binding to the component where we want to handle it. Pretty complicated. And building these chains of property and event binding is not the most convenient way of writing code. It's so much easier with services. Let's say in our account service here, we want to provide some event which we can trigger in one component and listen to in another. So we could simply add the status updated event, which could be a new event emitter, which we import from @Angular core. So make sure to add this import at the top, which will pass on the new event, the new status, so a string. And yes, we could trigger it now here in the update status method, but we can also, since we inject the account service here where we set the new status, call account service status updated and emit this with the new status. So now I'm emitting an event I set up in the service. And as a side note, later in the observable section, you will learn about another construct you can use to submit or to emit events and subscribe to it instead of using the event emitter. But for now, that's absolutely fine. So here we are emitting an event. Again, the event emitter lives in our service. And in the new account, I now want to listen to it. So here, let's say I want to throw an alert. So I will do this in a constructor for now, access my account service. And now for the status updated event here, I will subscribe to it because event emitter in the end just kind of wraps an observable. So here I could then receive the new status, which I know will be a string. And then I will simply throw an alert where I say new status, something like that. So now I'm not building any chain of property and event binding. I do have cross-component communication through a service with the event emitter. And you can see this if I click a button here. They actually got opened on another window, but you see this alert was thrown with the new status unknown. Same here, inactive, active. So now we're communicating between components through a service, which really can save you a lot of time. And with that, I hope you saw a lot of reasons why services can be very helpful and how you can use them to your advantages, make sure to use the right amount of instances. And if you inject services into services, make sure to provide the service on the app module level and to add injectable to the service where you want to inject it in. Let's move on to some assignments now. Welcome to this assignment about services. Time to practice the things you'll learn about services. And this is the app with which we're going to do it. I prepared it for you. You can find it attached to this lecture as always. Now here, we got a couple of active and inactive users. And we can switch them from active to inactive and the other way around by clicking these buttons here, as you can see. So this works, but if we have a look at the code, we see it's relatively complicated for this simple app, as we saw it throughout this module. We have this onSet to inactive button here on the active user component, for example. We there emit an event. This event reaches our app component. Here we handle it. Here we manage our users, active and inactive users, and then we pass those users to the respective components. Just dig a bit through the code. You will see it works. It's okay, but we can do it better with services. That is your goal now. I want you to optimize this app by adding a users service, which manages these users arrays globally and where we call some methods to switch users between, well, both worlds. I then also want you to add a counter service, which basically counts how often we do these two operations. How often do we switch users from active to inactive and the other way around, and simply output that count whenever it increases. These are the two services I want you to build, I want you to implement. Make sure to provide them correctly to get the right number of instances, so to say. I wish you fun with it. In the next video, you can view my solution on that. So, were you successful? Here's my solution. I would create this users service as we are asked to. And in there, we of course export a class, the users service. We don't need to add injectable right now, because right now we're not injecting a service in there. And here I now want to manage my users. Now you could create one array of users and there store objects, which for each object also tracks the state of that user. I will go with two arrays, so I will have my active and my inactive users, the two arrays from the app component. So I'll copy it from there and paste it into my user service. But again, as an improvement, you could store objects in one single array there, which then allows you to switch the status for each object, for each user. So this is this. And then I want to add a set to active method. Here I expect to get the ID of the element as should switch. And a set to inactive method. And here, of course, also you could optimize this by having one method which does both and which receives an additional argument which determines whether you want to switch active to inactive or the other way around. Well, in set to active, I want to reach out to my active users and push a new element to them. That new element is in my inactive users, the user with the ID I'm receiving there. And thereafter, I can simply splice that user. Splice will simply remove this one element in this case here. Well, now I can copy that code, paste it in here, and reverse it. Push it to the inactive users, from the active users, and splice it from the active users. Now this service is prepared. And now in my app component, I can get rid of these two methods. I also can delete my users here. So we can completely clean this component and we can clean everything in the template of the app component. We don't need to pass the properties to our components there because these components can reach out to the service on their own. Now, it is important to make sure that we provide the service on the right level. If we would provide it in the inactive user component and the active user component, we would have two different instances of that service. And therefore, it would not work. We could not switch because we would work with two different arrays. So, with four different arrays actually. So therefore, this is not the right place to provide it. We could provide it here in the app component or in the app module. Now, since we don't plan on injecting this service in another service or something like this, there is no reason to provide it application-wide, though you could do that. That's not wrong, not bad. but I will simply provide it here in the app component. But again, just to highlight this, it's not bad or wrong to provide it in the app module. So here I will provide my users service. Make sure to also add the import. With that provided on this level, active users and inactive users will actually share the same service, the same instance of that service. So now I can go to inactive users, add a constructor here, and get my users service here. So of type users service, of course, user service is the name actually. Make sure to add the import here too. You always need to add this. That's a TypeScript feature, not related to Angular. And then I can remove the input here. We're not receiving it from outside anymore. I can remove my whole output, my whole event here, and also remove this where I emit it. Remove all these imports therefore. And now I want to initialize my users array. I will do it on init, as again, it is a good practice to do initialization work in there. So let's implement on init, make sure to import it. And then we need to add the ng on init method. And in there I can set my users equal to the users I fetched from my user service. And we're in the inactive component here, so I should get my inactive users. Now with that I can simply copy that code over to the active users, replace my input and my output here too, and remove the input string, remove all these imports, but on the other hand make sure to import user service and implement on init. So just like in the other component, make sure to import on init too and import this service. And here we don't have to emit this event anymore. Instead, make sure that now users is not the inactive users but the active users, since we're in the active users component. And if we click on set to inactive, I want to reach out to the user service and call set to inactive and pass on this ID. And on the other hand, in the inactive service, I want to do the same, reach out to the user service and here call set to active and pass the ID. That should be all. Let's see if this works. If our app here is reloaded, I can still switch my users around. So this first part does work, but boy is it leaner, much less passing around, instead having a clean central service. Now the other part of the task was to add this counter service. So let's add this too, the counter service.ts file. Let's export a class here, the counter service like this. And here I simply want to manage my active to inactive counter, which starts at 0, and well, you guessed it, inactive to active counter, which also starts at 0. And now I simply want to add two methods where I say increment active to inactive. Of course, you can choose another name. And here I will simply say active to inactive counter plus plus and log the new counter, so the active to inactive counter. And then I will just duplicate this to also have my inactive to active counter, where I increase the inactive to active counter property and log the inactive to active counter property. You probably dream about inactive to active this night. But this is our counter service. Now here, you could add it in multiple places. You could add it here in the onSet to active or the onSet to inactive methods. That would be all right. But I want to add it here in my user service. So I want to inject it into a service. And for this, we have to take two things into account. First of all, we have to make sure that we provide the counter service here in the app module. So counter service. Make sure to add the import here too. Now it's available application-wide and therefore can also be injected into other services. Second, to inject a service into a service, what would you need to do? You need to add injectable to the service where you want to inject it in, right? So to the users service here, not to counter service, to user service, to the receiving service. So here I will add injectable. Don't forget the parentheses, that's a common mistake. Add the import. And with that, I can now inject the counter service in the user service. So here, counter service of type counter service. Make sure to import this type here at the top too. And with that injected, here in set to active, I can call this counter service. And since we set something to active, I want to call the increment inactive to active because we set something from inactive to active. And on the other hand, in the set to inactive, I want to increment the, well, active to inactive. So this one here. With that, if we now save this and let our app reload, and I click to set to inactive, we see that is 1. Maybe improve the output here that we say active to inactive, and then we output the number. And on the other hand, down here, we have inactive to active. So now let's just reload. Active to inactive 1, 2, and now we should add 4 to the inactive to active side and some to the active to inactive. So this is working. Everything seems to work as intended. This is my solution. Of course, you might have a different solution. There are different ways of achieving the same. Overall, you should feel confident using services now. You should see their benefits and how you might use them in your next project. Let's move on. So, were you successful? Here's my solution. I would create this users service as we are asked to. And in there, we of course export a class, the users service. We don't need to add injectable right now because right now we're not injecting a service in there. And here I now want to manage my users. Now you could create one array of users and there store objects, which for each object also tracks the state of that user. I will go with 2 arrays, so I will have my active and my inactive users, the 2 arrays from the app component. So I'll copy it from there and paste it into my user service. But again, as an improvement, you could store objects in one single array there, which then allows you to switch the status for each object, for each user. So this is this. And then I want to add a set to active method. Here I expect to get the ID of the element as should switch. And a set to inactive method. And here, of course, also you could optimize this by having one method which does both and which receives an additional argument which determines whether you want to switch active to inactive or the other way around. Well, in set to active, I want to reach out to my active users and push a new element to them. That new element is in my inactive users, the user with the ID I'm receiving there. And thereafter, I can simply splice that user. Splice will simply remove this one element in this case here. Well, now I can copy that code, paste it in here, and reverse it. Push it to the inactive users, from the active users, and splice it from the active users. Now this service is prepared. And now in my app component, I can get rid of these 2 methods. I also can delete my users here. So we can completely clean this component and we can clean everything in the template of the app component. We don't need to pass the properties to our components there because these components can reach out to the service on their own. Now, it is important to make sure that we provide the service on the right level. If we would provide it in the inactive user component and the active user component, we would have 2 different instances of that service. And therefore, it would not work. We could not switch because we would work with 2 different arrays. So, with 4 different arrays actually. So therefore, this is not the right place to provide it. We could provide it here in the app component or in the app module. Now, since we don't plan on injecting this service in another service or something like this, there is no reason to provide it application-wide, though you could do that. That's not wrong, not bad. But I will simply provide it here in the app component. But again, just to highlight this, it's not bad or wrong to provide it in the app module. So here I will provide my users service. Make sure to also add the import. With that provided on this level, active users and inactive users will actually share the same service, the same instance of that service. So now I can go to inactive users, add a constructor here, and get my users service here. So of type users service, of course, user service is the name actually. Make sure to add the import here too. You always need to add this. That's a TypeScript feature, not related to Angular. And then I can remove the input here. We're not receiving it from outside anymore. I can remove my whole output, my whole event here, and also remove this where I emit it. Remove all these imports therefore. And now I want to initialize my users array. I will do it on init, as again, it is a good practice to do initialization work in there. So let's implement on init, make sure to import it. And then we need to add the ng on init method. And in there I can set my users equal to the users I fetched from my user service. And we're in the inactive component here, so I should get my inactive users. Now with that, I can simply copy that code over to the active users, replace my input and my output here too, and remove the input string, remove all these imports, but on the other hand, make sure to import user service and implement on init. So just like in the other component, make sure to import on init too and import this service. And here we don't have to emit this event anymore. Instead, make sure that now users is not the inactive users, but the active users, since we're in the active users component. And if we click on set to inactive, I want to reach out to the user service and call set to inactive and pass on this ID. And on the other hand, in the inactive service, I want to do the same, reach out to the user service and here call set to active and pass the ID. That should be all. Let's see if this works. If our app here is reloaded, I can still switch my users around. So this first part does work, but boy is it leaner, much less passing around, instead having a clean central service. Now the other part of the task was to add this counter service. So let's add this too, the counter service.ts file. Let's export a class here, the counter service like this. And here I simply want to manage my active to inactive counter, which starts at 0, and well, you guessed it, inactive to active counter, which also starts at 0. And now I simply want to add two methods where I say increment active to inactive. Of course, you can choose another name. And here I will simply say active to inactive counter plus plus and log the new counter, so the active to inactive counter. And then I will just duplicate this to also have my inactive to active counter, where I increase the inactive to active counter property and log the inactive to active counter property. You probably dream about inactive to active this night. But this is our counter service. Now here, you could add it in multiple places. You could add it here in the onSet to active or the onSet to inactive methods. That would be all right. But I want to add it here in my user service. So I want to inject it into a service. And for this, we have to take two things into account. First of all, we have to make sure that we provide the counter service here in the app module. So counter service. Make sure to add the import here too. Now it's available application-wide and therefore can also be injected into other services. Second, to inject a service into a service, what would you need to do? You need to add injectable to the service where you want to inject it in, right? So to the users service here, not to counter service, to user service, to the receiving service. So here I will add injectable. Don't forget the parentheses, that's a common mistake. Add the import. And with that, I can now inject the counter service in the user service. So here, counter service of type counter service. Make sure to import this type here at the top too. And with that injected, here in set to active, I can call this counter service. And since we set something to active, I want to call the increment inactive to active because we set something from inactive to active. And on the other hand, in the set to inactive, I want to increment the, well, active to inactive. So this one here. With that, if we now save this and let our app reload, and I click to set to inactive, we see that is 1. Maybe improve the output here that we say active to inactive, and then we output the number. And on the other hand, down here, we have inactive to active. So now let's just reload. Active to inactive 1, 2, and now we should add 4 to the inactive to active side and some to the active to inactive. So this is working. Everything seems to work as intended. This is my solution. Of course, you might have a different solution. There are different ways of achieving the same. Overall, you should feel confident using services now. You should see their benefits and how you might use them in your next project. Let's move on. Welcome back to the recipe project. We already added a lot of features to it. Now it's time to add services to it, which will give us the possibility to greatly enhance this project. Which services do we need? Let's have a look at our application again. This is the application the way it looks right now. Now, services allow us to centralize tasks, manage data in a central place, and so on. So we probably need a service for both feature areas. We will need a shopping list service and a recipe service. The shopping list service managing, well, our shopping list, and we will also access it from the recipe area, because we want to add items to the shopping list from there. And, well, the recipe service, that will be responsible for managing our recipes, managing the data there, and so on. So we will use both services, and as always, the challenge for you, create both services. For now, only create the files and try to find places in our app structure where they just fit in. And thereafter, we will fill them with some life together. So let's start together in the next section. Try to create these files on your own. So let's add some services manually. Now, we should place services next to the feature or in the folder holding the feature they belong to. So if we create a recipe service, the recipes folder looks like a good place for it. So here I'll add a recipe service, and of course the file is named recipe.service.ts due to that. And here I will simply export a class which is named recipe service. Remember, a service simply is a TypeScript class. You don't need to add any special decorator to it, at least not if you don't plan on injecting a service into the service. Well, and the same for the shopping list service. I'll place it in the shopping list folder. Here I'll name it shoppinglist.service.ts. That's the file name. And then inside the file, of course, I'll export a class named shopping list service. So these are the two service files. Now let's start working on the recipe service first. Let's start working on it in the next lecture. What should our recipe service do for us? I guess it makes sense if the recipe service is the place in our app where we manage our recipes. Therefore, we should take our recipes, which we currently manage in our recipe list, and manage it in the recipe service. That's the first thing with which I'll start, so I'll simply copy it for now and add it as a property in the recipe service. Of course, we now have to add the import pointing to the recipe model file, which sits in the same folder as the service. So with that, we got an array of recipes in the recipe service. And I will actually make this private so that you can't directly access this array from outside. Now with this added, I also want to add a getRecipes method which will return this array so that we can get access to it from outside. If I were to return it like this, I actually return the direct reference to this array. And since arrays and objects are reference types in JavaScript, so has nothing to do with Angular, vanilla JavaScript it is, well, if we now change something on this array, we will change it on the array in the service. Therefore, I will call slice with no arguments. This will simply return a new array, which is an exact copy of the one in this service file. So therefore, we really can't access the recipes array stored here from outside. We only get a copy. So that is a way to get our recipes. Now with that, we can and we have to add our service, actually both services, to a place in our app to provide them so that we can inject them. Where should we provide both services? Well, let's start with providing the recipe service in our recipe component. We can always put it somewhere else later if we recognize that we want access to it from another part in our app. But for now, I'll add providers, this array, to the recipe component. Therefore, this component and all other recipe-related components, since they are all child components to this component in the end, will share the same instance of this service, but you won't be able to access the service, or at least not the same instance, in other components like the shopping list component. So here in providers, I will list my recipe service. Of course, you have to add an import at the top telling TypeScript where to find this type. Now with this, we can use our recipe service here. Now let's use it in the recipe list component. Here right now, we already manage our recipe array. Now, I don't want to do that here anymore. It will be undefined initially. We will get the value here in ng-on-init. And for this, we need to inject our service. Now we can do this since we just provided it on the parent component. So here I will provide my recipe service, which is of type recipe service. Of course, make sure to import recipe service from the appropriate file, and this should be private here to use this TypeScript shortcut of instantly assigning a property with the same name. In ng-on-init, I can now say this recipes equals this recipe service get recipes, and we will get this copy of recipes, this copy of that array. Well, let's see this in action. If we save this, we should, and we do, see the same as before. The app works just like before because the only thing we changed right now is where and how we manage our array of recipes. An important first step. In the last lecture, we used our recipe service, and we created it in the first place, we filled it with some life, to manage our recipes in a central place. That is working great. Now let's use that service to improve our app. Remember, we have this long chain of inputs and outputs, getting a selected item from the recipe item component over the recipe list component to the recipes component, here where we listen to that event, and then all the way down using the selected recipe property to the recipe detail component. So this cross-component communication. That is a super long way for just informing another component that we selected an item. We can do better, and we should. So what my goal is, that in the recipe item component, where we have this onSelected click, that here we can directly inform the recipe detail component. So in onClick, what I actually want to do here is, I want to not emit an event here. I will get rid of it here, and therefore I can remove the imports from of output and event emitter. Instead here, I want to call some method in my service, which will then, transfer this data for me. So in the recipe service, I'll add a new property, a public property, which I'll name recipe selected. Of course, you could choose a different name. It will be an object instantiated by using event emitter from Angular core. So you need to add this import. Let's put it
at the top of the file. That's kind of a good practice to do with your Angular imports. It will hold some recipe data, and that's all I want to do in the recipe service. With this setup, and of course you could also encapsulate this by providing a method to get access to it and one to emit the event, but I will use the property itself. So by adding this, I can now go back to my recipe item component, and in onSelected, I want to do something with that property in the recipe service. So first of all, let's inject it. Let's inject the recipe service as you learn to do it. Make sure to import it pointing to the recipe service file in the right folder. And then on the recipe service, we can use this recipe selected event emitter and call emit and emit the recipe of this recipe item component, because that is the one we selected. And that's the data we want to pass. Now with this trick, or with this approach, we can go to the recipe list component and remove this listener where we listened to whether we did select it or not. We can get rid of the onRecipeSelected code and get rid of our own emitted event here. So we're already saving a lot of code, get rid of all these imports which we don't need anymore. And in the recipes component HTML file, we can also get rid of this event here on the recipe list, because we no longer use this chain of data to pass it around. And now all I want to do is, in this component here, I want to listen to this event in the recipe service so that I can now correctly decide whether we do have a selected recipe and should therefore render the detail component, or if we should still show this template with this please select a recipe text. Therefore, I will inject the service here too, recipe service, and since I provide the recipe service on this component and all the other components in this recipe folder use the same instance of the service, which of course is super important. Otherwise, the service where I emit the event would be a different one to the one I listen to it, so I would never get informed about the event. But here it will work because we're using the same instance. So here in ng-on-init, for example, I can set up my listener. So on the recipe selected, I can subscribe to it and get informed about any changes. And now here, I know I will receive some data which is of type recipe, because that's how we configured the event emitter. It will give us a recipe. And in this ES6 arrow function here, that is the argument list, and here is the function body. Here, I simply want to set this selected recipe equal to the recipe we got with the event. And with that, we should get the same behavior as before if we reload the app, but now having a much leaner approach of using a service for cross-component communication, which of course makes it much easier to pass this data as you saw, and we don't have to build this complex chain of event and property binding. So in the last lectures, we improved our recipe section a lot with the service. Now let's work on the shopping list side, on the shopping list service. This service is empty right now. Now here's your challenge. Fill it with some life. It would be nice if this service could manage our shopping list, so our list of ingredients. Maybe you even add the add ingredient method here so that you can add ingredients using this service too. We already got this add functionality here in the shopping list component. It shouldn't live here anymore though. And with that, we would take a huge step forward. So your chance to pause the video and try this on your own. Thereafter, we'll solve it together. So, were you successful? Let's fill this shopping list service with some life. For this, I'll first of all copy my ingredients here and add it here as a property to the service. And of course, I need to import ingredient from the shared folder from the ingredient model there. Now with that, we got the data in here, and I will make this private. Now, just like in the in the recipe service, I will add a get ingredients method here, where I will return my ingredients, but only a copy of it with the slice method, so that I can't access the original array stored in this service.
With that, I can go back to my shopping list component and I will set this to an uninitialized property, but I can inject my shopping list service. Now again, the question is, where should we provide it? Now for now, we can provide it here in the shopping list component, and therefore it would also be available in the shopping edit component. But actually later I also want to access it from my recipe section. That is why I will actually provide it an app module, and here I will add it to this provider's array, therefore shopping list service. Make sure to also add the import at the top here. So now we will be able to use this service application-wide, including in other services, and I exactly need this behavior because we will soon use it in another service. So back to the shopping list component then, we can now inject the shopping list service, and I'll bind it to a property named SL service. Of course, you can choose a different name, which will be of type shopping list service, and you need to add the import pointing to the shopping list.service file. With that, an ng-on init, because you should do all tasks which require a bit more heavy lifting, or in general, as a good practice, all initializations in ng-on init. Therefore here, I will simply assign my ingredients to whatever the shopping list service returns me if I call get ingredients here. With this in place, if we save this and we go to the shopping list area, this is still working, so that's great. Now let's make sure that we can also add items. So I'll add the add ingredient method here. And I know that I will receive an ingredient here of type ingredient. And all I want to do then is I want to access my ingredients and push this new ingredient on it. So here, ingredient. Now if we go to the shopping edit component, right now we're emitting an event with our own ingredient. We no longer need to do this, so we can get rid of the event of output and of the imports here related to this. We can also go to the shopping list component HTML file and remove our listener where we listen to this event. And in the shopping list component TypeScript file, we can get rid of the onIngredientAdded method because we'll now do this in the service. So back to the shopping edit component where we create a new ingredient. Here I want to use the service, and for this I will access my service. So I will inject SL service here like this. Make sure to add the import, of course. And in onAdd item, I'll add SL service and add an ingredient to it, this new ingredient here. Now if we save this and now try adding a new item here, bread 1, we don't see it, but we also don't get an error. Now there is something wrong here, and we will find out what and fix it in the next lecture. In the last lecture, we basically finished our shopping list service, but here's one thing which is not working. I can click this add button as often as I want. I don't get an error, but I also don't see it getting added to this list. The reason for this is that when we call get ingredients, which we of course do to populate this list, we only get a slice of the ingredients array, so we get a copy. Therefore, once we add a new ingredient, which we of course don't add to the copy but to the original array, that is not reflected in our components where we only have that copy to work with. Now there are a couple of ways of solving this. For the easiest solution, you could remove slice, and that's not necessarily bad. You would then simply return the original array. And if you are sure you don't accidentally edit it somewhere, this might not be wrong. I chose this approach here though, because I want to show you a different solution. We basically have to inform our component that new data is available. So I will simply add a new event emitter here, and I'll name it ingredients changed. And I'll set this to, or I'll of course set this to a new event emitter to be imported from @AngularCore. This event emitter now
can emit our ingredient array. So the type it will pass on is an array of ingredients. And now here, whenever we change this array, we simply call this ingredients changed and emit a new event. And we, of course, pass a value here, our original ingredients array, though to be precise, again, only a copy of it. So now we always have the right ingredients array in the service, and we inform other interested components about that change in the event we're emitting here. So now in the shopping list component, besides getting the ingredients at the point of time we load the app, I also want to reach out to my shopping list service and simply subscribe to that ingredients changed event. So now whenever ingredients change, I know that I will get them. This will be of type ingredient array here, as we learned. And now I can use them here in the body of this anonymous function I'm passing to subscribe. And here I can now simply set this ingredients equal to the ingredients I got here. And with this change in place, now if we let the application reload here and go to shopping list, and now I add bread, and now you see it gets added here again without any issues, because now we're getting informed that something changed. We're almost finished. Our application is taking shape and services really improved it. Now I want to do something here on the recipes section. I want each recipe to have some ingredients, so we need to implement this. And thereafter, I want to make this to shopping list button work so that we can send our ingredients to the shopping list. So to do this, what I will do is, first of all, I will work on the recipe model. It should now also have ingredients. So this will be of type ingredient array. Ingredient, of course, needs to be imported from the respective model file in the shared folder. And when we create a new instance of this model, I expect to get some ingredients here. Again, this will be of type ingredient array, so that here we can assign ingredients equal to the ingredients we get as an argument here. So with that, we are prepared to have some ingredients. Now in the recipe service, I also need to add some here. So when we create a new recipe, and I'll simply structure this over multiple lines to make it easier to read, I also now will pass an array of ingredients, the same for the second recipe here. And now I guess it's time to also turn this into some real recipes, so let me quickly do this. So I quickly change the pictures and the text to have a schnitzel and a burger here. And now let's add some ingredients here in this array of ingredients. We can use the ingredient constructor for this. And of course, we need to import the ingredient type here from the model file, located in the shared folder for that. And now for the schnitzel, let's say we need the meat with an amount of 1 maybe. And then we also want to have some French fries here. Let's say exactly 20. With 1 extra, it would probably not taste well, I guess. So now with the array for the burger, here we also need a new ingredient. We need the buns, so the bread basically. Let's say 2. And we also want to have the meat here. Of course, feel free to add more ingredients. So now that we added that in the recipe detail component, here where we have this ingredients placeholder, well, we can actually now output them here. So let's add something here. Let's add an unordered list with a class of list group. And now here I want to add a list group item. This item here will actually be replicated because, again, this will of course be my ingredient. So here ng4, and now I will loop through all the ingredients. So ingredient of, and now of recipe ingredients, of course. Because remember, in the recipe detail component, we have a recipe and that has some ingredients, since a couple of seconds at least. So now we can simply use string interpolation here to output the ingredient name, and then maybe separated by a dash, the
amount. Of course, any format you like. So that's the first step. Now if we select the recipe, we see a list of ingredients at the bottom. Now I want to send these to the shopping list if I click this To Shopping List button. So that is what we'll work on in the next lecture. In the last lecture we added some ingredients. Now I want you to make this To Shopping List button work. You can come up with some ideas, some solution on how you can send these items to the shopping list so that once we go to the shopping list, we see them here. Think about informing the component that something changed, and also think about how to add more than one item at once to the shopping list. I wish you luck with that. Time to pause. In a couple of seconds, we'll do it together. So, were you successful? Let's add the shopping list items together. We already have this button in the recipe detail component. So the first step, of course, is to hook this button up. I will remove the ref here and instead add an inline style to still have a cursor, which looks like a pointer. But then here on the click listener, I'll call onAdd to shopping list. Of course, you can choose a different name. Now that will be executed here in the component body, in the recipe detail component TypeScript file. And here we either need to get access to the shopping list service or to the recipe service. And then the recipe service accesses the shopping list service. You can find arguments for both. You could say we're in the recipe section, therefore we should mainly work with the recipe service. You could say, why would we take this extra way, this extra step? We can directly access the shopping list service. Again, arguments can be found for both directions. I will choose the route where we use the recipe service. So I will inject the recipe service here. Type recipe service, of course. Make sure to add the import. And now I need to add a method in the recipe service. This is the add ingredients to shopping list method. Of course, you can also pick a shorter name if this one is a bit too long for you. Here, I expect to receive my ingredients, so that will be of type ingredients. And before we continue working on this in the recipe service, let's call this method. So in the in the recipe detail component, I will access my recipe service, call this brand new method with the extremely short name, and pass on the ingredients of this recipe here. So these ingredients. So with that, these ingredients are passed to the recipe service. Now here we need to access the shopping list service. Now for that we need to get access to the shopping list service in this file. And if you want to inject a service into a service, as we want to do here, you need to add injectable to that service. Make sure to import it from @Angular core. With that added here, we can inject the service now in the constructor of this recipe service class. Here I'll add the SL service, so the shopping list service, to which you'll need to add an import at the top, pointing to the shopping list folder and then the shopping list service file. And with that added, we can now reach out to that here, SL service, and here we need to add a new method. So let's go to the shopping list service and let's add a add ingredients method, like that. Now in here we will receive our list of ingredients, so of type ingredient array, and now we need a logic to add them. Now a quick and easy way would be to simply loop through them, so let ingredient of ingredients, ingredients like that, and then we could simply call this add ingredient for each ingredient. And that would be absolutely fine. The only downside probably is that we emit a lot of events. Now it won't be too bad because even a recipe with like 30 ingredients wouldn't blow up our app. But still there are a lot of unnecessary event emissions. So that is a viable option, but I'll comment it out. A different one would be to directly add all ingredients in one go and then emit our event. So we could access our ingredients here and call the push method. And now we can use a ES6 feature, the spread operator, which allows us to basically turn an array of elements into a list of elements. Because the push method here is able to handle multiple objects. However, it is not able to handle an array. Or to be precise, it can handle an array, but then it would push this array as a single object to the other array. So by adding the spread operator, which is simply 3 dots, might look strange, but that is how the operator looks, we can now simply spread our ingredients into a list of single ingredients which are now pushed without issues to our ingredients array. And then, don't forget it, we have to emit that our ingredients changed, so why don't we simply pass a copy of it. So with that now, we got a method we can call, add ingredients. So back in the recipe service, on the shopping list service, we can now call add ingredients and pass our ingredients to that service. With that, let's save this and let's simply check this. Right now we only have the default values of apples and tomatoes on our shopping list. Now on the schnitzel we got meat and French fries. Let's click to shopping list and let's go to the shopping list and we see meat and French fries. Awesome, that looks really great. Of course, if you click this multiple times, it will duplicate it. And you can, of course, write some logic to check if an item has already been added and then group it together by name. I won't do this in this application. The main thing here is it works. We can send data around through our app by using services. We took a major step forward. Now, in the next section, we're going to have a look at routing, and thereafter we're going to add routing to this application to now get a proper navigation and also to make this new recipe button here work. So, see you there. Welcome to another course module. Welcome to this course module. We already learned a lot about Angular, and thus far we really built a single page application. We used directives and so on to change portions of this page, but in the end, we always were on the same page. If you looked at the URL at the top, it was always localhost 4200. Now, what if you wanted to have a page where you actually display several pages, like you have a /users or a /accounts page? Now, you might think that for this, you indeed need multiple pages, multiple index HTML files or something like this. But you don't. Angular ships with its own router, which allows you to change the URL in the URL bar and still only use one page, but then exchange major parts or a lot of parts of that page so that to the user, it really looks like a new page was loaded because maybe only the header is the same, but behind the scenes, it is still JavaScript changing a lot of parts in your DOM, in your page, making it look like a new page was rendered, but you're still in the Angular world in your single page application. Let's take a closer look in this module. Attached to this lecture, you find this example project here. Now, on the first look, it might look nice, but it has one fundamental issue. We can't switch the pages here. We get some tabs at the top, but these tabs are not working. And therefore, what we see on this home page are actually all the components I later want to split up over multiple pages, or multiple pages in quotation marks, I should say, in this module. We do have a home, a servers, and a users page. And as you can see here, we got users, servers, and the home page on the same page. So that is something we can improve, but it would be nice to have separate pages as I said. So a /users page or a /servers page and so on. So this is what we're going to work in this module. And for this, we need routes. We need the Angular router, and the Angular router needs to know which routes our front-end application has.
So you might know this pattern from a full stack application where you also register some routes the user can then visit. We can do the same in Angular, and we will do this in the next lecture. So here I am in the source code responsible for the app you saw in the last lecture. And as you can see, here I got 3 major components and then some subcomponents of these components. In the app component, I'm loading them all: my home component, my users component, and the servers component. For now, I'm going to ignore my subcomponents here, edit server and a single server, so we will later nest this even more. But for now, it would be nice if of these 3 components, I would only display one at a time, so that we can dynamically load them by clicking on these links here at the top, and we really load a different route in our app. Now, where do we register such routes? Let's think about this logically. These routes are responsible for our whole app. Everywhere in our application, if we enter /users, we want to load the users component as our main page, let's say. So since this is really a core part of our app, where should we register it? Well, the app module sounds like a good place, because here is where we configure our app, where we add all these components and so on. So this might be a good place to also inform Angular about the routes our application has. And it is. So here above this @ng-module decorator here, I will add a new constant and I will name it app routes, because it should hold all the routes of my application. Now this routes constant should be of a specific type, the routes type, which needs to be imported from @AngularRouter. So make sure to add this import at the top. This is the type informing Angular, or giving these routes some structure, I should say. You don't necessarily have to add it here, but it is a good practice. Now with this import added and the constant set up, what should this constant actually hold? It should hold an array, because we will have multiple routes. So we add all the routes we want to set up to this array for now. And each route now is just a JavaScript object in this array. Now the question is, how should such a route be configured in an Angular app? It has to follow a specific pattern, a specific structure for Angular to be able to use it. And this structure always needs a path. This is what gets entered in the URL after your domain. This should be a string. And the first route I want to add could be my users route. This allows me to then visit localhost, or whatever your domain is, 4200 in this case here, and then /users. So that is your path without the slash. And this is important. Make sure you don't add the slash here. This would be incorrect. Add it without the slash. So this is now the path, and this will later allow Angular to determine which route in our array of routes here should be selected if we enter something in the URL or click some link, because it clearly defines, well, which path this route should be. Now we also need to define what should happen when this path here is reached. Right now, nothing happens. It's a route, but yeah, there is no action attached to it. The action typically is a component, so that you inform Angular that once this path here is reached, a certain component should be loaded. And this component will then be the page, you could say, which gets loaded. So here for users, it sounds about right to load our users component. And of course, it's up to you to make sure that in your application, you are indeed, well, configuring your components you want to serve as pages, to look like pages, to have all the content you want to have on this page. In this case, that's the case for my users component. Here, at least for now, it will output my list of users and then the single user component next to it. And we will later improve this to also be able to select a user from this list of users here, but for now that's fine. So this is now my first route with the users component getting loaded once we target /users. Now let's add a couple of other routes. I'll duplicate this or replicate this twice. I also want to have a certain page I display once we have just localhost 4200, so an empty path after it, you could say. So we should also create a route for this with just an empty path. And here I want to load my home component. This is the starting page, you could say. You, of course, don't need to have such an empty path, but then you somehow need to handle this, well, the user accesses an empty path differently, and I will come back to this later. So for now, we have an empty path, just localhost 4200 loading the home component, /users will load the users component, and I also want to have /servers, which will load my server or servers component. With that, 3 routes are set up here, but that alone won't do anything. How would Angular know that you want to use this constant? You could have added any constant here, and the name app routes, well, that is totally up to you. So right now, these routes will be ignored by Angular, and the type routes here doesn't do anything when it comes to this. So we somehow need to register these routes in our app. And we do this by adding a new import here to this imports array. We need to add the router module here, and the router module should be imported from our @Angular router package here. So with this added, we're adding the routing functionality to our app, but still our routes are not registered. That is why this router module has a special method we can call forRoute, which allows us to register some routes for our main application here. So forRoute will now receive our app routes constant here as an argument, and with that our routes are now registered in our Angular app on this router module, which gives us this routing functionality, and now Angular knows our routes. The missing piece is some place to render the currently selected component, because if you have a look at our app component template, we still add our components here with their selector. Now, okay, we visit /users, so Angular knows we want to load the users page, but how does it know where to display it? How does it know if you want to display it here, or maybe here in the header? It doesn't know. So the right place to inform it where to load it is to get rid of all these rows here but one, so only have the place where you actually want to render your route. And now you don't add your component with its selector, but you add a special directive shipping with Angular, the router outlet. Now this looks like a component, but it still only is a directive. Keep in mind, directives may have any selector, including this component or this element style selector. And with this now simply marks the place in our document where we want the Angular router to load the component of the currently selected route. And with this all set up, if we now save this and let it rebuild therefore, we should see that this rebuilds successfully. And if we visit our page now, you see we only see the home page now. And if we now enter /users here, we see the users page. And if we enter /servers, we see the servers page. So this is working. Of course, our links are not working. This is something we will work on next. In the last lecture, we made our routing work, we added routes, and we gave Angular a place to load our currently active component. But one issue we have is right now we can only navigate around by manually typing it here in the address bar. Not super convenient, and whilst it is important to be able to load a route directly from the address bar, it would also be nice to have some working links here in our navigation to have these tabs work. So let's add some links to our application. And if we go to our app component, we see here's our navigation. The first thing you might think about is, hey, we already have this ref attribute here to be precise. So here we could have ref, just / to load our root route. Here we could have /servers. And here we could have /users. And if we now save this, we added all the routes, the paths we set up in our routes configuration to our navigation here. And hence, if this reloads and we click the tabs, hey, this is indeed working. Now we are correctly loading the route we want to load. Okay, this tab is not updated, but I will come back to this later. But the reloading is working. And that's the issue. It's reloading the app. Watch this reload icon here. Do you see this? We refresh the app with every link we click. And that's the natural behavior, because with every link we click, a new request gets sent to the server, and it returns us a new page. And since this page is still our Angular app with the routes registered on it, it is able to give us the correct route. So the same thing happens as if we entered this manually here. That, however, is not the best behavior because it means it restarts our app on every navigation. That of course means our whole application state will be lost, and it might not really be the behavior we want to offer to the user. So this is not how you should implement navigation. How should you implement it then? There is a special directive Angular gives us. Let's get rid of all these ref attributes here. So this is not how we will navigate around. Instead, let's use this special directive. It's called router link. Now, router link like this simply is able to parse a string where we could pass just slash. So just this string slash to router link here. Now this will tell Angular that this element on which router link is placed here, this anchor tag here, will serve as a link in the end, but it will handle a click differently, as you will see in a second. Let's now also add this to the servers link, so router link equals slash servers. And I will come back to how you may write the path here in the next lecture. Another way of using router link is with property binding. So you can enclose it in squared brackets. And now, of course, you can't just pass slash users here because this would now search for a property with that name, which would even be an invalid name in JavaScript. So now you have to pass a string here with single quotation marks, or better, an array, which gives you a more fine-grained control over router link. And I will come back to this later when this is especially useful. Here in this array, you now specify all these segments of your path as elements in this array. So the first segment in this case is only a string slash users. And if you had slash users slash something, you would have a second element here, which is then just something without a slash. The leading slash here is only needed to make this an absolute path, and I will come back to this in the next lecture. For now, we'll get rid of this. Now, this array notation is not super convenient, but soon you will see when it really gives you an advantage or when you need this notation. It allows you to construct more complex paths very easily. So with this, we set up our free links using router link, either by passing a string or this array, which allows us to define our individual path elements. With that, if we save this and have a look at our application, now you see it still reloads, or it still gives us the components, but it doesn't reload the page. If you watch this reload icon, nothing is happening there. Because router link catches the click on the element, prevents the default, which would be to send a request, and instead analyzes what we passed here to the router link directive, so this path or this array of path elements, and then parses it and checks if it finds a fitting route in our configuration, which it of course does because we defined all the paths we're using here. And this is how we can navigate around with the router link, and this actually is how we should navigate around because it gives us the better user experience, it doesn't restart our app, therefore it keeps the app state, and it's much faster than reloading the page all the time. You can, of course, still type something here manually, so that will still work, but if you're inside of the app, using router link is much better. In the last lecture, we added this navigation, and I also mentioned that you can change the way you use your paths here. Right now we use slash servers, or even with this more complex notation, we have slash users as the first element. Now what happens if we just use servers here like this and just use users like this? Let's save this without the leading slash. Now if we click there on our links, you still see this works absolutely fine, nothing changed. Now let's go to our servers component template file here. And for now, let's quickly add an anchor teller element here, where we also add a router link, where I add servers again. Reload page would be a fitting description. So on this servers component, I now added this router link where I basically want to make sure that I stay on the servers page, which I'm already on. So if we go to servers here, we see the reload page here. And if I click it, you see we got an error. This error here occurs because it doesn't find a route which is servers/servers. Now this error won't occur if on the servers component I I turn this to slash servers, so to an absolute path. It was a relative path. Here, if we now have our console still open and I click reload page, nothing occurs here, no error occurs, because now it simply navigates to localhost 4200/servers, as you can see down there. And if we turn this back to a relative path, the difference was that now it tries to go /servers servers. So with a relative path, it always appends the path you specify in the router link to the end of your current path. And important here, the current path depends on which component you're currently on. That is why we could remove that in our navigation, where we also use relative paths, because that is on our root component. This component is not loaded through the router, so this root component always sits at localhost 4200/nothing. So this is always at our root level, which is why we can use relative paths here too. But one layer below that, once we loaded a route, for example the servers component, this page is only loaded if we are at /servers. So if we add a relative route here, this will now get appended to this route we're on, so it will try to load servers/servers, and therefore it gives us an error in our case because we haven't registered a servers/servers route. Now, of course, using relative paths inside of active components, active routes, might be a nice thing if you have nested routes. Right now, it will only break the app though. Now, you can also use relative paths with / at the beginning. This is the same as having nothing there. And you can even navigate around like in a folder directory. You could add // which means go up one level, and then add this to the path here. Now, if we do this inside of our servers component, you will see if I hover over this, now it again only tries to load /servers, and therefore we don't see an error. Because now it first goes back one level, which basically is to just our root path, so it removes one path, and important path depends on the route you're on. So if you were on servers/something, and this would load this component, it would remove both. So this does not necessarily only remove one segment here, it removes the currently loaded segment, you could say. So in this case it removes this, and then adds /servers again, which is why this works. And this is how you can navigate around absolute paths with a / at the beginning, which will always get appended to the root domain, relative paths without a / or with /, which means added to the currently loaded path, or // and you can even add more of them, to say, well, go back one path, go back another path, so always seen from the currently loaded component on. And if that is something which is not 100% clear, you will see it throughout its module, but also feel free to play around with it, add your own routes, add some nesting, add more complex paths, and see how this works out. But for now, let's continue with our application. I will remove this reload page link, and let's enhance this a bit more. We, of course, added navigation to our page, but one issue is that whilst it does work fine, we get no visual indication of what the currently active route is. It would be nice if the selected tab would change, and that, of course, is only a CSS thing. Because if you check your app component here, you see we got this active class on the list item, which determines whether this is marked as active, if this link gets the right CSS classes or not. So it would be nice if we could dynamically set this class. I will remove it from here, and how can we now set it dynamically? Angular gives us a specific directive for this. The router link active directive. And the convenient thing about this directive is you can add it to a wrapping element like we do here to the list item, or also, of course, to the link itself. And it will attach the class you specify in between here, for example, active, so this should be a string, to that element it sits on. Now, active on the link itself wouldn't do anything when using Bootstrap. Here for this tabs look, we need to add it to the list item, but this of course depends on which package or which CSS code you are using. And here you could specify any class you want, like my active class or whatever that is. So here it is active to make it look nice in Bootstrap's world. And I will add it to all my links here. So now theoretically, all my links should receive this active CSS class once they are clicked or when they are active. So if we have a look at this, it seems to work because we still have home set as our active page, even though we removed this class, this active class we had there before. If I click servers, it gets marked as active too, and the same for users, so this works. But somehow home is always marked as active, so that does not seem to work correctly. What's wrong here? Well, the router link active directive does one thing. It analyzes your currently loaded path and then checks which links lead to a route which uses this path. And by default, it marks an element as active. It adds this CSS class if it contains the path you are on, or if this link is part of the path which is currently loaded. So for the /servers link or the /users link, this is of course the case once we click servers or users. For the /nothing link, which is the first one, the home page, this is always the case. We always have /nothing at the beginning of our path here. So if we are on /users, well, there is this empty path in between, you could say. The same for servers and the same for just home, of course. So the empty path segment is part of all paths. Still, we don't want to have home being marked as active all the time. So to fix this, we can add some configuration to this router link active directive. And I will just split this up all over multiple lines to make this a bit easier to read. So we can add a special configuration to our router link active directive. So on the same element as router link active was added to, we can add router link active options. And this now needs some property binding because we don't just pass a string there. Instead, we pass a JavaScript object, and that would not work without having our squared brackets. So with squared brackets, we can pass anything which will be resolved dynamically, like this JavaScript object. And here we can basically add one important configuration, say exact, and set this to true. So exact is a kind of a reserved property on this object you pass to router link active options, and this will now basically tell Angular only add this router link active class, so this active CSS class in this case, if the exact, the full path is, well, whatever this link leads to. So only if everything is just / and not if it is only part of the path. So with this in place, now you see it still is marked as active on the empty path at the starting page. But if you go to /servers, now only servers is marked as active because now we fixed this. We changed the default behavior to make sure we only mark this if the full path is, well, whatever we have on our router link. Whoa, we already covered quite some things. We learned how to add routes and how to load them, either by typing it manually into our navigation bar here or by clicking some links. We also learned how to style these links. But what now if we wanted to load a route programmatically? So we don't have a link the user can click, but we finished some operation or the user clicked some button and then we want to trigger the navigation from our TypeScript code. We can do this. Let's say in our home component here, I add a new button to it. And on this button, I simply want to load the server's page. So here, now we could try adding router link, but let's say I want to have a click listener and execute some method because we do something else than just navigating there. I will also add some CSS classes to make this button look nice. So on this click listener, I want to execute onload servers. And here, this method now gets implemented in the home component. And in onload servers, I simply want to navigate to the service component. So we could, for this example, of course, also use a router link. But let's say here we have some complex calculation, or we reach out to our backend, we store something on the server, and once we are done, now we want to navigate away. To do so, we somehow need to get access to our router, this Angular router, because we need to tell it, hey, please navigate somewhere else. The nice thing is we can inject this router. So let's bind it to a private property, maybe we name it router. And this will be of type router. Router needs to be imported from @AngularRouter. With this injected, we can use this router here. So this router, and then we get a couple of methods there. One of the most important ones being navigate. Now navigate takes an argument which allows us to, guess what, navigate to a new route. And here a route is defined as an array of the single or the different elements of this new path. So just like here in app component, where I also explained this alternative way of binding router link, binding it to an array, where you could have users for the users part of your path, and then another element for maybe something for the something part of your path. Now you always have to pass such an array when using the navigate method, but in here still the first element is simply the first element or the first segment of your path. So if let's say we want to go to /servers here, we could add /servers here. And as before, this is now an absolute path. You could have a relative one, but here you have to control to what this should be relative to. And I will come back to this. So for now, let's make it an absolute path here. And once we did this, let's check our page here, click this button, and we go to servers. So this is now programmatically routing to a different page. Still, it doesn't reload our page. It does the same as if we clicked a router link, but with this router navigate method, we are able to trigger this programmatically, so trigger this in our code. In the last lecture, we learned how to navigate programmatically. Now I want to also have a look at how we can use relative paths there. So back in our servers component, let's say we have again our reload page link, but this time it's a button here with button primary, and still we might use this approach because we want to do some different things. So reload page, and here I will have my click listener on reload maybe. So if we now go to our TypeScript code, here on reload will be the method which gets triggered. And we already inject this service here. I also want to inject the router. So let's add router here. Make sure to add the import from @AngularRouter. So we learned that now we could say this router navigate. And now let's add /servers here. If we do this, and we save this page, and we go to the servers page and click reload, nothing happens. We don't get an error because we are already on this page. Technically, it still reloads the page, but keep in mind it never sends a request, so this reload icon will never spin. But Angular simply determined that we are on this page, so no further action is needed. Now let's say we remove the slash at the beginning, so we turn this into a relative path, and we still are on the servers component, keep this in mind. So now if this reloaded and we click this page, we still don't get an error. And now this might be strange because before, when we used the router link, you saw that we did get an error because it would try to add servers to the end of this path. And of course, this route now doesn't exist. So why does it work fine if we use the navigate method? Because unlike the router link, the navigate method doesn't know on which route you're currently on, so to say. The router link always knows in which component it sits, in which component's template, and therefore it knows what the currently loaded route is. Now you could argue that here we also call this inside of the component TypeScript code, so it could determine where it is in, but it's just not how it works. So to tell this where we currently are in, we have to pass a second argument to the navigate method, which is a JavaScript object, and here we can configure this navigation action. Now, I will come back to this later because there are more things we can add, but one configuration is the relative to property here. Here we define relative to which route this link should be loaded, and by default this is always the root domain, which is why we didn't get an error for this server's path. Here we have to give a route though, so we don't pass a string here. Instead, the route is something we can inject here too. We can get the currently active route by injecting route, which is of type activated route, and make sure to import activated route from the @Angular router package too. Now, activated route, like the name implies, simply injects the currently active route. So for the component you loaded, this will be the route which loaded this component. And the route simply is kind of a complex JavaScript object which keeps a lot of meta information about the currently active route. Now we can set this as a value, so this route, this injected route, for the relative to property. And now with that extra piece of information, Angular knows what our currently active route is. And theoretically, you could also set this to some other route which you would have to get by some way. So here we're telling it, now our currently active route is this activated route. So relative to this route, you should navigate. And then it will simply resolve all the relative paths you might have here relative to this route. So if this change in place, if we now click this button again, now we broke the app, because now it again tries to find servers/servers, which doesn't exist. So great, we broke the app. But with that, you should understand how you can work with relative paths in the navigate method. You define relative to what this path should be loaded. The default is the root URL. That might be the behavior you're looking for. It might not be the behavior you're looking for. You can change it with this extra JavaScript object, second argument to the navigate method, where you have the relative to property you can set to the route you want to navigate relative to. For now, I will simply comment this out to disable this not working button and still keep the code in this example project. With the basics about routing set, let's enhance our application a bit by going back to the app module and adding some other routes to it. Let's say that besides our user's route here, we also want to be able to load a single user, so to load the user component, which simply, well, gives us that single user. For that, we might want to load a user dynamically, because if we have a look at our users component, we see we get 3 users with different IDs. So it would be nice if we could pass the ID of the user we want to load in that route path. One approach would be to set up a route with user 1 and then one with user 2, and it doesn't look very optimal because it's not very dynamic, and still, how would we know inside of this component which route was loaded? Okay, we could parse the path manually, but that's not really a great approach. Instead, we can add parameters to our routes, dynamic segments in our paths. We do this by adding a colon and then any name you like for example ID. You will later be able to retrieve the parameter inside of the loaded component by that name you specify here, so by ID in this case. And the colon simply tells Angular that this is a dynamic part of the path. Without colon, only routes which are user/ID, and with ID I literally mean the word ID, would lead to this component. With a colon, user/anything else would load this component, and anything else would be interpreted as the ID. Now with this in place, we are able to load a component, the user component, with this dynamic piece sent to it. So if we have a look to this user component or at this user component, here we simply say user with ID, and now we simply have a dummy text here loaded and user name with some dummy text here. Now, for now, we won't touch this. We won't use this parameter. We will do this in the next lecture. Let's now see if we successfully reach this. So if we save this to let it recompile and we go back, we are in users. Let's add /something here. And you see the single user component was loaded. The same if we add /1 here. So this thing, the segment after /users, is indeed interpreted as dynamic. Otherwise, we would get the error that users /1 is an unknown route. It isn't, because we set it up to be a known one, because again, we added this dynamic path segment here. Now, this is how we can dynamically load some route, how we can encode some data into our path. How can we get access to this data in the loaded component though? Because that, of course, is another key question. Let's take a closer look in the next lecture. In the last lecture, we created our route with a dynamic path segment. Now we want to get access to the data the user sent us, or which is encoded in the URL, I should say. So we know that we will load the user component, this one here, and we know that there will be some data in the URL for us. How can we get access to it? Well, it is in the TypeScript file where we can get access, and there we need to inject something we already injected before, the active route. So this is again on activated route, so make sure to use this type and import it from @AngularRouter. And by injecting this, we get access to the currently loaded route. Now, I told you that this currently loaded route is a JavaScript object with a lot of metadata about this currently loaded route. One of these important pieces of information is the currently active user. Now you see that in this user component, I already defined a user object at the top, which is undefined for now. It should have the following structure, and it's not used right now. But we could load our user by simply, well, getting access or retrieving this parameter from our URL. So it would be nice if, let's say, in ng-on init, when our component gets initialized, we get our user. So we maybe want to say this user equals, and now we assign it to a JavaScript object because that is the type of it, a JavaScript object with an ID and with a name. Now the value for the ID can be fetched from our route, and there we have a snapshot property, and on this snapshot of our currently active route, we have a params JavaScript object, and here we can get our ID. And now you will only have access to properties here, well, which you defined in your route parameters. So this part here, we named it ID here, so we can retrieve the ID from this params object here. Now, the name is something which is not encoded in the route right now. So maybe we should do this too. Let's go to app module, and let's simply add another dynamic part here, :name. Now we also will get this as a parameter, so we can retrieve it the same way we retrieve the ID. Let's retrieve the name. And it's in the same params object because this is all part of the route which was loaded due to this path we set up in app module being triggered, which holds two dynamic pieces. And you can add as many parameters here as you want. They will all be retrievable on this params object of the loaded route. With that, we assign something to our user. Now we could go to our HTML document and output that data. So with string interpolation, here we could output user ID. It will now be set, we know that. And username maybe. Both will be available because we set it in ng-on init. Now this should work, so if we save this and we target /users1 max maybe, so that we have both the ID and the name, and we hit enter, we correctly see ID 1, name max. If we change the ID to 3, we see ID 3 here. So this seems to work, and you even see that this is still marked as active because this currently active path still contains /users, which was the route for this link. So this router link active directive is still doing its job. Now this seems to be working fine. Now let me add something to it which will break it though. I'll do this in the next lecture. In the last lecture we saw how we can retrieve our route parameters, and it was working fine, but there are ways to break this. there are cases where this approach will not work, and I will show you a typical example. On our users component, we right now always saw that we have the user ID and name we passed on our URL. Now in here, let me quickly add a router link. So I'll add a horizontal line and then add an anchor tag where I remove the ref and instead say router link. And now I will actually use this syntax with the squared brackets where I pass an array. And I want to load /users, an absolute path to load the correct route. The second element will be the ID. So this might be, let's say 10, could be a number, could be a string. And then the name, let's say Anna. So this will now construct a route which is /users/10/Anna. And this is where this array approach might be better because you can really structure this really well. And we will soon see how you can even make this more dynamic. So here I will say load Anna, ID 10, something like that, any text you like. And now let's see this here. We got this link on our currently loaded page with users 3 max. And if I click this, you see that the URL was updated. Now it's users 10 Anna, but the text here wasn't. And this is not a bug. This is the default behavior. And what is happening here? Do you have an idea? The behavior here, as I just mentioned, is not a bug. We load our data by using this snapshot object on the route. Now, if we load a new route, what happens? Angular has a look at our app module, finds the fitting route here, hopefully, loads the component, initializes the component, and gives us the data by accessing the snapshot here. Now, that only happens if we haven't been on this component before. But if we click this link, which is on the user component, well, then the URL still changes, but we already are on the component which should get loaded. So Angular, cleverly, doesn't reinstantiate this component. That would only cost us performance. Why would it re-render a component we already are on? Now you might say, because the data we want to load changed. But Angular doesn't know. And it's good that by default, it won't recreate the whole component and destroy the old one if we already are on that component. Still, of course, you want to get access to the updated data. And you can. It's fine to use the snapshot for the first initialization. But to be able to react to subsequent changes, we need a different approach. In our TypeScript code in ng-on-init here, let's say after we assigned this initial setup, we can use our route object, and instead of using the snapshot here, there is some params property on this route object itself. Now we didn't use that before, we had the snapshot in between. What's the difference? Params here is an observable. And now observables is something I will come to right after this section where we will take a closer look. Basically, observables are a feature added by some other third-party package, not by Angular, but heavily used by Angular, which allow you to easily work with asynchronous tasks. And this is an asynchronous task, because the parameters of your currently loaded route might change at some point in the future if the user clicks this link, but you don't know when, you don't know if, and you don't know how long it will take. So therefore, you can't block your code and wait for this to happen here, because it might never happen. So an observable is an easy way to subscribe to some event which might happen in the future, to then execute some code when it happens without having to wait for it now. And that is what params is. It is such an observable, and as the name implies, we can observe it, and we do so by subscribing to it. So you can call the subscribe method on it, and this is still called on params. I'm just bringing it in a new line to make it easier to read. And now subscribe can take 3 functions you pass here as arguments. Now, the first one is the most important one here. It will be fired whenever new data is sent through that observable. So to put it in easier words, whenever the parameters change in this use case. So then this first argument, which should be a function here, is executed. I will use a ES6 arrow function. And here we will get the updated params as an argument. And you can set this of type params. Doesn't really make a difference. It has to be imported from @AngularRouter then though. But anyways, params will always be an object, just like here on the snapshot, which holds the parameters you defined in the route as properties. So in the function body of this arrow function, so of this function which gets executed whenever the parameter changes, here we can now update our user object. And we can say this user ID should now be params ID, referring to the params we passed here. And the same, of course, for the name. Oops, with a semicolon at the end, of course. So this will now update our user object whenever the parameter change. That's why it's inside of this callback and of this anonymous function passed to the subscribe method here. This code will not be executed when ng-on-init runs through. This code here will. So the subscription will be set up, but only if the parameters then change. Only in this case, we will exchange them in our user object. That is why with this change in place, if we now go back to free and max, we see free and max is displayed here. But if I now click this link, it correctly updates here too, because our observable fires, and we then retrieve the updated parameters and assign them to our user object. And this therefore actually is the approach you should take to be really safe against changes not being reflected in your template. Now, if you know that the component you're on may never be reloaded from within that component, as we're doing it here, then you might not need this addition. You might simply use the snapshot, because if you know your component will 100% of the time be recreated when it is reached, because there's no other way of reaching it, there is no way of reaching it whilst being on that component. If you know that, you don't need to subscribe. In all other cases, make sure to use this approach to get informed about any changes in your route parameters. In the last lecture, we learned how we can subscribe to our params to update them or to react to any changes to them and update our page if we already are on that page. Now we set up this subscription using observables, and this works fine, and you don't have to change anything here. I want to bring something to your attention though. The fact that you don't have to add anything else to this component here simply is because Angular does something for you in the background which is super important. It cleans up the subscription you set up here whenever this component is destroyed. Because if it wouldn't do this, what are you doing here? You're subscribing to parameter changes, and let's say you then leave this component, and later you come back. Well, once you left, this component will be destroyed, and when you come back, a new one will be created. But this subscription here will always live on in memory because it's not closely tied to your component. So if the component is destroyed, the subscription won't. Now, it will be here because Angular handles this destroying of the subscription for you, but theoretically, you might want to implement the onDestroy lifecycle hook, importing it from @AngularCore. Therefore, you have to implement ng-onDestroy. And then you could store this subscription here in some property. Let's name it params subscription, which will be of type subscription. And subscription needs to be imported from RxJS subscription. RxJS is the package offering all this observables functionality. As I mentioned, it's not shipping with Angular, but Angular is using this package. So this type here, this subscription, this param subscription property is now bound to this subscription we're setting up here when calling subscribe. This returns us this subscription. And once the component gets destroyed, we could now access the subscription and unsubscribe. And again, because it's important, you don't have to do this. You can leave it as it was before, because Angular will do this for you regarding these route observables. But if you add your own observables, and I will come back to this in the observables section following this section, you have to unsubscribe on your own. And I just wanted to bring it to your attention because it's always super important to understand what's happening behind the scenes. Again, it's not necessary here, but it doesn't hurt to also do it manually too here. It won't add anything bad to your app. by doing it like this. In the last lecture, we learned how we can retrieve our route params. That's awesome, and this is super important, something you will probably use a lot. Now, there are more things you can add to your URL though. You might have query parameters. These are the parameters separated by a question mark, like mode equals editing, anything. And you can have multiple ones separated with @signs. The question now is how can you pass them using Angular links, router links, and how can you then retrieve them? You might also have a hash fragment, so separated with the hash sign to jump to a specific place in your app, loading, for example. Or maybe you don't really want to use this to jump there. You would have to add this scroll down there behavior on your own. Maybe you just want to retrieve it to use it as some extra information. Let's take a closer look at how we can pass this extra information on our links, both when using the router link directive and the navigate method in code, and how we can then retrieve that information. Let's start by passing it first. Let's say in our app module, we want to add more routes. For our servers here, we also want to add one other route, and that would be the route which allows us to edit a certain server. So we might load a server with some ID and then have /added at the end to describe in the URL what will happen in this component. And here it would be the added server component we want to load. So we added this new route, which should load this component in this added server file. Now, to be able to load this route on my servers component here, I want to hook up these links here in this list. We still have to do the same for the users component later. So here, I will add my router link and I will use the squared bracket syntax again so that I can pass an array here because I want to go to /servers. Then let's say server with ID 5. We will soon learn how to make this more dynamic. And then also add it. So this is this newly created route I want to call in this case. If we save this and we go to servers and click on this, you see we loaded service 5 added, and the same for every link, of course. Again, I will change this soon. Now let's say we also want to have some query parameter deciding on whether we are allowed to edit the server or not. So we want to add this question mark, and we don't do it by adding question mark equals something here as another element in this array. Instead, when using a link in a template, we add a new property of this router link directive. We can bind to the query params property. Now, query params, and that's important, is not a new directive. It's just another bindable property of the router link directive. And here we have to pass a JavaScript object, and on query params, we can now define key value pairs of the parameters we want to edit. So for example, say allow edit here and set this to 1. Now let's see what happens if we now click this link. If we now click any link here, you see we have question mark allow edit 1 here. So that's this key value pair we set up in this object. And of course you could have more key value pairs here, which would then be separated with the and sign in between in your link. So that's the query params property. We also have the fragment property, and that is only fragment because you may only have one fragment. Here you could simply pass a string with single quotation marks, or therefore omit the squared brackets and set this to, let's say, loading. So if we now save this, we go back to the servers page, now you see we have hash loading at the end. This is how you can add a fragment. So super easy to add in our router link here in our template. Let's now see how we can do the same programmatically. So in our home component where we already have this load servers button, let's say we want to load server 1. So here I will change this name to load server and pass 1 as an argument maybe. Adjust this method here, load server, and the ID will be passed as an argument as we just saw. And here I therefore want to navigate to servers, pass the ID. We're already seeing how this gets more dynamic. Now we're not hard coding 5 or something like this. We're using this argument here instead. And then as a last argument, edit. Now again, we still want to add query params and this fragment. So here in the navigate method, we use this object we already saw, where we already added relative to. Now I don't need relative to here. Instead here, I can also set up my query params. And that again is then just a JavaScript object where we say allow added and set this to 1 maybe. And just as I added query params, I can also add the fragment here and set this to loading. Now with this, if we save this and we go back to our home page and click load server, you see we add the query parameter, allow added and set it equal to 1, and the hash fragment here. So that is how we can use query parameters and fragments on both the programmatical routing approach, calling it from the TypeScript code, or on the router link like here. Now let's also learn how we can retrieve the data thereafter. In the last lecture, we learned how we can pass query parameters and fragments. Now let's make sure we can also retrieve them. So we're loading this added server component in the end. So that is probably where we want to retrieve that information. We can easily do this by going there, added server component, and you see there already is a lot of code in there. Well, everything what's happening here, however, is it's using our service to get the server with the ID 1 and to be able to update it. And definitely dive into this service file if you want to learn more about what's happening here. It's super simple though. We simply are able to get this array of servers, get a single server, or update a single server, so overwrite it. So that's not the interesting part. The interesting part in the added server component here is how we can get access to our query parameter and the fragment. We need our activated route for this. So let's inject it just like we did before. Activated route needs to be imported from the @Angular router package. So make sure to add this import at the top. And with this added, and let's say ng on init, we can retrieve our query parameters and the fragment. And just like before, there are two ways of retrieving it. For the first approach, we can simply access the snapshot of our route and access query params here or our fragment. Just like that. Now this might bring the same problem as with the params. This is only run or updated at the time this component is created. So if there is a chance of changing your query params from the page you're currently on, you might not want to use this approach because it won't be reactive, it won't display or allow you to react to any changes which happen after this component has been loaded. So for now, let's use the snapshot though. And let's watch the console once this reloads. Notice we already have a query parameter and a fragment. And we see both here. This is our query parameter object, where we have this key value pair mapping again, allow added to 1. And this is just a bit broken, but here you see if I make my console a bit broader, you see the loading hash fragment. So this is how you can retrieve it. The alternative, of course, is to use the route, and just like we had params as observable, we also have query params as an observable we can subscribe to, like this. And of course, we also have fragment as an observable we can subscribe to. So just like before, this will now allow you to react to changed query parameters. Now that's something we will use later in this module. For now, nothing will happen here, but it is important to keep in mind, like for params, you do have the same for query params and fragment. You don't need to unsubscribe here. Angular will handle it for you, just like it did for params. But this is how you can now get access to these extra features and how you can make sure that you don't miss the data. So now that we learned a lot about navigating passing parameters, let's improve our app a little bit by going to the users component, where we have a list of links in the end to single users. And let's add the router link here, pass an array as an argument. And here we want to target /users, and we already created our route, right? We have /users, /id, and /name. So we can use that information here in the users component. The second element here in this array therefore should be the ID. And since we have a for loop where we loop through all our users, we can easily dynamically add the ID here by accessing user
ID. And the same for the name, the third element, the third segment in this path, the username, we can access username. This is how we can dynamically construct such a link. And you already saw this with the navigate method a couple of lectures earlier. So this is our router link here. Let's do the same for the servers. So here in the servers component, let's also replace the 5 here with server ID. We do have a server ID if we have a look at the service. At the server's service, you see we have IDs and names here. So we want to pass the ID, and we can now do this by dynamically fetching it here. And I will remove added though, because I not only want to load the added component here, I want to load this single server component instead. With my link added here, we need to add the fitting route. So in our app module here, we need to add another route where we have servers and then just ID to load a single server with the server component here. Right now we're always loading the added server component, so make sure to add this extra route. And of course, this will be loaded because we removed the added at the end. So we're not editing this anymore. This just loads the single component. And of course now, in this single server component, this one here, where we want to output our server data, we need to get that data we pass in the route path in the URL. We pass the ID there. We do have a server's service where we are able to get a server by ID, and we already do this in our server component here in AngularJS. Right now, always for the server with the ID 1. So now use your chance to update this code to do this with the ID being passed with our route. You learned everything you need for this. Time for you to do it on your own. I will give you the chance to pause this video before we do this together. So, were you successful? Let's try it together. Of course, to get access to the route parameter, we need to inject our activated route. So we learned how to do this. Add this route property and make it of type activated route, which you need to import from @AngularRouter. And now in AngularJS, you can get your ID from this activated route from the snapshot, the params object here, and then the ID, which is encoded in the URL. And now you can use this ID here to get that server. Now, if you also want to react to any changes thereafter, you need to subscribe to your params observable here, and basically do the same. You get the params here, which is of type params. Make sure to import that from @AngularRouter. And once you get this, you can get a new server whenever your params should change. So here you could then access params ID like this to update the server whenever it changes triggered on this page. So with this in place, if we reload our app and go to servers, you see we get an error here, which makes sense because keep in mind on our servers component here, we still are always loading our single server component. And therefore we are also loading it if we don't have this ID available. So for now, I will comment this out. We will soon learn how we can nest another router in there to have some kind of child routing to load this route dynamically next to our menu here. So for now, I simply commented it out. If I now click on a server here, we still get an error. And now this can be a tricky one to spot. What's going wrong here? The issue is if we parse a parameter from our URL, it will always be a string because our whole URL is simply just text. So ID here will actually not be 1 in the case of /1. It will be a string of 1. So if we try to get a server by this ID, it will actually search a server which has an ID of 1 but a string 1. However, we use numbers here. So we simply have to make sure to convert our ID to a number, and we can do this by adding a plus in front of it. And this is perfectly fine to do with that you're making sure that the ID you're retrieving is treated as a number. Of course, you also need to make sure to do this here in your observable. So convert the params here to a number too. So with that, if we now click on servers and choose a server, you see production server here, test server in this case, and with that, this is now working as expected. We now improved our app because now we got working links here, we got working links here, and we're loading the correct server.
So with that, we added a lot, but we see that our app has some limitations. It would be nice if we don't load a new page with the user or the server here, but load it next to our menu in both cases. So we somehow need some nested routing, some child routes kind of, to have a router inside a router. Let's have a closer look at this in the next lectures. We improved our app quite a bit, but the issue we have is that if we click on a server or a user, we load a brand new page. It would be nicer if we would load it next to this menu, so we need some nested routing. We can also see that in the app module, we kind of have some duplication here. All these routes here start with servers and all these routes with users. So it would be nice to nest them and to have some child routes which all start with servers then here, in this case for example. Let's add such child routes. To do this, I'll go to my servers component route, to the /servers route, and I'll add another property, children. Children takes another array of routes, so now I can simply take my two other servers routes here and add them inside of this array as children. Now, servers should now be removed, because that is not always prepended at the beginning anyways, so we have to make sure to get rid of it here. And now we have just ID and ID added. So this is now already better, because now we group that together. It gives us more than this visual grouping here though. You notice that on the servers here, we have the servers component as the, component to be loaded still. The question now is, where will the server component be loaded then? Because that is yet another child route of our servers component. And you can see that this is an issue. If we reload our app here, everything's working. If I click on test server, now we get an error. Because now the error tells us that it cannot find an outlet to load our server component in. And indeed it can't, because the only router outlet, the only hook in our code where it should load components, is in our app component here. Now that is reserved for all our routes on the top level. So /nothing, /users, users ID name, and servers. But the child routes of servers need a separate outlet because they can't override the servers component. Instead, they should be loaded nested into this servers component. And that actually is the behavior we want. So we can quickly get there by going to the servers component HTML file, and here where we load the edit page or the app server page, here I will simply comment out all that code and instead add a router outlet here. This now adds a new hook which will be used on all child routes of the route being loaded on the servers component, which of course is our /servers route here. So all these child routes will be loaded in this router outlet place now. So if we save this and now we let this reload, you don't see anything here, but if I click a server, it's now loaded next to the menu because this is where we added our second router outlet. And this is how you can easily add child routes. Let's do the same for the user routes now. In the app module, I'll add children here, so this property which takes an array of routes. And I only have one nested route here, but that's fine, so I will add it here. Get rid of the users at the beginning, just have then the ID and name, the two dynamic parameters, and load the user component. And now in my users component HTML file, I'll replace my app user here with another router outlet, where all the user-related child routes, or the one user-related child route we have, will be loaded. So if we save this, you now see we load the user next to it. And that is why it is super important to dynamically update the ID and so on, because the component wasn't exchanged. We were able to switch the loaded user while this old component, the user component, the single user component, was already loaded. And this is how you can implement child routing, nested routes, with this children property, which then holds all the nested routes. In the last lecture, we added child routing let's now improve this app a little bit more. In our servers component, we have our links loading the individual servers, so the single server component, this component here, with this allow edit query parameter. So now in the server component, we should add some button where we say edit server, because right now we got no way of reaching the edit server component besides manually typing this route here, this path here, into our URL. So let's add a button to the server component. I'll add some CSS classes to make this look nice. And of course, I'll add a click listener where I say on edit. Now again, this is on a single server component. So here I'll add the on edit method. And in here, I now want to navigate to the edit server component. We learned how to do this. We need to get access to the router so that we are able to call the navigate method. So let's inject it. Make sure to also add the import from @AngularRouter. And with that injected in onEdit, we can navigate. You learned how to do this, so maybe a time to pause the video and try it on your own. This is how I would do it. I would call my router. Then of course we have the navigate method, and here we need to pass an array. And we simply want to append edit to the end of the currently loaded route. So you could of course also use /servers, the relative path, then use the ID of the currently loaded server again, server ID, and then append edit. But since we already are on this path, why not just use a relative route and just use edit? Now you learned if you want to use a relative route, a relative path here, when using the navigate method, you need to set up the relative to property here on the second argument, on this object you can pass to navigate, and reference the currently loaded route so that the Angular router knows to which route you want to navigate relatively. So with this, we should load the /edit route. We should append it to the end of our currently loaded route. Let's see if this works. If we go to servers, click on a server and click on edit, we load the edit server page. And now here we want to control on whether the user is allowed to update, to edit the server or not. The issue is, you see, we theoretically have our query params here, allow edit, always set to 1 in this case. But we lose this information as soon as we click edit server. So that is something we need to fix before we can use the information there. We will fix it in the next lecture. Before doing so, let's implement the rest of the logic though. Let's say here on the servers component, where we set the allow edit query parameter, we don't always want to set this to 1, to true therefore. We want to decide on whether we want to allow the editing depending on the server ID, let's say. So only if the server ID equals 3, let's say, only in this case we want to allow edit. So we want to set it to 1, otherwise we will set it to 0. So that's just a ternary expression checking the server ID, and if it's not equal to 3, we will set it to 0. So we will set the allow edit parameter to 0. That's the first step. Now in edit server, of course, we want to be able to retrieve our query params. So here we already get the subscribe method on the query params. Now here I want to determine on whether we are allowed to edit or not. So I will add a new allow edit property here and set it to false initially. But whenever this changes here in the query parameters, I want to get my query params, which are also of type params, to be imported from @AngularRouter. And then here in the method body, I will set this allow edit equal to my query params here, equal to the allow edit ID or property we set there. And now this either is 1, string of 1, of course you could also pass true as a string here, in which case I want to set allow edit to true. If it is not 1, I will set it to false though. And in the template of this component, we could simply add a heading, let's say, where we say you're not allowed to edit if, and we can use ngIf for this, if allow edit is false, so if not allow edit, and we wrap all the rest in a new div, so all this part here, only if it is true. And now all of a sudden we would control this, but again, the issue is if we click on edit server, our query params disappear. So it is always in the you're not allowed to edit mode. Let's fix it in the next lecture. Let's see how we can actually preserve our query params once we navigate again. So in the last lecture, we tried to improve our application a bit more, but the issue is our query parameters are gone whenever we navigate away from our single server component to the edit server component, for example. So we want to preserve them because we already set this information at the point of time we visit a single server. Now we want to preserve this information once we navigate one step further to the edit server component. To preserve that information, we got a simple way of doing so. In the server component where we navigate, we can pass another property or add another property to this JavaScript object we use to configure our navigation. And here we get the query params handling property. Now query params handling takes a string as a value, and this could be merge to merge our old query params with any new we might add here. Now we don't add any new ones, so we can simply choose preserve instead. And preserve, which will override the default behavior, which is to simply drop them, and make sure that the old ones are kept. Now if we were to add new ones here, the old ones would actually override the new ones, so we should use merge in this case. But since we don't add new ones, preserve should make sure that we don't lose them. So now if we click on this again and click edit server, now you see allow edit equal to 0 is still set. And therefore on the dev server, where it is set to 1 if we click edit server, we do see the edit menu again. So query params handling here, super important, super useful to know to make sure you don't lose the information you had before. Whoa, you already learned a lot about routing. We're nearing the end. But did you ever wonder what happens if we enter something here which we don't cover? Like let's say it's just /something. We get an error because clearly we don't have a route with /something here. So that is something we probably want to improve. We want to do some 404 error handling. We maybe want to redirect the user to a specific page whenever he tries to visit a page we don't have. These are the topics I'll focus on next. Setting up a route which handles all routes we don't have set up, and redirecting requests. Not necessarily two topics you use together, but also not that uncommon. So let's start with redirecting. Let's say we add a new component to our application, and I will use the CLI for this with the gc for generate component command, and I'll name it page not found. The page not found component, which was added here in our app folder, in this new page not found folder. I'll get rid of the spec file. And here I will simply say in the template, this page was not found. Something like this. Now I want to render this page in, let's say, the case that we visit a certain route. I'll add it here at the bottom, where the path is, for now, something. And in this something case here, I want to load my page not found component. Of course, make sure that you added it to declarations and so on, because we're still using it in our app, of course. So with this in place, if we now save this, go back to our application and visit /something, we of course see this page was not found. Now let's change something to not found, and let's make sure that once we add another new route, which then is something, let's say, we don't also have to add component here, but we redirect to another route, to the not found route maybe. For this, we got another property we can add to any route config here, so of course also to any of the other routes. If you don't want to specify a component to load, you can say redirect to. Now this is an alternative to component. Component loads the specific component, redirect to redirects to another path. So here you can specify any path, and the path maybe now is /not-found. So now if you do this, you see that it automatically redirected. So let me show you this again by typing /something, watch the URL, it redirects to /not-found. And all the other routes, of course, still work. So this is how we can use redirection. Now, of course, it's not very convenient to define /something here because you probably can't define all possible wrong URLs the user can enter. So a more convenient way to catch all routes which are not covered by your app is to use the double asterisk route here. This is the wildcard route, which means catch all paths you don't know. And the order is super important here. Make sure that this very generic route is the last one in your array of routes, because your routes get parsed from top to bottom here. So if this was actually at the beginning, you would always get redirected. As I can quickly show you by saving this like this, now no matter where you click, you always are redirected to not found. So make sure this is the last route here in your setup. And with this, now all the other routes work, but if you enter anything invalid here, you always get redirected to not found, because now you're using this wildcard route, catching all routes which are unknown to Angular at this point of time once it reaches this line here, and which then redirects to the not found route, which displays the page not found page or component. This is how you can redirect and make sure you catch routes you're not covering right now. Whew, so a lot was covered. Let's dive even deeper. If we have a look at our application, our app module, you already see that the routing takes up some significant space in our app module. So typically, if you have more than, let's say, 2 or 3 routes, you don't add it directly in the app module. Instead, you add a new file, which is for the application as a whole, typically is called app routing module. So the apps-routing.module.ts file now will hold a second module. And I will have a whole module course section about Angular modules later in the course. There we will dive much deeper and learn how you can define and use multiple modules, use them together. This is a super easy use case here, so let's add it now. Here I will give this a name of app routing module, because that is what it is, and it receives this @ng module decorator. So this is configured with a JavaScript object being passed to it, and this will be a super simple module. Now, as mentioned, I will dive deeper into this later. You can basically build your Angular app from multiple modules. This simple module here will handle all our routing related tasks. So I will cut all my routes, this app routes constant, and add it in there. Of course, now I need to make sure that all these imports here are added. So make sure to add all the imports to all these components, and also, of course, here to routes from the @Angular router package. And you don't need to add declarations here, because these components already are declared in your app module, and we will soon add the app routing module to this root module. So no need to redeclare them. This would actually even give you an error. We also have to remove the router module from here, from our root module. Therefore, we can remove the imports from the router package. Make sure to import router module in your app routing module now. So to add this import here. And now we need to configure something in ng module. We basically want to add imports again. We had this in the app module too. And in imports, we want to use this router module, use for root as before, and pass our routes array to it. So just like we did before. But that alone is not enough now, because as I mentioned, we simply want to use this app routing module to outsource our routes. Therefore, we need to add our app routing module back to our main module. And for this, we need to add the exports array here. And I just can mention it again. We will dive deeper into modules later in the course. Exports simply tells Angular, hey, from this module, if I were to add this module to the imports of another module, what should be accessible to this module which imports this module? And the one thing we want to make accessible is our router module. Now here you don't call for root because you did this here. So in the first step you configured this router module, added your own routes to it. Now we simply export this configured router module. And therefore in app module, we can now import our own app routing module. So here on the imports array, we can simply add app routing module. Make sure to add the import path here. And with that, we have the same setup as before, but with a bit of a leaner app module and our routing functionality outsourced in this separate module, which is kind of a good practice to do to keep your files organized and easy to read. So, same behavior as before. If we save this with ngserve still running, we should therefore see that everything still works, and this looks good to me. But again, important to understand, now with a different setup, a bit more readable and a good practice to implement if your application grows more complex. Throughout this section, you learned a lot about routing. You know how to set up routes, to load them both through route link or programmatically, how to pass params, query params, how to use the data, how to load different components, and much more. One important feature is left in this module, which I definitely want to cover: route guards. So basically, functionality, logic, code, which is executed before a route is loaded or once you want to leave a route. Let's start with a simple use case. Let's say you only want to give access to your server component, your single server component, or the added server component if a user is logged in. Now we're not going to add a full login functionality. For this we will later have the authentication section in this course, but we will fake it for now. Still, we want to check this before any of our sub-routes here, so servers 3, servers 1, and then also the added routes are accessed. Now, manually checking this in the onInit function of our server and added server component would be very cumbersome, because you would have to add it in both components, and if you add more components belonging to the server's feature, you would have to add this over and over again. So therefore, we want to use a feature built into the Angular router running some code before a component is loaded. We will use the can activate guard, and we will do so in the next lecture. As mentioned in the last lecture, we want to maybe protect some of our routes. And we can use a feature offered by Angular which allows us to run some code at a point of time defined by us. I will add a new file in our root folder and I will name it auth-guard.service.ts because the code we run there is stored in such a service. I'll name it auth-guard though because the feature of the Angular router is called guards. It guards certain actions like navigating to, around, or away from it. But in the end, it is a normal service, and therefore, as such, I will export a class which I'll name auth-guard. Now, you could add service here to be fully in line with all the other services, but since we will only use this as a guard, I will leave it at the auth-guard name. And now here, I will implement the can activate interface. This interface is provided by the Angular router package, so you need to import it, and it forces you to have a can activate method in this class. The can activate method now will receive two arguments: the activated route snapshot and the state of the router, so the router state snapshot. So make sure to also add these imports at the top here from @AngularRouter and to add them here as types for the two parameters we get in canActivate. Now you might ask, where are we getting these arguments from? Keep in mind, we will soon define that Angular should execute this code before a route is loaded, so it will give us this data, and we simply need to be able to handle the data. So that is canActivate with the arguments it requires. canActivate also returns something. It either returns an observable, so make sure to import observable from RxJS. Observable is the correct path in this case. This observable then will wrap a boolean, so it will in the end resolve to a true or false value. Alternatively, this route returns a promise, also returning the boolean in the end, or it returns just a boolean. So canActivate can run both asynchronously, returning an observable or a promise, or synchronously, because you might have some guards which execute some code which runs completely on the client, therefore it runs synchronously, or you might have some code which takes a couple of seconds to finish because you use a timeout in there, or you reach out to a server, so it runs asynchronously. And both is possible with canActivate. You will see an example in a second. So here we want to be able to log in or out. For this, let's say we have another service, the auth service. And this is just a fake service here. So I will name it auth service. And in a real application, this might reach out to a server and allow us to log in or log out and check our current authentication state. I will track the state here too with the logged in property, which is set to false initially. And then I'll add a login method, which will set logged in to true, just like this, and a logout method, which will set logged in to false, to again fake this behavior. And I will have a method which allows us to check the state, authenticated. And here I want to simulate that this takes some time to finish, because maybe we reach out to a server. Therefore here, I will return a promise, a new promise therefore. This promise will, as always, take a method, a function as an argument with the resolve and reject methods we can execute. And in this promise, here I will execute set timeout to wait, let's say, 800 milliseconds, and then execute another method in which I will resolve the promise and return this logged in. Again, just to fake that this takes a couple of seconds to finish, or some time to finish. So, with this auth service added, I now want to use it in my auth guard. And as this is also just a service, we need to add injectable to be able to reach out to the other service to inject that service into this guard. So make sure to import add injectable from Angular core. And then I will add a constructor to my auth guard where I reach out to my fake auth service here, of type auth service, therefore make sure to add this import too. And now in the canActivate guard, I simply want to check whether the user is logged in or not. So here, I can reach out to my auth service to the isAuthenticated method, which again, keep in mind, returns a promise. Well, therefore we should return this promise here, I guess. So it returns us this promise. And here, I then want to be able to handle that whenever this promise in the auth service resolves. I know that there I will get back a boolean, so this authentication state, this logged in boolean is what we resolve here in the end, and this could be false or true. So I know that I will get back a boolean, and here I then want to check if this is true, in which case I want to return true, and otherwise I want to navigate away, because I don't want to allow the user access to the route he wanted to go to originally. I will navigate away to force the user to go somewhere else. So I will inject the Angular router for this, because this is how we can navigate with the navigate method. Make sure to add the import from @AngularRouter. And then here we can navigate with the navigate method. Let's say we just want to go back to our root page with just /. So in this case, our canActivate method will navigate away. And I will now simply return this promise it still is in the end, because if we return something inside of the promise, it will give us back another promise. So now we're returning a promise here, which gives us back true, or simply navigates us away, canceling the old navigation anyways, therefore. So this now allows us to control access to whatever is controlled by this can activate guard here. Now we're still not using this guard, of course. So to use it, I'll go to my app routing module, and now we want to define which route or routes should be protected by this guard. And we do so by going to that route, it's the server's route and all its child routes, and adding can activate this property to it. Now can activate takes an array of all the code, basically all the guards you want to apply to this route, and it will automatically get applied to all the child routes. So here can activate will use my off guard. Make sure to add the import here pointing to your file, and this will make sure that servers is now only accessible, and all the child routes only accessible if the off guard can activate method returns true in the end, which will only happen if in the off service logged in is set to true. Since this is set to false, and right now we never call login, this should always deny us access. Now before trying this, we need to go to our app module and add to the two new services we added. So add the off service and the off guard, which also is a service. Otherwise, Angular won't be able to inject them for us. So with that set up, let's go to our application, click on servers, and I can click there as often as I want. I can't reach it. Users works, but servers always navigates us back to home after these 800 milliseconds, because that is how long it takes to resolve the information whether we are authenticated or not. We defined these 800 seconds here. So our guard is working, however, on our whole servers tab. Now I want to be able to see the list of servers and only protect the child routes. How can we do this? In the last lecture, we added the can activate guard, and it was working fine, but it was working for our whole servers path here. Now we could grab it from here and add it to our childs to make sure that only the childs are protected, the children, and not our root path. But that is not the easiest way, because if we add more child items, we have to add can activate to each of them. There is another guard we can use. It's pretty similar to can activate. It's called can activate child. So let's implement this interface too. You need to import it from @AngularRouter. And this interface requires you to provide a can activate child method in this class, which basically takes the same form as the can activate method. So it has the route and state, and it returns an observable promise or boolean. So this is the form of can activate child. Well, and since this is exactly the same form and we want to run the same logic, we can simply call, or return this can activate. So the other method we already included, and here we simply pass our route and state as arguments, since can activate expects these two arguments. What is the advantage of adding this then? Well, since we added the can activate child interface, we can now use a different hook here in our routes. Instead of only using can activate, we can use a different one, and I will split this over multiple lines to make it really clear on what's happening. I will comment out can activate and instead add can activate child. This now also takes an array of services which act as guards, which implement the right interfaces. And here we can still add the off guard, because the off guard now is able to do both. Protect a single route, since we have can activate implemented, or all child routes, since we have can activate child implemented too. So with this in place, we should now be able to go to servers. This works. But if we try to load a single server, now we get redirected back. because now only the child routes are protected, something I can also prove by trying to go to /1 edit. This also navigates us back. So now this is the fine-grained control you can implement to protect a whole route and all its child routes, or just the child routes, depending on which behavior you need in your app. Now let's finish this can activate behavior by allowing the user to log in. I'll quickly do this by going to my home component, and there I want to add two new buttons, one login button and one logout button. And I will add some CSS classes, button default maybe, and button default here too. And here I want to execute on logout, and for the other one, of course, I will execute on login. And I will keep this really simple since it's not about having a nice UI here. I will simply inject my auth service here, of type auth service, of course. Make sure to add the import at the top. And then I'll add my two methods here. So on login, we'll simply reach out to the auth service and call the login method to set this logged in boolean to true. And on logout, we'll of course do the same, but we'll call the logout method to set it to false. And this simple improvement now makes sure that we can of course log in. We don't see any visual indication here, but we do see it if we try to access a single server. Now this is working always after these 800 milliseconds, which it takes to evaluate whether we are allowed to access. But if I switch this back to log out again, you see we're redirected again. So now we can control this. Now we finish this fake auth service, and more importantly, the can activate guards. In the last lectures, you learned how to use can activate to control access to a route. Now I want to focus on the control of whether you are allowed to leave a route or not. We can control this too, and we might want to control this if we are logged in once we do edit a server. Now we, for example, are allowed to edit the dev server. And here, if we actually changed something, I want to ask the user if he accidentally clicks back or somewhere else, if you really want to leave, or if you maybe forgot to click update server first. So this convenience method of keeping the user from accidentally navigating away. How can we implement this? Let's go to the edit server component for this, here, and let's add a new property. Below allow edit, I'll add a changes saved property, which is false by default, and which I want to change whenever we click on update server. Here, of course, we did update the server, so I want to call changes saved and set this to true here, because now the changes were indeed saved. After the changes were saved here, I want to navigate away. So I will inject the router here, of type router, make sure to add the import at the top as always from the @AngularRouter package. And then here, after we saved our changes, I want to navigate away. I want to go up one level to the last loaded server. And for this, I will pass the relative to configuration and want to navigate relative to the currently active route. So far, so good. We're changing this changes saved property here. Now let's make sure that whenever the user tries to accidentally navigate away, that we prevent him from doing so, or at least ask if he really wants to leave. Now we somehow need to execute this code in this component here, because we will need access to this changes saved method, which informs us on whether this update button was clicked or not. However, a guard always needs to be a service, because we need to provide it just like we provided the auth guard. So somehow this doesn't fit. We need to access the code in our component and have a service, and that sounds like a complicated setup. But it isn't, it's actually really simple. In my added server folder here, I'll add a new file. I'll name it can deactivate guard. And this again will also be a service, as all guards are. And in here,
I first of all now want to export an interface. An interface simply is a contract which can be imported by some other class, let's say, which forces this class to provide some logic. So here I will name this can component deactivate, and this interface will require one thing from the component which implements it. This component should have a can deactivate method. This method, and this is simply how I define the type of this can deactivate method, since this is only an interface, it won't contain the actual logic, it will only contain the information how it should look like. So this method should take no arguments, but in the end it should return an observable, which therefore needs to be imported in this file here from rxjs observable, which will resolve to a boolean in the end, or a promise, which will resolve to a boolean in the end, or just a boolean. You might recognize this pattern here from the can activate guard. These guards share the same structure. So that is my interface. Nice to have it, but that alone won't do the trick. Now let's come to the important thing, the meat of this class, of the service here I should say, the service itself. So I'll name it can deactivate guard, and this guard will implement can deactivate. This is an interface provided by the Angular router, so we need to import it from there. This actually is a generic type and it will wrap our own interface. So it will wrap an interface which forces some component or some class to implement the can deactivate method. Might sound complicated, but this is the setup which will make sure that we later can easily connect a component to our can deactivate guard here. So for now, let's just go with that piece of information. And now this class here, this guard, will also need to have a can deactivate method. This is the can deactivate method which will be called by the Angular router once we try to leave a route. Therefore, this will have the component on which we're currently on as an argument, and this component needs to be of type can component deactivate, which means it needs to be a component which has this interface here implemented, therefore a component which has a can deactivate method. This will become super important in a second. We also will receive the current route as an argument, so that is an activated route snapshot. Need to make sure to import this too. It will have the current state, so that is a router state snapshot, import this too. And the next state, so where do you want to go? Because remember, this will be called at the end when we want to leave a route. So next state is an optional argument though. This will also be a router state snapshot. And this will now also return an observable, a promise, or a boolean. So just like the can activate guard. That is how the can deactivate method in our can deactivate guard looks like. And here I now want to call can deactivate on the component we're currently on. And this is why I need to implement this interface in this component, why I created this interface in the first place, because now the Angular router can execute can deactivate in our service and can rely on the fact that the component we're currently on has the can deactivate method too, because this is where we will actually implement the logic checking whether we are allowed to leave or not, because we need this connection between our guard and the component. So this is why we can safely call can deactivate here. And now with that information, we can go back to our app routing module. And on the edit page here, we want to add this guard. So we can add can deactivate as a property to this route config. It takes an array just like can activate. And here we now will point to our can deactivate guard. Make sure to add this import therefore. And now Angular will run this guard whenever we try to leave this path here, this component loaded at this path. For this to work, we of course need to go to our module and provide our can deactivate guard, just like before, can deactivate. With this provided, make sure to add the import. We're almost there, but one important piece is missing.
Remember that I told you that the can deactivate guard will in the end call can deactivate in our component? Well, for this to work on our added server component, here we need to implement our can component deactivate interface, our own interface we exported in our can deactivate guard service file, this interface. This interface now forces us to implement the can deactivate method in our component, which is important because we try to call this method on our component here. So in the added server component here, I will simply add a can deactivate method now. We know how this method should look like because we defined it here. It should return an observable, a promise, or a boolean. So let's make sure that it does. And now here, first of all, we need to import observable from rxjs/observable. But with that added, with this import added, here in can deactivate, we now provide the actual logic deciding on whether we are allowed to leave or not. This logic will be run whenever the can deactivate guard is checked by the Angular router. So here I will quickly check if we're first of all allowed to edit this, because if we're not allowed like this, here I will return true anyways, because hey, we weren't allowed to edit it in the first place, so sure, you may leave. And otherwise, I will check if my server name here is unlike the server name we had at the beginning. Server name here, this property, is simply bound via two-way binding to user inputs. So initially it is set to the value we get from outside, from the server which was loaded. We bind it here. But as soon as we type, we will have some differences. So if we have differences on the server name or on the server status, so here I also check if this is not the same as before, server status. So if one of the two was changed, and now I will wrap it in parentheses. So if one of the two was changed and the changes were not saved, so changes saved is false, in this case, I want to return a confirm dialog where I ask the user, do you want to discard the changes? Otherwise, I will return true because otherwise either nothing was changed or it was changed, but changes saved is set to true, so we did save it indeed. With this in place, let's go back to our servers and first of all log in maybe. Let's go to the dev server, which is the one we are allowed to edit. And here, if I now type something there and I didn't click update server and I click somewhere else, we are asked if we want to leave. And if I click cancel, we stay on this page. We may now save our changes and then we are navigated away without getting any issues at all. And the fact that we updated the wrong server simply happens because here we still are always loading the server with the ID 1. So we should update this to get our real ID. So maybe here, access our route, snapshot, params ID, and pass this as an ID. And thereafter, of course, also subscribe to route params to update the ID if params change. That is something you can do as an exercise. And of course, make this of type number by converting it. But more importantly here, everything's working as it should. We are only allowed to change this if we did click update, otherwise we are asked. Or of course, if here once we are asked, we click OK, we are allowed to discard our changes. So that is true, or that is possible too. But now with can deactivate, we have this extra protection in place. So with this, we learned a lot about routing in this module. Now there's one more guard I want to dive into, and we will do so in the next lecture. Thus far, we had a look at two route guards, at the can activate guard and its neighbor, the can activate child guard, and at the can deactivate guard. Later in this course, in the modules section where you learn more about the Angular module,
We will have a look at other routing related questions and also at guards again, but I'll come back to this. In this module here, there are still two other things I want to have a look at. And the first one is how to get some data, either static data or dynamic data, once a route is loaded. Now you might correctly say, hey, we learned how to get data, how to get a parameter out of the URL and then use that. But that's not what I mean. I mean that some of your routes depend on data they receive either statically each time they are loaded, or they will resolve dynamically. Maybe I show some examples to make this clearer. Let's start with static data. We got our page not found component here. Now let's say we don't want to use that, but instead I will create a new component, the error page component. So this will be a generic error page, where the page not found component is pretty much limited to, well, 404 not found errors. We could imagine that we reuse the error page for all kinds of errors. So I'll remove the spec.ts file. And here in the template now, I don't want to output page not found or anything like this. Instead here, let's say we have some error message, which I want to output via string interpolation. The issue, of course, is this property doesn't exist as of now. So let's add it here. Let's add error message to this component. And we know it should be a string, but still, what would be the message? Because again, we might reuse this page. Now, for routing, there only is one proper use case you want to target right now, and that is that a route is not found. So in our route setup here, our redirect route here, which redirects to not found, which loads the page not found component here in the end. Here, I will duplicate this and then comment it out so that I have the code stored. Here, I now want to use the brand new error page component. So this error page component, which was generated by the CLI and for which you should add an import here. Of course, you should have also added this to your main app module if the CLI didn't do this automatically for you here, and the import too. So with this, we're now loading this not found page, or excuse me, this error page if we target the not found route. Still, the issue is that here we try to output some message which we haven't gotten here. Now, we could reach this page through different hooks, or for different errors, but for each error, there is only one message. So in our app routing module, we know that if we have the not found route and therefore a not found error, we will always display the same error message. And we can pass such static data with the data property here. The data property allows us to pass an object here. And in this object, we can define any key value pairs, any properties we want. Like, for example, our message, which is page not found. Now, again, you might say, if I define it statically here and we will soon fetch it in the error page, why don't I define it there to begin with? Because we might reuse this error page. Maybe we got another route reaching this where we want to display a different error, or we have a different logic in our application which might render this page. So again, it might be reusable, but for each use case, there is a specific data field, a specific message we want to pass, like the page not found message here. So with this, we now want to retrieve that whenever we load our error page component. And for this, like params, like query params, we need the active route. So let's inject our activated route here, make sure to import it. And an ng on init, I can then again either assign it by using the snapshot of this route, and then simply the data object where I can now access message. And of course I have to make sure that this property exists, and we do make sure because we know we can only reach this component through this route where we will have this message property set. So this is the way of using it with its snapshot, or just like with params or query params, if this could possibly change while you still are on this page, you want to use your route and here the data observable to which you subscribe and which will give you this new data object here of type data, some dummy data type you can import from Angular router, which will in the end give you access to your data or the properties you defined there. So here you could then also set it equal to data
message both would work depending on whether it may change or not. So yeah, both should work. I will comment out the first use case here, but again, if it doesn't change, using the snapshot is absolutely correct or fine. So with this, we should now bind this, and therefore if we save this and go back to our application, enter some invalid route here, we correctly see page not found, the static error message we passed with the data property. And this is a typical use case whenever you have some static data you want to pass to a route. Now let's move on to some dynamic data in the next lecture. In the last lecture, we learned how to pass static data. Now let's say we have some dynamic data we have to fetch before a route can be displayed or can be rendered. For example, here on the servers. Let's say the servers already have been loaded. But once we click a server here, and maybe I should log in to demonstrate this, I want to load the individual server from some backend. So we are going to simulate that this takes a couple of milliseconds or seconds. So how could this work? If we have such a use case, we need a resolver. This also is a service just like can activate or can deactivate, which will allow us to run some code before a route is rendered. Now the difference to can activate is that the resolver will not decide whether this route should be rendered or not, whether the component should be loaded or not. The resolver will always render the component in the end, but it will do some preloading, you could say. It will fetch some data the component will then need later on. Of course, the alternative is to render the component or the target page instantly, and in the onInit method of this page, you could then fetch the data and display some spinner whilst you're doing so. So that is an alternative. But if you want to load it before actually displaying the route, this is how you would add such a resolver. So let's say for the single server here, I will add it in the server file, my server resolver. And again, this will be technically just be a service. So I'll export my class here, which I'll name server resolver. And now this has to implement the resolve interface provided by @AngularRouter. Resolve is a generic type and it should wrap whichever item or data field you will get here, will fetch here in the end. So we will fetch a server here, and therefore we should define the type here. Now you could outsource this into an interface or a model in general. So we will know that a server will have an ID which is of type number, that it will have a name which is a string, and a status which is a string. So this is simply a type definition of, well, the thing this resolver will give us in the end, to what it will resolve in the end. Now, the resolve interface requires us to implement the resolve method, and this resolve method here now takes two arguments, the route, so the activated route snapshot, which you already know, which you need to import from @AngularCore, and it will also provide us the state snapshot, so the router state snapshot, which also needs to be imported from @AngularRouter. These are the two information pieces the resolve method gets by Angular. And in the end, this then also has to return either an observable, which you need to import from RxJS observable. This observable will then also return this type here. So we can copy this, but since we're creating a lot of overhead here, we can also quickly define an interface here. And it would, of course, be better to outsource this in its own file, but let's quickly do it here. So the interface for the server, which has an ID of type number, and then the name, which is a string, and the status, which is a string. And now this allows us to simply use server here as a shortcut for this type. So the observable should, in the end, give us back such a server, or we get a promise, which in the end will return such a server, or, well, just such a server synchronously. So this is what we will get back here in resolve. So now we need to implement the logic to get this back. Now we have our server's service here, and there we have the get server method, which will give us back a server. Now this clearly is some synchronous code.
it will run instantly here. So there is nothing wrong with this code. We will resolve this instantly. And as you saw in your resolver, that's fine. One return possibility is to instantly return the data. So the easiest thing we can do here is reach out to our server service. And for this, we need to inject it. So we should provide our server service like this. That's a real hard word for me. Servers service like this. And of course, if you want to inject a service into another service, you have to add injectable to it. Make sure to import this from @AngularCore. Also make sure to import your own service. And with this, the easiest way to use this resolve function is to reach out to your service. And there we call getServer. And now we need to know the ID of the server we have to fetch. Because that is what we do in the server component here in the end, right? There in on init, we're getting this server right now. So now we want to outsource this because let's say we want to do it before it loads. The good thing is we do get the route here. It only is the snapshot, but this service here will actually run on each time we re-render the route. So the snapshot is all we need. Unlike the component itself, again, this is executed each time. So no need to set up an observable or something like that. So here we can access our route, and there are the params, and then the ID, and make sure to cast it with a plus sign in front of it to an integer. This is the easiest way of using this resolver, which will do the loading of our data in advance. And now this would also work if this were to return an observable or a promise, so with asynchronous code, for example, an HTTP request. So this is our resolver. With this resolver in place, we of course now have to add it. So first thing is, in app module, we should add it to our providers, our server resolver, like this. Make sure to also add the import at the top. And with that added now, we want to add it to our routing module. Here, for the route where we want to use it, so let's say for this component here, we add another property, the resolve property. This takes a JavaScript object, and here we map all the resolvers. This is different to the other guards. There we used arrays, but for resolve, a different approach is taken, and you will see why in a second. So here we have key value pairs of the resolvers we want to use. So for the server, and this name of the property is totally up to you, we will use our server resolver. Like this. Make sure to import it here at the top. This will now map the data this resolver gives us back. And remember, it gives us back some data with this resolve method it had to implement. This method will be called by Angular when this route is loaded. So the data it gives us back here will be stored in this server object we will then have available, or in the server property we will have available in this to be loaded component. So in this to be loaded component, in our server component, right now we get the server like this, using the params. Well, I will comment this out, because now we use a resolver for this. That's the goal of the resolver, and it makes even more sense if this is some asynchronous task, of course. So here, we can easily get our server by binding the data observable. So just like static data, which you passed with this data object here, with this data property you could add to a route, the data returned by your resolver will also go into this data baggage, in this data object you have in your to be loaded component. So here we can listen to any changes, and I'm setting up an observable here, or I'm using the observable here, I should say, because the server can change while we already are on the page, as we have this side menu. This is why we also had to set up our route params here dynamically. And here we know we will get back our data of type data as learned before. Make sure to import data from Angular router. And now we know that we can simply assign our server the server property in this component by binding to data server. And now this name here is important. This server here, this name here, of course, has to match the name you use here
when you assign your resolver to some property. So if you change the name here, you have to change it when you retrieve the data. Well, with this in place, if we save this with ngserve still running, if we log in and go to servers and we click on a server, you see this still works as intended. It still loads the server like before, but now not using the params here in the server component, but instead using a resolver before this. Again, of course, especially important when using asynchronous data. Almost done. We covered a lot in this module. This has been a very long section in this course, but it has been so important because routing is such a key task in any application. Now, if you have a look at our application, we got a couple of routes in there, /users, /servers, and much more. Now here's one important thing. It works fine here on our local setup, but actually this is not something you should take for granted. If you have a route like this, your domain /servers, and you're hosting this on a real server somewhere in the web, this might not work out of the box because their routes, the URL, is always, this is how the web works, is always parsed, handled by the server first, so by the server which hosts your application. Now here on the local environment, in our development environment, we're also using a development server, but this server has one special configuration your real life server also has to have. And I will come back to this in the deployment section. The server hosting your Angular single page application has to be configured such that in a case of a 404 error, it returns the index.html file, so the file starting and containing your Angular app. Why? Because as I mentioned, all your URLs are parsed by the server first. So not by Angular, by the server. Now if you have /servers here, it will look for a /servers route on your server, on the real server hosting your web app. Now chances are you don't have the route here because you only have one file there, index.html, containing your Angular app. And you want Angular to take over and to parse this route, but it will never get a chance if your server, the server hosting your app, decides, no, I don't know that route, here's your 404 error page. Therefore, you need to make sure that in such a case, your web server returns the index.html file. If for some reason you can't get this to work, or you need to support very old browsers which are not able to parse paths like this in the client, which Angular does then, you have an alternative approach to using these nice URLs which look like all URLs in the web. You can fall back to our older technique which was used a couple of years ago, using a hash sign in your routes. Let's see how we enable it, and then I will explain what it does. You can enable it in your app routing module, where you register your routes here with the forRoute method. You can pass a second argument, a JavaScript object, to this method, configuring the setup of your routes. So besides the routes itself, now we can configure them. And one important configuration is the use hash configuration, which you can set to true. The default is false, which is why we didn't have to pass it. If we do this and we save that, let's see what happens. You out of the box see that now we have this hashtag in our URL. And if I click on servers, you see there is this hashtag in between. And that's no bug, that belongs here because this is this hash mode routing. What this hashtag will do is it informs your web server, hey, only care about the part in this URL before this hashtag. So all the part thereafter will be ignored by your web server. Therefore, this will run even on servers which don't return the index.html file in case of 404 errors, because they will only care about the part in front of the hashtag. That's how it works by default. And the part after the hashtag can now be parsed by your client, by Angular. So this is the solution if you can't get the other approach to work. However, I will say that definitely you should try to use the more prettier routes using the HTML history mode, as it is called, with the normal / routes without the hashtag. So this is how you would enable it. I'm going to duplicate this, so to comment this out to have it there for reference, but I will fall back to the other mode, which gives us cleaner routes, which really look a lot nicer and more like you're used to seeing routes from other web apps. And this is the last piece of this section. Well, we really covered a lot in this section. We learned a lot about routing, setting up routes, setting up child routes, navigating there in code, passing parameters, passing query parameters, extracting parameters dynamically, using guards, using different types of guards, preventing the user from accidentally navigating away, resolving data, passing static data, styling the links which are active, and so much more. This is how you may use the Angular router. We're going to use it in our course project soon, but I can only encourage you to play around with it to really get a feeling for it. And I will also take a closer look at these observables we used in this section so that you feel more comfortable using them too. Let's move on. Welcome back to the recipe book. Now that we learned about routing in the last course section, it's time to add it to our recipe book course app. This is the structure of our app thus far, and we already got a lot of components and so on. Right now we implemented the navigation in our application with ngIf though, and that is not really the best way of navigating around. Instead, I want to use the Angular router to load pages and to allow the user to, well, switch between pages. In this section, however, we will not only add the router, we will also add one new component, the recipe edit component. Because now that we have a way of loading different pages, we can also add this. This is the component which we will fill with some life after the forms section in this course, which will then allow us to create new recipes or edit existing ones. So I want to set up routing in this section, and we definitely need routes to load either the shopping list or the recipe book. But inside of the recipe book section of the app, I want to have some child routes targeting the recipe detail or recipe edit component. These components, which will always be loaded on the left side of our list of recipes, should be loaded dynamically, and only one of the two should be loaded at a time, therefore child routing. So that is the general structure. Let's now put this into practice and build our application and add routing to it, starting in the next lecture. So here is the course project in the state we last left it. ng-serve is already running in a terminal, and now I want to add routing. Now let's start with the root routes, with the routes for our overall application, before we then dive into the child routes. You learned how to add such routes, and therefore, here's a challenge for you. Try implementing the main routes of our application, so to load the recipe page and the shopping list page on your own. So right now, I will give you a couple of seconds to pause the video and try this on your own, then we'll implement this together. So, were you successful? Here is my solution. For the root routes, I will add an app routing module, as shown in the routing section. So let's add it in the app folder, the app routing.module.ts file. Now in there, as you learned it, we're going to export a TypeScript class which is called app routing module. And this module has only one purpose. It will provide the routing to our application. It will bundle all the routing functionality, so to say. Now here we need to add ng-module to this class to transform it from a normal TypeScript class into an Angular module. And for this, we also need to import ng-module here at the top. Now, ng-module takes a JavaScript object in which we can configure it in greater detail. However, we won't need to configure that much for our routing module. Mainly, we will need to register our routes. So let's set them up first. I'll add a constant named app_routes, and this will be of type routes, just like that. Now, routes needs to be imported from @AngularRouter, and as you learned, routes simply is just an array of JavaScript objects where each object represents a route. So let's add the first route. Now, which routes do we need? As mentioned, a route which loads our recipe section and a route which loads our shopping list section.
So let's start with the recipes. I'll set up a path which will be displayed in the URL and which will allow us to go to that route. And let's say recipes sounds like a good path for this, so that you can visit your domain and then /recipes to reach this route. Now, when we visit recipes, I want to load the recipes component. So I'll assign that component here, the recipes component. And of course, we need to add the import of that component. So make sure to add this at the top, pointing to the recipes folder and then the recipes.component file. That's our first route added. Of course, one route is not everything we need here. We also need a second route. So I'll quickly duplicate this. And here I now want to target shopping list. So let's set up this route too. And here, of course, the goal is not to target the recipes component, but instead we want to target the shopping list component, our second main route. And as the recipes component, we need to import this and add the import statement at the top. With that, we got two routes to load. And we also got a problem. When we first visit the page, we will navigate to neither of the two. We will just visit the path with, well, basically an empty path, so just our domain /nothing. Therefore, we should add another path here, another route. Here I want to target an empty path, so basically the path we will reach when we load the app for the first time. And here we could now either also load the recipes component, but that's not really what I want to do. Instead here, I want to redirect to /recipes. So I will redirect to and now /recipes. Now let's try implementing it like this. In my ng module here, I now will import the router module. Like that. You have to import it from @AngularRouter. On the router module, we can call for root. And here we should pass our app routes to configure this router module Angular ships with. With that, our routes are now configured and added to the Angular router. Now, since we are in an extra module here and we want to get this into our main module, into our app module, I need to export this readily configured router. So I will add the exports array here and simply export router module. Now important here without calling for root, because we already did that. Now it's really all about exporting this configured router. With that configured and exported here, we can go to the app module, and here in the imports array, we should import our app routing module, and of course also add this import here at the top, so that you make sure to import app routing module from /approuting.module from this file. With this, routing was added to the application. Now we need a place for Angular to render our routes. So that is something I will set up right now in the app component. Here, where we currently use our ngIf trick to decide which route should be loaded, well, here I will remove this approach and instead add the router outlet to mark the place where the Angular router should render the component we should load depending on the path we are at. With that, we got a place to load our routes. Now, we got no links as of now, we will add them soon, but let's first check if this all works. So with ngserve running, I will save this to trigger the recompilation, and then I will have a look at the running app. Here we get an error, and the error message gives us a hint on how to fix this. But what's the issue? The way we configured it, we will always redirect the router, because the default matching strategy of the router is for the path, it will see if it's a prefix of the current path. And the empty path, which is our redirect route, if you check it here, this route here, uses an empty path, and therefore this is part of any route we visit, because again, the default matching strategy is prefix, so it will check if this empty path is a part of the total path. And of course it is, it's part of every path. So that wasn't a problem when we were redirecting from, let's say, something to somewhere else, because now we had a very specific path, and of course we would also redirect something / anything else, but it would not be part of every route. Well, an empty path is part of every route. It's easy to be fixed, and actually the error message told us how to do that. We have to add the path match property here and set this to full. This overrides the default of prefix and says now only redirect if the full path is empty. So we won't redirect on any other paths. With this, if we save this and we reload the page, here we see this now works and we were redirected to recipes. I can demonstrate this if we reload the page. Again, we're gone to recipes. And if I try loading the shopping list path, that also works. So navigation works. Now the goal is to hook up the links in our navigation, because that, of course, right now is not working anymore. In the last lecture, we added routing. We set up our routes for this application and we can load them, but the links are not working as expected, so we should fix this. With our main route set up, we can go to the header component. And here I want to change the way we navigate. I no longer need the click listeners here. And also I don't need the ref elements. So we should remove that so that our app doesn't reload. Because right now if you click the links, it will simply send a request to the server and reload the page. So remove that. And I can also remove the onSelect method here and remove the event emitter, the header component. So basically all that code, also the imports. And now we can simply use router link. And here I want to create an absolute link to /recipes. And for the shopping list, here I will create an absolute link to /shopping list. And of course, you could also use that alternative syntax taught in the last lectures, in the last course section actually, where you would enclose router link into squared brackets. And then you would pass an array between the double quotation marks here to configure the individual segments of your path. But since here all I want is to go to these root routes, there is no need to do so, and that is the quickest way of setting up our paths here. So with that, if we save this, we should already see that navigation is working again, and it is, that's great. But I also want to mark the active route here. So that is what I'll work on in the next lecture. In the last lecture, we added navigation, and we are now able to switch between our pages here. That's great. Now I want to mark the active route. And actually, Bootstrap, the CSS framework we're using, gives us a class to mark the active route. If we add this class to the list item which holds the link, it's the active class there. If we save this, now this is marked as active. Of course, it doesn't change because I hard-coded it into there, but this is the class we dynamically need to add. Well, and you learned how to do this. We got a helpful directive for this, the router link active directive. Here we simply define the class we want to conditionally attach to this element whenever the link on this element or nested inside of it, like it's the case here, gets active. So here that would be the active class as we just saw. And the same, of course, for shopping list. So router link active should also be placed on this one. And with this, you see it's still active, but now it switches because now the CSS class gets applied to the correct route. So that's now working. With that, let's make sure that when I click a recipe here, we don't actually reload the app as we do now. If you watch this reload icon next to the browser URL bar, that happens because we still have this ref element on it. So we will fix this and then think about the next steps of our app. In the last lecture, we styled our active links here. Now I want to fix the behavior that whenever I click one of these recipe icons here, we reload the page. And that simply happens if we have a look at our recipe list component, which of course is responsible for displaying the list. Here in the recipe item, which is the individual item we're clicking, we have a link with this ref attribute here. Let's remove it because that will actually send a request to the browser and therefore reload our page. If we remove this, you see now I can click it, but now we no longer got the cursor, which looks like a hand. We can quickly add this manually though by simply adding style and then cursor equal to pointer. And now we should have the pointer, which clearly indicates that we can click this, but now we don't reload the page anymore. Now for the dropdown here, we should also make sure that all these links are not reloading the page, because right now they are. And that is something we have to fix in the recipe detail component. Here, we also need to remove these ref elements here. And I already added the style with the cursor, which is set to a pointer to the first anchor tag. Let's also add it to the other two. And with that, that should be fixed too. Now, if we select something here, we don't reload. Let's now also do that for the dropdown. Right now, clicking the dropdown also reloads the page. That, of course, has to be fixed in the header component. And here, we reload the page because our dropdown also has this anchor tag or this ref attribute on it. So we should get rid of this and then maybe also implement this style cursor pointer setup to get the right mouse cursor. Let's also do the same for the individual anchor tags inside of that dropdown. So I also removed ref there and added my own cursor style. So with that, this now all works fine. Of course, the dropdown doesn't do anything. We'll add this later, but the app is working again. And therefore, we made a big step into the right direction. So with this all added and set up here, our root routes seem to be working fine. But now I want to change the way we load the recipe when we click on one here in the list. I actually want to load that via child routing. When we click new recipe, I also want to load the to be created recipe edit component here on the right, where we now have the detail component. And the same for the case that we click edit here. So that is something I definitely want to add. I want to add these routes, these child routes. So that is what we should work on next. As mentioned at the end of the last lecture, the next goal is to implement child routing for our recipe routes here. So that when we click a recipe here, we actually load it by adding, let's say, slash, and then the ID of that recipe in our recipes array here. In the URL. So recipes 1 would load the first element, or recipes 0 actually, since we started 0 in the array, and so on. So that would be great if we could load our recipes like that and render them here then. So with a child router again. And the same for new recipe and edit, but for that we will need a new component. Let's implement this in a second step. The first step should be to make these items clickable and load the detail component as a child route here in a new router outlet probably. We will also need another new component then for the case that we first visit our page. In this case, we should have a starting component which kind of says, please select a recipe. Something we right now do by displaying this template here in our recipes component, here the ng template, but that will then also be removed because all I want to have inside of this div with the callMD7 class here is our router outlet. So again, this is a challenge for you. Try implementing this child routing, or at least try to do the first steps of that, setting up the router, creating that component which basically says please select a recipe, and then loading either that component or the detail route, the detail component, depending on whether we click the recipe in the list or not. Certainly a challenge, but also something where you can practice a lot of the things we learned in the last lectures. Starting in the next lecture, we will do this together, so then you can see my approach on implementing this. So, were you successful? Here is my solution. As I said, I want to implement child routes. So I will do this by going to the app routing module here, and on my recipes, I'll add the children property. Now, children also takes an array of routes, and each route still is just a JavaScript object. Here, the first route I want to have is the empty path, so that we just visit /recipes/nothing, the default case. Here I want to load that new component I was referring to, which will simply hold the text we have in this ng template for now. Now for this I will quickly create this component, and I'll use the CLI for that. With ng-gc I can generate a new component, and this component should now go into the recipes folder, so recipes, and then slash, and here you may simply choose that folder. So recipes, and I will name it recipe start, so the recipe start component. with spec false, I prevent this spec file from being generated. So with that, we got our recipe start component here. And as I mentioned before, all I will do is I will output here, maybe in a h3 tag now, please select a recipe. So really simple. With that set up, with our start component set up here, I now want to use that. It has been added to app module automatically by the CLI, so make sure that this is the case. And now in the app routing module, here, I will load this component. So the recipe start component, this one here. Make sure to add the import at the top from /recipes/recipe start component. And with that added, we got our first component, which can be displayed inside of our recipes component. Let's try this out, because that should be all we need to get started with it. In the recipes component, because again, this is, and that's important, this is the component, the recipe component here, is the component where our child routes are registered. So it is in this component's template that we need to provide a router outlet for the child routes to be rendered. So I will do this here. I will add a router outlet here. And when I save this with ngserve running, this looks pretty good. We see please select a recipe, and clearly that is not a paragraph anymore, so it seems to be our new component. Of course, if we click somewhere, that doesn't work anymore, because we only have the router outlet there. Our old logic of loading a recipe is completely broken, but we will restore it soon. Actually, we can already take the first step for restoring that functionality. I'll add another path here to the child routes of recipe component. That path should be :id. So a dynamic segment added after /recipes. That's of course something you have to keep in mind. All child routes always come after the path of the parent route. So all these routes here will have /recipes in front of it. So add /recipes/id, with id being a dynamic parameter. Here I want to load my recipe detail component. We also need to add the import to that component up here, of course. So from the recipes folder, then recipe detail, and then the recipe detail component file. With that, we now at least have a route which would allow us to load this component. And we can kind of see this in action if we manually enter 1 here, let's say. It tries to load the recipe detail component. Of course it will break, because there we try to output data which we no longer get, because our old logic of transferring data from the list item to the detail component doesn't work anymore. But we'll fix it, and we'll actually start fixing it in the next lecture. In the last lecture we started adding our child routes, and now loading the recipe detail component doesn't work anymore. The reason for this is that here we use recipe all over the place, and that's a property of this component, but it's a property set through property binding with add input in front of it, so it awaits to be set from outside the component. Since this component is set through routing though, this won't work anymore. So we have to change how we receive the recipe here, how we set the recipe. And we can change it because keep in mind, in our route, which we define here, we pass this ID, which is a dynamic parameter. So we should be able to load a recipe by the ID, which will simply refer to the position in the array of recipes. So here is your challenge. Try fixing the recipe detail component to somehow use that ID to update the recipe which is displayed, to fetch it from the recipe service. Of course, you will need to implement some method in the recipe service which allows you to get that. Here is your chance to pause the video. Thereafter, I will solve it together with you. So, were you successful? Let's fix it together. In the recipe detail component, we clearly can remove add input, because that's not how we receive the value anymore. So we can also remove the import of add input. That of course also means, before we forget it, that in the recipe item component, we can remove the onSelected click listener here, because that will not be how we pass the value anymore. And of course, we could also remove the onSelected method here. That is something we don't need anymore. Of course, that also allows us to remove the recipe service from this component and remove the import. So we're cleaning up quite a lot here. In the recipe list component, we don't have to change anything. And in the recipe component itself here, we already did make a change and add the router outlet. So now in the recipe detail component, we somehow need to get our single recipe. And we know that we will get the ID from the router. So let's first fetch this ID. And you learned that for this, we need to get access to the activated route. So let's inject it here of type activated route. Make sure to add this import here from @AngularRouter. This import is important to enable TypeScript to identify the type you're trying to inject here, and with that Angular is able to use it. So now we get this route, and now we have two ways of retrieving the ID. The first one would be to simply bind it to this route snapshot params ID. But this will only work for the first time we load a detail component. Now keep in mind, the menu where we can click on one is on the left. So we will be able to choose a new recipe whilst we still see the details of another one. So we probably want to react to changes in our recipe ID, because that's absolutely possible in our app. So that is not the approach I want to use. Instead, what I want to do is I want to use my route, the params observable, and subscribe to that observable. Now with that, we can react to any changes in our route params, and we will get them here of type params, as we learned, to be imported from @AngularRouter. And now we can really react to a new ID. So we should probably store that ID here in a property of our class. It will be of type number. So we should set this ID equal to params ID, though we know that what we get back here will be a string. So we should cast it to a number by adding a plus in front of it. So now we will have an ID in the form of a number, which we can use to identify our recipe. Well, with this information, we want to load our recipe from the recipe service, and for that we need to change our recipe service, because right now we got no way of loading a single recipe by ID. That's something we can easily implement though. We can simply implement a getRecipe method, which takes an ID of type number, and then we can simply return this recipes and select the item at this index. We could also rename ID to index to make really clear what that number will be in the end. You could also call slice before doing that, because slice would now give you a copy of your array, though it won't be a deep copy, so the objects still are the same anyways, so you can also directly return the object like this. You could of course also create a hard copy of that object with object assign, for example. That's not what I want to do here though, so we return a single recipe. Now back in the recipe detail component TypeScript file, after fetching an ID and storing it, I want to fetch the new recipe. And I will later also show why I needed to store the ID here. So let's fetch the recipe using our recipe service whenever the ID changes. Then I will call getRecipe and pass my ID as an argument. And with that, we should be able to indeed make our application to work again. By going manually to recipes 0, we indeed see the detail view for the schnitzel and with 1 for the burger. So that is working. Now we also need to enable these links here to work again, because right now they're not doing anything. With our child routes added in the last lecture, let's now make these links work again so that we can really choose an item from that list. The place to make these links work, of course, is in our recipe list, the recipe item here. that is where we have the anchor tag, and that is where we should set the link. We can set a link with router link, but now we get a dynamic segment in the path. So now I will bind router link with squared brackets, because now I want to pass this array which allows me to really configure segment for segment of my path. Now the first segment is also the only segment that will be the ID I want to load. So I will use a relative path because this element here, the list, already is loaded at /recipes. So whenever I just add the ID here, that is already all I want, because then we're going to end up at recipes/ID. Now, to get the ID, I need to pass this extra information to the recipe item component. We're not doing this right now, so let's do that. I will add a new property binding here. So I will add the index here, and the index will simply be a number, and I will add input at the beginning. With this, I can now pass in the index of this item from outside, and I'll do this from the recipe list component. Here, besides sending the recipe itself, I can now also pass the index, and of course I have to retrieve that from my ng for loop. So here I'll simply bind I to index to get the index of of each iteration basically. And then I'll pass this index I to the app recipe item and bind it to the index property there, this property we just created. As a side note, with the ID being passed to this component now, you theoretically could update this component to now use our recipe service and the getRecipe method we just created to fetch the recipe by ID. But I will leave it as it is here, but that would be one way of refactoring or restructuring this component. The important thing for us now is that we have the index property in this component now. And that is all we need for this link. So I want to pass the index here, and keep in mind, this is for a single component, so that index will be different for each instance of this component. So if we save this, we can see it already at the bottom of the page. This looks all right. And I can switch between 0 and 1. So that looks pretty good. Now it would also be nice to style the active item here though. And that is something I'll do in the next lecture. In the last lecture, we made our child routes links here work again. Now let's make clear which one is selected by marking it. We can mark the active link by adding, manually, the active class to it. If we do this, all are marked as active, because of course it's added to every instance of this component, because I hard-coded it in there. So that's the right class, but of course we should add it dynamically with good old router link active directive. And here I simply want to pass active as the class name, because we just saw this is the CSS class we need to add, and with that it's working as expected. And this is all we needed here. You also see that recipes is still marked as active at the top, because we still are at /recipes and then at a child route, but that doesn't matter for this to be marked as active because it's not set to exact matching, and actually we want the behavior we have right now. So that all looks pretty good. Now we can move on to make sure that we can click this new recipe button and this added recipe button and actually do something once we do click them. So with child routing almost finished, let's make sure that we can create new recipes and that we can edit the existing ones. So for this, we need a new component. So let's generate this first. I'll use the CLI again with nggc, and I want to store it in the recipes folder. And here I will name it recipe edit. And I don't want to create this spec file, which is why I set it to false. So with this, if I shrink down the other files, we get this new recipe edit folder here with the recipe edit component. We'll work on the content of this file after the forms section, but I already want to load it and I want to retrieve the route parameter. So to load this, what I will do is I will go to my app routing module and I will register a new route here. The first route is for a new recipe. So maybe new would be a good path so that we have /recipes/new in the end. And with that, we could load our recipe added component here. And of course, you need to add the import here from the newly created recipes/recipe added folder. Also make sure that it was added to the app module. And this is done automatically as always by the CLI, but you need to ensure that it is added to declarations and as an import here at the top to have it work correctly and to be able to load it. So with that added here, we have our new recipe route. Now I'll duplicate it to also have a :id/added route maybe, so that we have the ID available in this route because we need to load it, but I want to have a /added at the end so that it's clear that we're in added mode. And this is the same component. That's also the recipe added component. I will, in the component, determine whether we are in added mode or not. Now with this setup here, if we go back to the application and we enter /added after this, we see recipe added works. So that's great. But we will see something maybe unexpected if I try to go to /recipes/new. Now we try to load the detail component and therefore we get an error because it basically failed to get a recipe with the ID new. And that's exactly what went wrong here. If we visit recipes/new, due to the way how we ordered our routes, it will try to parse new as an ID, because the route with the dynamic ID parameter comes before the route definition where we have new hard-coded into the path. So we should switch these two routes so that the new route comes before the route with the dynamic parameter. Otherwise, how would Angular know if whatever we passed right now should be interpreted as the new hard-coded path or as a dynamic parameter? So with this order, now we should be able to load new without any issues. If we hit enter, that looks all right, and we can also still load the existing recipes. So with that, these paths are set up too. The missing piece is now to retrieve the ID in the recipe added component and to determine whether we are in added mode or not. So we added our routes for the added component. Now let's go to that component and retrieve the ID and therefore determine whether we are in added mode or not. I will inject the activated route in there as you learned it before from @AngularRouter. And an ng on init, this is a good place to now retrieve the ID. As before, I want to do this dynamically, so I will use my route and the params observable and subscribe to that. And here I will receive my params, which are of type params. And here I then want to retrieve the ID on which I'm currently working. I will store the ID here in a property named, or not named ID, but of type number. So here I will set this ID equal to plus to convert it into a number, params ID, because that's the name of our dynamic parameter in our route setup, right? With that, we retrieve that ID here, but I also want to find out whether I'm editing the recipe or creating a new one. I actually want to store this information in a new property, added mode maybe. I'll set it to false initially, so initially could say we assume that we are creating a new recipe. We are not in edit mode. Now I will check this whenever the parameters change. Then I will assign a new value to edit mode. And here I will simply assign the value of the following check. I want to see if params has an ID property. So if it has one, then this will actually be a string with the ID. Otherwise it will be undefined. So by comparing it to null and checking if it is not null, I'm checking does it have the ID. Because params, and that there the ID, will only be not undefined if we are in edit mode, because then an ID will be present. If this check returns true, so if the ID indeed is undefined and therefore equal to null, this will return false because I'm checking the opposite. and therefore we are in new mode. And we can check this by simply logging it in the console here, edit mode. Let's see if this works. We're at 0 edit here, and it returns true. And now we're at new, and it returns false. So that seems to work. This is a nice way of checking in which mode we are. So with that, we are able to retrieve the ID of the element we want to edit and to find out whether we are in edit mode or not. Now I want to make this edit link here work and the new recipe link, because these are both things which are not working as of now. Let's work on this next. And actually, this is a nice challenge for you. Make these links work. Make sure that when we click this link or this button, we get taken to the recipes new page or the recipes edit page for that respective recipe we had loaded. It's a nice challenge for you. In the next lecture, we can review my solution together. So were you successful hooking up these buttons? Let's do it together. I want to start with the new recipe button. And for that, I'll go to my recipe list component, which is where I have this button here. And I simply want to add a click listener to it. On new recipe could be a fitting name. So let's copy that name and add it to our TypeScript code so that here we have the method which will get triggered. And now I need to inject the router to be able to navigate to this route I want to go to. So I'll add my router here of type router to be imported from @AngularRouter here. So I'll add this import. And with that, in on new recipe, I simply want to target or use my router to use the navigate method to target this path I want to go to. Now, which path is that? We already are on /recipes here. Keep this in mind because we're on the recipe list. So I can use a relative route and simply add new to it. Now, to be able to use a relative route in the navigate method though, we also need to inform the router about our current route. So let's inject this too. Here the route, of course, of type activated route needs to be added. An activated route should also be added from the @AngularRouter package. And then I'll add my JavaScript object, add the relative to configuration, and point to this route, to my current route. With that, let's see if that works. Back in the application, let's try this new recipe button. That looks great. So let's try going to just recipes, works, select a recipe, works too. So that is indeed working as expected. Now we should do the same basically for the edit recipe, though there we also need to pass our ID. The recipe detail component is of course the place where we have this link here, the edit recipe link. So I'll add a click listener and say on edit recipe here. I'll also copy this name into the TypeScript code of the edit recipe component, like this. And then here we also need to get access to the router so that we can call the navigate method. So let's inject it of type router as before. Make sure to import the router from @AngularRouter. And now that is why I stored the ID in this property here. With that stored, I can now use my router here to navigate. And I want to navigate, well, basically to the current ID and then add it. Now I could simply add it to the current route. So let's add relative to here, this route. And let's see if this works as expected. If I click edit recipe, we go to 0 edit and the same for 1. So actually we don't need the ID here in this case then. Why did I get it then? Well, simply for demo purposes. This is an absolutely fine way and probably the way you will navigate. The alternative though, and just to show this how that would work and to practice this, is to use navigate. And now let's say we move up one level and then we want to add our ID again, so this ID, and then add it. So now I'm deliberately constructing a more complex path, simply to show how that would work. So now that is also relative to our current route, so this route. And with that, you should see that it still works, because what we do is we go up one level, so to just /recipes in this case. Then we again add our ID and then add it. And we should see that if I click this button again, even if we reload the app to be sure that it did indeed update, it works as before. Now with a more complex setup. Again, you would probably use the first one, which is, well, comment out the second one. I just wanted to highlight again how that works, how you can use that more complex navigation and also navigate around with this go up one level command you see here as the first segment of this more complex path. However, again, just adding edit to the relative, or to the current route, I should say, is of course the straightforward way. In the last lectures, we added a lot of routing functionality to our app. It's looking pretty good. We got all the main pieces tied together. One thing I want to bring to your attention again is we are subscribing to params here in the detail component and in the edit component. Now, as I explained, you don't need to clean up the subscription here. I just want to bring it to your attention again. In other cases, where you use your own observables you created and not managed by Angular, therefore, you will need to clean up this subscription. So definitely keep that in mind if you work with your own observables. Here for now, we can simply proceed with this setup and let Angular do the cleanup work.